Good morning. It is Saturday, 9 a.m. in Texas. This is going to be a fun live stream, so thanks for joining us. We'll get started here in just a minute. Okay, good morning. Thank you everyone for joining. This is Ham Radio 2.0, and this is our first ever technician live stream with the question pool that just updated for the next 4 years. We've got a brand new question pool that updated last July, and this session is going to be an all-day live stream going through the No Nonsense Study Guide written by Dan Romanchik, KB6NU. He's going to be teaching us a one-day technician course today. At the end of the day, we will have an option for you to go take your test. You can choose to do that, or you can choose to continue studying on your own and test later at a later date whenever you want to. Some of that will be talked about during this session, and that is the thing. We've got a Zoom webinar going on the back end. If you signed up previous to the email, there is a Okay, Norm, I'll unmute myself so you can hear me on Zoom. If you sign up on my email list, there was a link sent out yesterday and again this morning for a Zoom webinar. So you guys will be seeing that real time in the back end of the Zoom webinar, but it will also be live streaming on YouTube for everyone else to participate in as well. So if you have a question throughout the process, and be respectful of Dan, he's got a flow he's going to go through, but he said he does take questions during the presentation. So if you have a question in Zoom, you can raise your hand and we can acknowledge you. We can allow you to speak so that everybody else can hear you. And then we answer that question and just move on. So we don't want to spend too much time on questions because that just prolongs things, but we do want you to ask questions. So that's why everybody's here, is to learn. So without further ado, let me switch it over to Dan here. Dan, you want to take your screen off for just a second so I can introduce you, and then you can just kind of take the reins from there. Let's go right there. And there we are. What's up, man? How are you this morning?
I'm good. You?
I'm pretty good.
It's
cold.
good.
It finally got cold in Texas like 2 days ago. So it was like 37 degrees out this morning. So I know Michigan's probably colder than that.
A little bit.
So cool. So any quick advice or instructions before we get started?
Well, so I just say that, this is a little bit of an experiment for both of Jason and I. Mm-hmm. I've taught online classes, but I've split it up into 4 sessions. So this is going to be a long day. Mm-hmm. And as he's mentioned, or I think you've mentioned already, this is going to be recorded and on his YouTube channel, so that if it gets a little too much for you, feel free to drop out. You'll be able to review the lessons online. And I put my email address on every slide, so you can always email me with questions too afterwards. Other than that, we'll just jump right in.
Perfect. Sounds good. Okay, I will let you have it, and we'll go from there. Thanks, Dan. This should be a really fun stream.
We'll find out.
We'll find out, right? Yeah, totally. All right.
All right. Now.
There it is. Perfect.
Okay, so I'll just say right off the bat, if you haven't done so already, which some of you may not have, you want to download my study guide. It's a free PDF file from kb6nu.com/study guides. And I follow the study guide from front to back. In a way, it's the study guide was created to go with this class. Next thing I'll say is this class really isn't going to teach you everything you need to know, right? There's so much to ham radio that there's no way we can do it in 6 or 8 hours, however long this session takes. So the way I want you to think about this is you're getting a license to learn, right? Because, I've been a ham a long time and I'm still learning stuff. So, if you go into it with that kind of attitude, I think you'll do okay. So let's talk a little bit about the test. there's 413 questions in the question pool. And in this class, I'm going to talk about every single one of them. That doesn't mean you'll remember them all, but I'm going to talk about every single one of them. On the exam you take, there'll be 35 multiple choice questions, right? And you need to answer 26 of those correctly. That's a percentage of 75%. So you can get 9 questions wrong and still pass the test. So keep that in mind. So you don't have to know everything. If you haven't already found a test session, a session at which to take the test, here are 2 URLs to let you find a test session that's either near you or online. Tests are administered by what we call volunteer examiner coordinators, and some of them are still offering online test sessions. So if you're in a place where you can't take it in person, you can schedule it online. All right, so let's get right into it. So I cover the technical stuff first because I find that if I try to cover it later in the class, people are already falling asleep, and that's not good. So the first thing we want to talk about is this simple electric circuit, and what are some of the parameters of this electric circuit. In any electric circuit, you have 3 parameters. You have the voltage, which is provided by this battery. You have resistance in the circuit, which is shown by this resistor. That's the schematic symbol for a resistor. And if you connect these 2 components up in this way, a current will flow through the circuit, and we use the letter I for current. Voltage, and in fact, I should have wrote this as E. Sometimes we write this as E for electromotive force, and it's measured in volts. So you have a 9-volt battery, you'll see the symbol 9V. Resistance is measured in ohms, and we sometimes use the omega symbol to denote ohms. Current is measured in amperes, and we use the letter A for amperes. So the question on the test, what is the electrical term for the force that causes electron flow? Answer, voltage. Question, what is the name for the flow of electrons in an electric circuit? Answer, current. Question, electrical current is measured in which of the following units? Amperes. And on the test, you'll always see amperes written out, either with a capital A or without. Volts will always be written out, as will ohms. So we call this circuit a DC circuit. DC stands for direct current. In a direct current circuit, the flow of current is always in one direction, from the positive terminal of the battery to the negative terminal. However, if you think about your the electric supply in your home, the plug in the wall, that's alternating current. And let's take a look at that. So in an alternating current circuit, the voltage actually changes continuously. It goes from 0 to plus to minus, and concurrently with that, the current will change. It'll flow in one direction, then flow in the other. Like I say, that's what you get out of the wall socket. You get an alternating current. So question, which of the following describes alternating current? Answer, current that alternates between positive and negative directions. And you can see that from here. Question, what describes the number of times per second that an alternating current makes a complete cycle? Answer, frequency. So as you can see here, a complete cycle is when the waveform starts at 0, goes either positive or negative. Here I'm showing it going negative first, then going to positive, and then back to 0. This is one cycle. The number of cycles per second is equal to the frequency of the wave. And in the case of the AC in your house, it's called 60 hertz. Hertz is a cycle per second. And that's the next question. What is the unit of frequency? Answer, the hertz. And that's spelled out too. This was named after a physicist named Heinrich Hertz, who was the first one to actually demonstrate radio waves. All right, let's go back to. So, oops. As we said, this is the resistance here, right? And the unit of resistance is the ohms. So question, what are the units of electrical resistance? Answer, ohms. And question, what type of current is opposed by resistance? Answer, all these choices are correct. Direct current, alternating current, and RF current. So a resistor, we show it here in a DC circuit, but you also will have it in AC circuits and RF circuits. Now, oops. So we have voltage, current, and resistance. So the nice thing about this is that these form, there's a set relationship between these three units, and this is called Ohm's law. E equals I times R is the basic form of that equation. But if you use some simple algebra, you get the other forms of the equation. R equals E over I, and I equals E over R. About 10 years ago, I was teaching this class, and I said that same thing. I said, well, the basic form of the equation is E equals I times R. And by some simple algebra, you can get these other two forms of the equation. And I had two kids in the class. They were brothers, about age 10 and 11. And one of the kids said, yeah, but we haven't had algebra yet. I thought that was hilarious. And so they're right, but I paid special attention to them throughout the class, and both of them were able to get their licenses that day. So I felt pretty good about that. And, if these two young guys are able to do it, I'm sure you'll all be able to do it too. So I like to tell that story. So question, what formula is used to calculate voltage in a circuit? Well, that's this equation. And the answer is E equals I times R. Question, what formula is used to calculate resistance in a circuit? That's this equation, R equals E over I. Question, what formula is used to calculate current in a circuit? Answer, I equals E over R. Now, let's look at some examples of this. Question, what is the resistance of a circuit in which a current of 3 amperes flows when connected to 90 volts? So we want to know the resistance, right? So we're going to use this equation. So R equals, and E is in this case is 90 volts. Divided by 3 amperes. So the answer is 30 ohms. And like I say, these will always be spelled out on the test. And so in the next couple of examples, I'm going to shorten it so I don't have to write all that stuff down. I can make it a little bit bigger. Next question. What is the resistance of a circuit for which the applied voltage is 12 volts and the current flow is 1.5 amperes? So again, we want to know the resistance. And in this case, we've got 12 volts divided by 1.5 amperes. So the answer is 8 ohms. Whoops, 8 ohms. Now, this brings up a point. If you can't do this calculation in your head, you can use a calculator on the test, but you have to be able to show the examiners that there's nothing stored in memory. Okay, but you can use a calculator on the test, and for this question, it makes it a little easier to use a calculator. Next question. What is the resistance of a circuit that draws 4 amperes from a 12-volt source? So again, we've got 12 volts. In this case, the current is 4 amperes. So that means the resistance is 3 ohms. All right, let's look at some other questions now. Question, what is the current in a circuit with an applied voltage of 120 volts and a resistance of 80 ohms? So here they want to know the current. So we'll be using this equation here. The voltage is 120 volts. Divided by 80 ohms. So the current is 1.5 amperes. And again, this is one of those questions where you might want to have a calculator for it. Question, what is the current through a 100 ohm resistor connected across 200 volts? Well, 200 volts divided by 100 ohms, that's 2 amperes. And you notice the questions are worded a little differently, but it doesn't matter. If you know the value of the parameter, in this case 200 volts and 100 ohms, you just plug it into these equations and you'll get the correct answer. Question, what is the current through a 24 ohm resistor connected across 240 volts? So here we got 240 volts, 24 ohms, it's 10 amperes. All right, let's look at the next and the final form of the equation. Question, what is the voltage across a 2 ohm resistor if a current of 0.5 amperes flows through it? So we're going to be using this equation. We've got 2 ohms. Well, let's do the amps first. 0.5 amps times 2 ohms. Well, 0.5 is a half times 2 is 1 volt. Question, what is the voltage across a 10 ohm resistor if a current of 1 ampere flows through it? So in this case, we got 1 ampere times 10 ohms And the answer is 10 volts. Question, what is the voltage across a 10 ohm resistor if a current of 2 amperes flows through it? Well, this is just almost the same question, except we had twice the current, right? 2 amperes times 10 ohms, 20 volts. All right, so this really isn't too hard. And like I say, you might want to use a calculator for some of these questions, but I think in general, you're probably can get by without even using a calculator. And like someone mentioned before, before the class started, chances of you getting a math question on the test, you'll have maybe 1 or 2 on the whole test. So don't let the math get in your way. All right. Now let's talk about series circuits. In the other circuit, we only have one component. We have one resistor. Well, in a series circuit, you can have two or more components. And we call this a series circuit because the components are in series with one another. Now, the thing you want to know here is the current will be the same through, whoops. Hang on. The current will be the same through both components because there's only one path for the current to flow. So the question is, in which type of circuit is DC current the same through all components? Answer, a series circuit. Whoops. Okay, let's take a look at the parallel circuit. And a parallel circuit's a little different because it has two paths for the current to flow. So the current comes out of the battery and then splits into two separate currents. What the thing you need to know about a parallel circuit is that the voltage is the same across both components, right? There's the battery. The voltage here is the same as the voltage here. So the voltage is the same across both components in a parallel circuit. And that's the question. In which type of circuit is the voltage the same across all components? Answer, parallel. Now, in all these circuits, we're connecting these components. We connect the battery to the resistors with wires, right? With metal wires, usually copper wires, right? That's because copper is a good conductor. We say that when we say a wire is a good conductor or a metal is a good conductor, we mean that it has a low electrical resistance. So the question on the test, why are metals generally good conductors of electricity? Answer, they have many free electrons. So that when you connect that battery to it and it exerts that voltage, all those free electrons can flow in the circuit. Now, a lot of times we don't want current to flow in a particular spot of our circuit. In that case, we use insulators. Insulators offer a very high resistance to electric current. And, like I say, they're useful in lots of different places too. So question, which of the following is a good electrical insulator? Answer, glass. The way I suggest remembering the answer to this question is if you can remember those big old glass insulators they used to use on power lines, That's the way to think about it. And those things were made of glass because they're very good insulators. All right. Moving right along. Now let's talk about power. Yeah. Power is sort of similar to Ohm's law in how you calculate it. There's these equations. The main equation is power is equal to current times voltage. And let's take a step back. What is power? Power is the rate at which electrical energy is generated or consumed, right? So if you think, we have a 90 watt or 60 watt light bulb, right? That means that every second it's consumed, the electrical light bulb turns electric current into light. So it's consuming that energy and turning it into light energy. And the way we would figure out what the power is and being consumed by that light bulb is by measuring the voltage, measuring the current, and then multiplying the two together. So P equals E times I. Conversely, we can use the simple algebra again to get other forms of the equation. So in this case, you don't need to know both of them like you did with Ohm's law. You only need to know this second equation here, and current equals power over voltage. So if you knew the power being generated or consumed and the voltage at which the circuit is operating, then you can calculate how much current is flowing through the circuit. Okay, so let's take a look at some examples of that. Oh, well, let's get to the questions. Answer. Question: which term describes the rate at which electrical energy is used? Answer: power. Electrical power is measured in which of the following units? Answer: watts. And if you think all these unit names sound like actual names, then you're right, because all the Ohm was George Ohm. He was an English physicist. Amperes was named after Henri Amperes, who was a French physicist. Watt was an English physicist who was credited with inventing the steam engine, or at least making it more practical. In that case, this is kind of interesting. So the watt was first used for mechanical energy, but we can also use it for electrical energy. So that's why it's watts. Question: what is the formula used to calculate electrical power in a DC circuit? Answer: P equals E times I. Let's look at some examples. How much power is delivered by a voltage of 13.8 volts DC and a current of 10 amperes? Well, we're going to use this equation. 13.8 volts times 10 amperes. It's 138 watts. Question: how much power is delivered by a voltage? Well, we just did that one. How much power is delivered by a voltage of 12 volts DC and a current of 2.5 amperes? So we got 12 volts times 2.5 amperes, and that's equal to 30 watts. Now, I often get asked, why do we want to know this? Okay. Well, there's very good reason. Say you have a transmitter that's capable of transmitting at 50 watts, right? And you're going to power that with a 13.8 volt DC power supply. Well, how much current does that power supply have to deliver? put it into these equations, and you'll know the answer. In this case, it's a little bit less than 4 amps. However, there's other considerations, and we'll talk about this later. Since your radio is not 100% efficient, you really need more than 4 amps. But that's how you need, 50 watts divided by 13.8 to deliver 50 watts. So let's look at this other equation now, an example for this other equation. Question: how much current is required to deliver 120 watts at a voltage of 12 volts DC? Well, I equals P over E, right? So we got 120 watts divided by 12 volts. It's 10 amperes. Yep. All right. Moving right along. This next topic, we're going to talk about scientific notation. And the reason we talk about this is that in amateur radio, well, in science in general, some quantities are very large and some quantities are very small. And by using scientific notation, it simplifies the calculations, right? Instead of saying your computer has a disk drive with 500 billion bytes of data, we say, well, it's got 5 gigabytes or 500 gigabytes. Same with all the rest of these quantities here. In these notation specifies sort of a multiplier for each unit. For example, a kilo is 1,000 of something. A mega is 1,000,000 of something. A milli is 1/1000th of something. A micro is 1/1,000,000th of something. So, these are the units we were dealing with. And the questions on the test deal with converting between these units, right? So all these questions deal with converting between, say, gigahertz and megahertz, or microfarads and picofarads. And let's take a look at how this works. All right. So question: how many milliamperes is 1.5 amperes? Okay. So .5 amperes is equal to how many milliamperes? Well, a milli is 1/1000th of something. So there's 1,000 milliamperes in 1 ampere. And we've got 1.5 amperes. So if we multiply this by 1,000, we get 1,500 milliamperes. And this is written out on the test, or in the exam. Question: which is equal to 1,500,000 hertz? So we got 1,500,000 hertz. And the answer for this question is in kilohertz. So since there's 1,000 hertz in a kilohertz, if we divide this number by 1,000, we get 1,500 kilohertz. Question: which is equal to 1 kilovolt? i.e., how many volts are in a kilovolt? Well, a kilo is 1,000 of something. So it's 1,000 volts. Question, which is equal to 1 microvolt? So you got 1 microvolt. And I'm going to use the little mu symbol here. Well, I won't. I'll take that back. How many volts is 1 microvolt? Well, it's 1/1,000,000th, right? So it's, in fact, I think they even spell this out. 1/1,000,000th of a volt. Or 0.000001 volts. Question, which is equal to 500 milliwatts? And in this case, the answer is in watts. Well, a milliwatt, or 1 watt, is equal to 1,000 watts. 500 is a half of 1,000. So this is 0.5 watts. And here's another thing you notice, aside from the millivolts, all these are related by a factor of 1,000 so far, except for this millivolt one. That's a factor of 1,000,000. Question, which is equal to 3,000 milliamperes? What they want to know is how many amperes is that? Well, 1,000 milliamperes in an ampere. Divide 3,000 by 1,000, and you get 3 amperes. You know, in a lot of these sections, there's sort of like questions out of the middle of nowhere. And this next question is one of those. Question, what is the abbreviation for kilohertz? So that's just KHZ. K for kilo, HZ for hertz. And 1 kilohertz equal to 1,000 hertz. What is the abbreviation for megahertz? Well, that's MHz. The reason we put those questions in there is the next set of questions has to do with frequency conversions. Question, which is equal to 3.525 megahertz? And basically, they want to know how many kilohertz is that? Well, since there's 1,000 kilohertz in a megahertz, if you multiply this by 1,000, you get 3,525 kilohertz. Question, which is equal to 28,400 kilohertz? And what they're asking for is how many megahertz is that? Well, 1,000 kilohertz in a megahertz, divide this by 1,000, you get 28.4 megahertz. Actually, 28.400, which is the same, right? Question, which is equal to 2,425 megahertz? How many gigahertz is that? 1,000 megahertz in a gigahertz, divide this by 1,000, you get 2.425 gigahertz. Now, we have one question about capacitance. The unit of capacitance is the farad, which we use the letter F for that. It's named after Michael Faraday, who did a lot of work with electromagnetic stuff. Question, which is equal to 1 million picofarads? 1 million picofarads. Well, there's 1,000 nanofarads in a picofarad, 1,000 microfarads in a nanofarad. So there's 1 million microfarads or 1 million picofarads in 1 microfarad. So the answer is 1 microfarad. I hope that makes sense. But this is an indication of why we use scientific notation, because a picofarad is a very small quantity, but that's we often use picofarad value capacitors in radio circuits. One thing you want to keep in mind here is that the units are always the same, right? 3.525, 3525, 28400, 28.400. So just keep that in mind. Yeah, someone asked the question, or it actually wasn't a question. He said, well, to divide by 1,000 or multiply by 1,000, you just move the decimal point right or left, right? So like, for example, we'll take the question, how many megahertz is 28,400 kilohertz? Well, if you move the decimal point, so the decimal point in this number is right here, right? If you move the decimal point over 3 spots, you get 28.400. All right. Good. So let's talk about decibels now. You need to know 3 values. You don't need to know how to calculate decibels, but you don't need to know these 3 values. And basically, decibels are power. We're talking about power here, but decibels can be used to specify any ratio. But in this case, we're talking about power ratios. And all you have to know are these 3 values. So 3 dB corresponds to a ratio of 2 to 1. 6 dB corresponds to a ratio of 4 to 1. And 10 dB corresponds to a ratio of 10 to 1. Okay? So let's look at the questions here. Question, which decibel value most closely represents a power increase from 5 watts to 10 watts? So we got 5 watts to 10 watts. Oops. Well, that's a ratio of 2 to 1, right? So the answer is 3 dB. Question, which decibel value most closely represents a power decrease from 12 watts to 3 watts? Oops, watts to 3 watts. Well, it's a ratio of 4 to 1, right? So the answer is 6 dB. But since this is a decrease, it's minus 6 dB. So when you have a power increase, the value of the decibel is positive. When you have a decrease, it's a negative value. Question, which decibel value represents a power increase from 20 watts to 200 watts? So 20 watts to 200 watts. It's a ratio of 10 to 1. So the answer is 10 dB. So I often get asked, why do you want to know this? Well, a lot of times the gain of an antenna or an amplifier is specified in decibels. And if you have an idea of how decibels work, then you can calculate or figure out how much gain you'll actually have at the output, right? And we'll talk a little bit about this when we get to antennas, but just keep in mind these three values: 3 dB ratio of 2:1, 6 dB ratio of 4:1, 10 dB ratio of 10:1. All right, let's talk about components now. And the first one we'll talk about is resistors. Resistors are probably the most common component in electronics. They're used to control the flow of current or the amount of current flowing in a circuit. These two are examples of resistors, actual resistors. And up here is what's called the schematic symbol, the symbol we use in diagrams describing circuits. One thing you'll note is that when you have a construction like this, an arrow pointing to the component, that's usually denotes that the component is variable. So this is a variable resistor. And sometimes we call variable resistors potentiometers. So question, what electrical component opposes the flow of current in a DC circuit? Answer, resistor. Question, what type of component is often used as an adjustable volume control? Answer, potentiometer. So let's see how that might work. So if you had an audio amplifier and you were connected to a speaker, you might use a variable resistor here to control the amount of current flowing through that speaker and thereby controlling the volume of the circuit. So this was the case of a potentiometer being used as a volume control. Question, which electrical parameter is controlled by a potentiometer? Answer, resistance. So this would have some kind of resistance. All right. Probably the next most common type of component in electronic circuits is the capacitor. And the capacitor, so this is an actual capacitor. There's many different types of capacitors. This is a ceramic capacitor, so-called because there's a layer of ceramic inside of it. And then this outer coating is also a ceramic coating. And if you turn the capacitor on its side, it would look a lot like the schematic symbol here. There's two plates, two conducting plates, and there's a we call it the dielectric, which is insulating material in there, and that's usually some ceramic. What happens here is if you connect a battery to it, you'll build, and this is the plus side of the battery, right? You build up a bunch of plus charges on this part of the capacitor, a bunch of negative charges on this side of the capacitor. And what happens when you have this sort of configuration? You actually get an electric field inside the capacitor, across that insulator. So question, what type of electrical component consists of conductive surfaces separated by an insulator? Answer, capacitor. Whoop, what happened there? Whoop. Capacitor. What electrical component stores energy in an electric field? Answer, a capacitor. That's the electric field there. Question, what describes the ability to store energy in an electric field? Answer, capacitance. So that's, the higher the capacitance, the bigger the electric field. Or the bigger the amount of charge we can store in the capacitor. That's a better way to think about it. Question, what is the unit of capacitance? Answer, the farad. Again, named after Michael Faraday. So let's talk about inductors now. Inductors, as you can see, are coils of wire, and the schematic symbol shows that it's a coil of wire. So question, which electrical component is typically constructed as a coil of wire? Answer, the inductor. Question, what type of electrical component stores energy in a magnetic field? Answer, inductor. So let's see how that works. We put a battery here. We'll get a current to flow through the inductor. And when the current flows through the inductor, it builds up a magnetic field around the inductor. And that magnetic field will be there as long as the current is flowing through that inductor. Question, what describes the ability to store energy in a magnetic field? Answer, inductance. What is the unit of inductance? Answer, the Henry. And the Henry is named after Joseph Henry, who in this whole pantheon of physicists is the only American in the bunch. Joseph Henry did a lot of work on the telegraph system. And if you think about it, that makes a lot of sense, right? What is the telegraph system? Well, telegraphs, they use coils of wire, and they use the magnetic properties to attract what's called a sounder, a bar of metal that when a current flows, it attracts that bar of metal and makes a click, right? That's all a telegraph is. So Henry did a lot of work figuring out how inductance and the magnetic fields work. All right. And like I said, the inductors are probably the third most common type of component in radio circuits. Now, there's a few questions about batteries here, and I don't have a slide for this. We often use batteries to power our equipment, so that's why you want to know about them. Question, which of the following battery chemistries is rechargeable? So we use a lot of rechargeable batteries in ham radio. Answer, all of these choices are correct. Nickel metal hydride, lithium ion, lead acid. And well, we don't use nickel metal hydride batteries so much anymore. We still do use the other two, lithium ion and lead acid. Question, which of the following battery chemistries is not rechargeable? Answer, carbon zinc. I don't know if you can get any carbon zinc batteries anymore, but if you can, they're not rechargeable. All right. Now let's talk about some more interesting components. At least I think they're more. Whoops, what did I do here? At least I think they're more interesting. So these are diodes. And again, this is the schematic symbol for a diode. This is the actual picture of a small, what's called a small signal diode. There's all different types, and you'll see all kinds of different configurations, but this is perhaps one of the more common ones you'll find. The interesting thing about a diode is that it only allows current to flow in one direction, in the direction of the arrow. So current can flow this way, but not this way. So if you had a battery connected across the diode like this, you'll get current flow. If it's connected in the reverse direction, there's no current flow. So that's an interesting phenomena, and we'll see how that's used in some circuits a little bit later on. Question: what electronic component allows current to flow in only one direction? Answer: the diode. What are the names for the electrodes of a diode? Answer: anode and cathode. Question: how is the cathode lead of a semiconductor diode often marked on the package? Answer: with a stripe. So you see here, there's a stripe on here, and that corresponds to the cathode. And why is that important? Well, if you were fixing or building a radio circuit and it says a diode has to be installed in a certain way, you can't install it the other way and expect the thing to work, because diodes only allow current to flow in only one direction. If it was a resistor, it doesn't matter. You can put it in any old way. It's going to resist. It's going to offer the same amount of resistance no matter which way you put it in. But a diode, you have to put it in the correct way. So one of the things about diodes is they have what's called a forward voltage drop. Yeah, voltage drop. So it's not like putting a piece of wire in here. It's actually going to drop a certain amount of voltage. That's often 0.7 volts for silicon diodes and 0.3 volts or so for germanium diodes. That's the idea behind this next question. Which is true about forward voltage drop in a diode? Answer: it is lower in some diode types than in others. And like I say, germanium diodes have a lower voltage drop than silicon diodes. So one of the types of diodes that's most common is the LED, right? This is the schematic symbol for an LED, or light emitting diode. Question: what causes a light emitting diode to emit light? Answer: forward DC current. So again, let's put a battery in here, and let's put a resistor in here to limit the current. If we connect the circuit this way, current's going to flow and the light will turn on. If we put the battery in opposite, though, no current is going to flow, because LEDs only allow current to flow when the anode is more positive than the cathode, and the light will stay dark. Question: which of the following is commonly used as a visual indicator? Answer: LED. All right. That's it. If you can hear that, that's I have one of these silly bird clocks in my office here, and so that if you can hear that, that's my bird clock. All right, let's talk about transistors now. Transistors are sort of the real workhorse of electronics nowadays. There's two types of transistors, two main types. There's other types, but the bipolar junction transistor, shown on the left here, and the field effect transistor, shown on the right, along with their schematic diagrams. These operate a little bit differently, but their purpose is the same. The purpose is to control the flow of current in a circuit. To do that with a bipolar junction transistor, we actually use a current input, a little bit of current into the base, the B lead there, will cause a larger amount of current to flow from the collector, C, to the emitter, E. The field effect transistor works a little bit differently. It actually uses a voltage on the gate, which is the letter G there, denoted by the letter G there, to control a larger amount of current from the drain, or D, to the source, S. So question, which of these components can be used as an electronic switch? Answer, transistor. So like I just said, if we put a little bit of current into the base of this bipolar junction transistor, then we can get a larger amount of current to flow through the transistor. Therefore, it's sort of acting as a switch, right? And we'll see this a little bit more later too when we talk about the actual circuits. Because we do get a larger current flow from C to E, we can also use this as an amplifier. And what we call the gain of the amplifier, or gain of the transistor, is the ratio of the amount of current we put in to the amount of current that will flow through the transistor. So question, what is the term that describes a device's ability to amplify a signal? Answer, gain. Which of the following can provide power gain? Answer, transistor. So in most radios today, we actually use FETs. We use field effect transistors as the component in the final amplifiers of our radios. Now, if you looked at what's inside this transistor, this wouldn't look exactly like this, but it would look sort of like this. You'd have three regions of semiconductor material, one for each of the leads, right? So this is the base, this is the emitter, this is the collector. In this case, this is an NPN transistor. So this is an N material, this is an N material, and this is a P material. That's how we get NPN. So question, which of the following components can consist of three regions of semiconductor material? Answer, the transistor. Question, what are the names of the electrodes of a bipolar junction transistor? Answer, emitter, base, collector. All right, let's talk. It was a couple of questions about FETs now. Question, what does the abbreviation FET stand for? Answer, field effect transistor. What type of transistor has a gate, drain, and source? Answer, field effect. So this is the drain, the gate, and the source. Like I said, we use both types of transistors in all kinds of electronics. So that's why we're just giving you sort of a basic introduction to them. Any questions so far? All right, so I got a little bit more of this chapter, and then we'll take a break. It shouldn't take too long.
We had a couple of questions come into the chat but they were answered by other people in the chat. The main one I saw was, is dB a measurement of how loud something is?
Well, so that's the audio dB,
right?
And it's a similar concept, right? But they're different units. Where the units are the dBs are used to specify ratios of electrical power, not sort of audio power.
Yeah, that's basically the answer that someone else in the chat gave. So I just kind of let that go.
Yeah. Any others?
I have not seen any other questions right now. So again, guys, if anyone in the chat on YouTube has questions, just type it in the chat. If you have a question in the Zoom webinar, just raise your hand. So, but we're good to go, Dan.
All right, good. So let's talk about some actual circuits now. And this is right out of the book, right? Figure T1 in the book. And there's some questions about this. This is what's called a schematic diagram. And what a schematic diagram does is shows you the components that are in a circuit and how those components are connected. So if I gave you the components shown here and this circuit diagram, you could actually build this circuit and get it to work. Now, what this is a transistor switch circuit. This is an example of how a transistor is used as a switch. And the way this circuit works here is that if I put some kind of voltage across here, let's put a battery to just show voltage, but it could be any voltage. Putting that voltage there is going to cause a small current to flow through this resistor into the base. This is the base, remember, right? And that small current is going to cause a larger current to flow through the transistor as a whole, and it's going to turn on this light. This battery here is going to provide the voltage, the current to light the light. So there's a few questions about schematics. What is the name of an electrical wiring diagram that uses standard component symbols? Answer: schematic. Which of the following is accurately represented in electrical schematics? Answer: component connections. So again, this shows you how this circuit would be connected, how you would build its circuit. Now, there's a couple questions specific to figure T1. Question: what is component 1 in figure T1? Answer: resistor. Remember, that's the symbol for a resistor. What is component 2 in figure T1? Answer: transistor. Question: what is the function of component 2 in figure T1? Answer: control the flow of current. So when this voltage is present, current will flow. When this voltage is not present, current won't flow. Question: what is component 3 in figure T1? Answer: a lamp. What is component 4 in figure T1? Answer: a battery. So this is a really simple circuit, and like I say, if I gave you the components and the diagram, you could build one for yourself. All right, let's take a look at figure T2 now. So this is a so I had a question here in the question and answer thing about the previous. Let me go back to it. Question is, why a battery on both ends? Well, we don't really need a battery here, but we're just using that battery to provide a voltage across here to create a current into the base. This could be some whole other circuit that's providing that voltage. So we don't really need a battery, but I just use an example of what might cause a current to flow into the base of the transistor. All right. So figure T2, this is an example of kind of why I hate the question pool, to tell you the truth. This circuit is something, it's ostensibly a power supply circuit, but this is not a power supply you'd want to use in your own Radio Shack. It's just terrible. Because it's such a poor example of a circuit, I've always been after the people who create the question pool to get rid of this diagram in the questions, but replace them with something else, but get rid of this. But anyway, it's still on the test. So we do have to talk about it. Like I say, this is a power supply circuit, and this is the AC input here. So this is just a plug you'd plug into the wall. The switch number 3 controls, turns it on and off. Component number 4 is what's called a transformer. And what a transformer does is it transforms the 120 volts AC you'd get out of the wall, right, into a much lower value. And, we in amateur radio now, we're using like 12 to 15 volts. So you get 12 to 15 volts out here. That's what a transformer does. It transforms a higher voltage to a lower, or vice versa. In this case, it would be higher to lower. So questions. What type of switch is represented by component 3 in figure T1 or T2? Answer: a single pole, single throw switch. So it's a single pole, single throw switch. Question: what is component 4 in figure T2? Answer: a transformer. Question: which of the following devices or circuits changes an alternating current into a varying direct current signal? Answer: a rectifier. And this is the rectifier. A rectifier is a type of diode that's designed to work in power supply circuits like this. So let's sort of see what this does. On one side of the diode, you'll have the regular AC voltage, right? Kind of look like this. If I'm drawing it, I could be a better draftsman, I guess. But so that's on this side of the circuit. On the other side of the circuit, the cathode side, what you'd see is just the positive going portions of that waveform. Right? So that's what the question is: which of the following devices or circuits changes an alternating current into a varying direct current signal? Answer: the rectifier. So that's what the rectifier does. And so the whole idea of the circuit is to change the AC into a DC voltage. And now you can see sort of that instead of being a positive and negative and a true alternating current, now it's you've only seen the positive portions of that circuit. So we're moving toward being a DC voltage. Question: what is component 6 in figure T2? Answer: a capacitor. And the purpose of the capacitor is to try and start to smooth out the voltage, to make it more of a real direct current. So at this point, what you'd start to see is the voltage kind of getting like this. So as you can see, it's getting to be more of a real DC voltage. Somebody asked, what is component 2 in figure T2? That's a fuse. So just for protection. Question: what is component 8 in figure T2? Answer: a light emitting diode. And that just shows that the power supply is on or off, right? If you had a DC voltage here, current will flow, a positive DC voltage, current will flow and the light will light up. Question: what is component 9 in figure T2? Answer, a variable resistor. Remember I mentioned the little arrow pointing toward the component makes it a variable component. All right. Let's go to figure T3. Oh, shoot. Sorry about that. So figure T3 is something you might see in a antenna tuner. And you see it's got variable capacitors and a variable inductor. And this variability allows you to make the antenna tuner work, to match what an antenna tuner does is, and we'll talk more about this a little bit later, it'll match the impedance here to the impedance of a transmitter here. So question, what is component 3 in figure T3? Answer, a variable inductor. Oops. So that arrow shows it's variable. What is component 4 in figure T3? Answer, the antenna. So that's the symbol for an antenna. Now, one thing that sort of goes along with this circuit, not directly, is the idea of a tuned circuit. So a tuned circuit consists of a resistor and a capacitor and an inductor. And you can have a series tuned circuit or a parallel tuned circuit. Now, remember I said that inductors create magnetic fields when current flows through them, and capacitors store energy in an electric field. Well, if you got an electric field and a magnetic field, what do you got? Well, you got radio, right? And so these are called tuned circuits because these allow you to create radio signals at certain frequencies. So the one thing to consider is that these components will resist alternating currents, and RF is just an alternating current, right? Well, at some frequency, the what's called the impedance of the capacitor will equal the impedance of the impedance of the inductor will equal the impedance of the capacitor, and at that point, at that frequency, that's what's called the resonant frequency of the circuit. And this is the cool part, at the resonant frequency, this acts like a total short circuit. It's as if these components weren't even there. So in a series tuned circuit, it will act as a short circuit at the resonant frequency. But so if you use these same two components and connected them in parallel like this, you get totally the opposite behavior. In a parallel tuned circuit, this acts like an open circuit. It's to me, that's like an amazing thing. So that's the concept of tuned circuits. Questions are, which of the following is a resonant or tuned circuit? An inductor and a capacitor in series or in parallel? Question, which of the following is combined with an inductor to make a resonant circuit? Answer, a capacitor. So it's a little bit more involved than that, of course, but that's sort of the magic of radio right here in these two little circuits. By using tuned circuits in radio, we can create and receive radio signals of particular frequencies. So that's sort of the amazing thing. There's a few miscellaneous questions about other components, then we can take a break. Question, what is the function of a single pole double throw switch? Answer, a single circuit is switched between two other circuits. So let's just look at this real quick. This was a single pole, single throw, right? From T2. This is a single pole, pole double throw. We have two sort of outputs, so we can switch between one or the other. Question, what is a relay? An electrically controlled switch. So how does a relay work? Well, relay has a little coil in it usually, and then there's a bar or piece of metal that's attracted when a current flows through here. You get the magnetic field, and this closes. So that's a relay. You can control the switch electrically. Question, which of the following displays an electrical quantity as a numeric value? Answer, a meter. So I don't know, you've probably seen meters, right? They got a little dial or a little scale, and then the little needle goes back and forth. Question, what is the name of a device that combines several semiconductors and other components into one package? Answer, an integrated circuit. Whoops. No, I guess I don't have a thing. So, what's an example of integrated circuits? So, your computer has, probably 100 different integrated circuits in it. Some could be very, very big, like the processor in your PC may have millions of transistors, whereas a smaller integrated circuit, such as a voltage regulator, might have only a couple transistors in it. But that's an integrated circuit. Question, what type of circuit controls the amount of voltage from a power supply? Answer, a regulator. So the power supply in figure T2 should really have a voltage regulator integrated circuit in it, but it doesn't for whatever reason. Question, what electrical component is used to protect other components from current overloads? Answer, a fuse. And if you remember figure T2, let's get that up. It's got a fuse. That's component 2 in figure T2. And finally, question, which of the following is a reason to use shielded wire? So let's think about that. A shielded wire may have several conductors in it, right? But there's a shield around that wire. And the whole idea of the shield is to prevent outside, like radio waves or other forms of interference, from affecting the signals in these wires, and conversely, to prevent the signals in these wires from radiating signals out into the environment. So question, which of the following is a reason to use shielded wire? Answer, to prevent coupling of unwanted signals to or from the wire. So at one end or the other, you'll ground that shield, and anything generated inside the cable will be picked up by the shield and shunted to ground, and conversely, anything trying to affect the signal from outside will be shielded from the data wires and shunted to ground. All right, let's take a break. Let's take 10 minutes. Get back here at 11:35.
11:35. Okay. Yeah,
11:35 Eastern time.
Eastern time. Yeah. No, that's fine. That's fine. No problem at all. Okay, so we're going to take a break, and that'll work just fine. Thanks, Dan. Go ahead and step away if you want to. I'll take over for a minute.
All right.
So I appreciate everybody being here. Some people have asked about the Zoom link. If you signed up, okay, so the Zoom webinar, and I said this at the beginning, but we've had a lot of people join us and leave since then, so that's fine. I don't mind repeating it. I'll probably repeat it several times throughout the day. if you signed up at the Zoom link, the Zoom webinar is here for you to basically monitor from the back end. It's the same exact thing on YouTube, except it's real time. YouTube has a 20 to 30 second delay. So 2 emails were sent if you signed up on the Zoom for the Zoom webinar. One was sent yesterday, one was sent today. A couple people have reported not getting that. All I can tell you is that it was sent to you. Check your spam filter. Or you can email me directly, kc5hwb@gmail.com. That's kc5hwb. That's my ham radio call sign. kc5hwb like boy @gmail.com, and I will send you the Zoom link directly. So, but the Zoom link's not going to really provide you with anything that the YouTube stream doesn't provide you with, other than the fact that it'll be a little bit easier to see your questions if you raise your hand in the back of the webinar. You can ask questions a little bit more directly, but we're monitoring questions in the YouTube chat as well. So it's up to you. You can do it however you want to. Either way is fine. But email me if you did not get the link. I would like to take a minute and talk about sponsors that we have for this live stream. The first one is BetterSafeRadio. BetterSafeRadio.com offers two-way radios that are designed in China by they're designed by BetterSafeRadio in the USA, but they're manufactured in China by a company called Oshang, which it's spelled Waxon. I usually call it Waxon, but the correct pronunciation is Oshang, or something similar to that. That's as good as I can get. But they sell these radios on the website. This one here comes pre-programmed with over 900 channels in it that will cover most of your simplex frequencies, repeaters. It'll monitor GMRS and FRS, a bunch of police and fire band stuff, and it comes pre-programmed with all that stuff. So it's a great entry-level radio for someone who just got their license because it comes with all these pre-programmed channels. I'm going to be giving one of these away to someone in the Zoom chat during this live stream, probably towards the end. So I've got 23, 24 people in the Zoom webinar right now, those people who signed up prior to today. And BetterSafeRadio is donating a radio to give away in today's live stream. Additionally, they're going to donate a radio to us every month from now on out, and we're going to do just on random live streams that I do. I live stream every Sunday at 7 p.m. Central Time. So if you guys subscribe, you can keep up with the live streams and the videos that I post. And and during the next 12 months, we're going to give away one of these radios to someone in a live stream every month. So be watching the channel. Generally, the way that I give those away is I'll send out an email list, have you sign up on the email, and then everybody on that list, I do a random number generation and pick those from there. So BetterSafeRadio.com. I will share this link in the Zoom webinar and in the YouTube channel right now. Let's see. Right here. You guys can go check that out and see everything, or see that radio, read up about it, get some more information about that. Gavin is asking in the webinar, can you show that full screen on Zoom, Jason? Full screen on Zoom. Which, this right here? No, I can't. Not right now, I can't. But I just shared the link in the chat, Gavin, so check that. Click on the link in the webinar chat, and it'll take you right over there. You can read all about it. So I don't have that scene set up to share full screen right here, right now, unfortunately. This right here is wrong. There we go. So yeah, BetterSafeRadio.com. Click on that link in. That's fine. I got it. Thanks. Thank you. Thanks for being here, Gavin. So yeah, link in the webinar chat. Same link in the YouTube description. You'll still see Dan's desktop in the Zoom. So be watching for these breaks that we're taking. You're gonna have to tune into the YouTube channel because I don't want to kill Dan's connection while we're on break. So yes, Dan Sullivan is asking a question. Still seeing KB6NU's desktop in the Zoom. Yeah, you will. So check on the what am I trying to say? Let's see. Let's see if I can, maybe I'm wrong about that. Hold on, let me see if I can change that. Show self view. Add pin, replace pin. Oh, how's that? I can do it that way. I forgot I could do that. The webinar GUI is a little bit different than the GUI that I'm used to for Zoom. So there we go. So Mark's in the house, bettersaferadio.com. Happy studying to everyone. Thank you for the donation, Mark. Like I said a minute ago, we'll be giving away one of these radios towards the end of the live stream today, and then one per month for the next 12 months, or for the next 11, this one plus 11 more months. So there we are on that. Also, if you guys care to, you can sign up on my email list, which is just hamradio2.com/email-sign-up. And that list, I send usually 1, sometimes 2 emails per week to keep up with stuff happening on the channel. Maybe new deals, sales, something new, some new radio coming out, new events like for Hamfest's upcoming and whatnot. So I try to share with the audience there everything that I can. So hamradio2.com/email-sign-up. I will put that link in both chats here in just a minute, but that's how I try to keep up with everybody and keep everybody informed and communicate with the audience. And I got a lot of people, and you can reply to the email. When I send out a broadcast email, you can reply to that email and say, hey, you have a question about something or clarification needed or something like that. It's perfectly acceptable to do that there as well. So, okay. Thanks, Dan. Yeah, I try not to send out too much stuff that's too much on the I don't like to send out, there's a certain company out there that sends out a lot of emails, and that's okay. You can always unsubscribe. But yeah, I don't like to do that if I don't have to. All right, let me see how to switch back to this. Hold on. That's not right. My view. Got about 2 or 3 more minutes on the break. Remove pin. There's that. Okay. There. Okay. George Cullen, any way that a UV 5x3 can be programmed via iPad? Not unless there's a chirp version for iPad. I don't have an iPad. I'm not an Apple guy. I don't know a lot about them. I mean, I know what they are, obviously, but I don't know what software is available for them. So, good question. I don't know. See if Chirp is available for iPad, and if so, you can program it with Chirp. If not, then probably not. Belfang Tech's another one of our sponsors for this live stream. I'm going to be talking about them on the next break. So, UV 5x3 is a great radio. I still have mine and still use it. I've had it for 4 or 5 years. All right, another minute or so. We're coming back. I see a couple more people have joined the Zoom webinar, so that's great. Yeah, Dan, I'm messing with things in the back end. You should. Okay, yeah, you should see it. But by the time we come back, you should be good. I've got a bunch of things to switch around. I've got a scene. I got OBS running. I got Zoom running. I've got 2 chats running. So I'm glad I have 2 monitors here today.
And I'm glad you're doing that while I'm trying to teach. So
yeah, exactly. Yeah, it makes it a little bit easier to do that, to have someone teaching and someone doing producing, I guess you would call it.
All right. So are we ready?
Yeah, we're ready.
All right, let's do it. So now we're going to get into some of the more, I don't know, I'd say kind of more interesting stuff. We're going to talk about radio wave characteristics. So if you can see my screen here, and this is from actually a really nice animated GIF that shows you how these fields change in time. I can't sort of display that here, but what this shows is that a radio wave is made up of two components, an electric field and a magnetic field, and those fields are at right angles to one another. And if you think about how a radio wave travels through space, it would travel along this x-axis here, increasing, decreasing, and moving, like I say, in the x direction. That's why we call it a radio wave an electromagnetic wave, because it's got an electric field and a magnetic field. So, a question: what are the two components of a radio wave? Answer: electric and magnetic fields. Question: what is the relationship between the electric and magnetic fields of an electromagnetic wave? Answer: they are at right angles. Question: what is the velocity of a radio wave traveling through free space? Answer: speed of light. So that's why radio communication is, at least on Earth, is almost instantaneous. Question: what is the approximate velocity of a radio wave in free space? Answer: 300 million meters per second. So that's the speed of light, right? 300 million meters per second. So let's talk now about wavelength.
We got a hand raised in the Zoom chat. Tiki, if you could type your question in the Q&A, we can address it there, if you don't mind.
Yeah, I didn't see that.
Yeah, it doesn't pop up in the same place that the Q&A does. The Q&A pops up and it gives us a notification. You can raise your hand, that's okay, but it'll be a lot quicker and easier to see if you just type it in the Q&A chat. Everybody in the webinar I'm talking to.
Well, when he types it in the Q&A, we'll answer it.
Yeah, we'll do that. Go ahead, Dan.
Okay, so one of the important things in for us as ham radio operators is wavelength. So what is wavelength? Wavelength is the amount a radio wave will, let's see, how should I say this? The distance a radio wave will travel within one cycle. So let's look at the red wave, for example, right now. So as it's moving through space, right, it's going to travel a certain distance in one cycle. This is one cycle. And the wavelength is going to be dependent on frequency, right? So this blue, if we look at the blue wave for a second, here's one cycle for the blue wave. And the blue wave is twice the frequency of the red wave. So as you can tell, the wavelength, and sometimes we use the symbol lambda for a wavelength. The wavelength here is a half the wavelength of the wavelength of the blue signal is half the wavelength of the red signal. And why is this important? Well, it's important because one reason anyway is that antenna size is kind of proportional to the wavelength of a signal. So a antenna for the 40 meter band will be a lot bigger than an antenna for the 2 meter band. That just sort of makes sense. And fortunately, these two are related quite nicely. So the frequency, well, let's use wavelength first. The wavelength of a signal is equal to 300 over the frequency in megahertz. Okay, let's look at this question. Okay, so, and conversely, if you know the wavelength, you can calculate the frequency. The frequency is equal to 300 over the wavelength. Actually, the wavelength in meters. So where does that 300 come from? Well, the 300 is the 300 million meters per second, right? And because we're talking about frequency in megahertz, not in just plain hertz, we can get rid of that million, that factor of a million. So, question, what is the formula for converting frequency to approximate wavelength in meters? Answer, wavelength in meters equals 300 divided by the frequency in megahertz. Question, what is the relationship between wavelength and frequency? Wavelength gets shorter as frequency increases. And like I say, that the reason that's important is, one of the reasons is antenna size. Another thing is we use the approximate wavelength to denote our amateur radio bands. Talked about the 2 meter band, right? The 2 meter band. If we plug this into our equation, we get so frequency equals wavelength, or 300 over the wavelength equals 300 over 2. Well, that's about 150 megahertz. And the 2 meter band here in the US is 144 to 148 megahertz. So it's not exactly, but it's approximate. It's a lot easier to say 2 meters than 2.05 meters or whatever it might be. All right. So question, in addition to frequency, which of the following is used to identify amateur radio bands? Answer, the approximate wavelength in meters. Here's another kind of amusing historical fact. So we have what's called the 40 meter band, right? So frequency equals 300 over 40. Oops, 300 over 40, 7.5 megahertz, right? Well, at one point, the 40 meter band actually spanned 7.0 megahertz to 8.0 megahertz. So that the middle of the band was actually 7.5 megahertz. That was beautiful. But over time, that band got reduced, and now it's just 7.0 to 7.3 megahertz. But 40 meters actually used to be in the 40 meter band at one point. All right. But remember that the important thing here is wavelength gets shorter as the frequency increases. And these two equations. So the radio frequency spectrum is very, very large. You know, sometimes in the ham radio, we joke that we can use frequencies from DC to daylight. DC, of course, being like 0 hertz, and light being like way out here somewhere. Sort of to help us think about this big spectrum, we break it up into portions. And one of the reasons we do this is that different portions of the spectrum have different propagation characteristics. And that's one thing you want to know as a ham is what frequencies to use for which type of communication you're trying to accomplish. So if you know how the radio waves propagate at certain frequencies, you can choose the appropriate frequency for the type of communication you're wanting to accomplish. So what is on the test are 3 different ranges. One is HF. That's this portion of the spectrum right here, 3 to 30 megahertz. And then VHF, which is this portion here, and UHF, which is this portion here. So 3 to 30 is HF, 30 to 300 is VHF, 300 to 3 gigahertz or 3,000 megahertz is UHF. That's why handhelds are sometimes said to be VHF, UHF transceivers, because they'll have the 2-meter band, which falls in the VHF spectrum, in the 70 centimeter band, which falls in the UHF spectrum. So question, what frequency range is referred to as HF? Answer, 3 to 30 megahertz. Question, what frequency range is referred to as VHF? Answer, 30 to 300 megahertz. Question, what frequency range is referred to as UHF? 300 to 3,000 megahertz. That's 3,000 megahertz here. And as they're wont to do, here's a sort of a miscellaneous question. What does the abbreviation RF mean? Answer, radio frequency. Any signal with a frequency in this range would be referred to as an RF signal. All right. So one reason we want to know or do this kind of thing is because these different ranges have different propagation characteristics. When you get started as a technician, chances are you'll be using a VHF, UHF transceiver, right? And then Jason just showed you an example of one during the break. And at those frequencies, propagation is normally line of sight. And what does that mean? That means that normally you have to be able, the transmitter and the receiver have to be within line of sight of one another. That's not strictly true, but for the purpose of this discussion at this point, let's just go with that. And what does that mean? Well, like I say, the transmitter, in this case, this would be the transmitter. This would be the receiver. And they have to be within line of sight of one another. If your receiver was over here, for example, you're going to run into the earth here, and you're not going to be able to communicate between the transmitter here and the receiver here. It's just too far. Looking at a question in the Q&A section. So the distance you can actually reach is called the radio horizon. So let's say, let's sort of draw a line here. So let's say that this is the distance you can do line of sight propagation over. This would be called the radio horizon. And it's actually a little bit farther than line of sight because radio waves, unlike light waves, tend to bend a little bit around the Earth's surface. So it's a little bit farther than the visual horizon, but it's still pretty close. So question, why is the radio horizon for VHF and UHF signals more distant than the visual horizon? Answer, the atmosphere refracts radio waves slightly. Question, why are simplex UHF signals rarely heard beyond their radio horizon? Answer, UHF signals are not usually propagated by the ionosphere. We're going to talk a little bit more about the ionosphere later, but the ionosphere is a layer of the atmosphere that ionizes. That's why they call it the ionosphere. And at certain frequencies, radio waves will actually bounce off the ionosphere, and you'll be able to achieve farther propagation than you would with line of sight propagation. But we'll talk a little bit more about that later. So that's line of sight propagation. Let's talk about what happens in a realistic situation. In a realistic situation, if you're in the middle of a city somewhere, you can get all kinds of different paths from that your radio wave will travel from the transmitter. In this case, let's say this is the repeater here, to you at your house here trying to hit the repeater. Your signal can actually travel, and the repeater signal can actually travel over any of these paths, right? So, question: why do VHF signal strengths sometimes vary greatly when an antenna is moved only a few feet? Answer: multipath propagation cancels or reinforces signals. So depending on what's going on in the environment, you may have, well, you certainly will have multiple paths. Excuse me. And some of those paths will cancel each other out, and some will reinforce the other. So you get a whole crazy quilt of stuff happening here. Question: what is the meaning of the term picket fencing? Answer: rapid flutter on mobile signals due to multipath propagation. So let's say you're in a car, right? And you got your, of course, I'm not a great drawer. I'm a better ham than I am an artist. But if you can, this is sort of a static situation, except for the airplane, of course. But, once you've established these paths, generally they're kind of stable. But if you're moving around in a car, this is really a dynamic situation. So at this point, you might have a strong signal. A little bit farther down the road, you got a weak signal. So you get that weak, strong, weak, strong. That flutter is sometimes called picket fencing. It's as if you're looking at the signal through a picket fence. Question: what effect does multipath propagation have on data transmissions? Answer: error rates are likely to increase. And why you might think, well, why does that matter to me? I'm not going to be sending data. Well, if you're using D-Star or DMR, those are all data transmissions. And if your signal is not strong, then that data transmission is going to have a high error rate. And you might not get the audio quality you want. In some cases, you may not be able to actually access the repeater at all. So this is actually a more cogent question now than it was, say, 10 years ago, when we didn't have a lot of digital voice going on. So that's something to keep in mind. Multipath distortion will increase error rates. Question: when using a directional antenna, how might your station be able to communicate with a distant repeater if buildings or obstructions are blocking the direct line of sight path? Answer: try to find a path that reflects signals to the repeater. So let's look at this case. So in this case, there is a direct line of sight here, right? From your home to the repeater. But say, this certainly is happening here in Ann Arbor. Say somebody decides they're going to put up a building here, and that blocks your line of sight path. How can you get around that? Well, you can cultivate one of these reflected paths. You could put let's say, bouncing it off this building is going to give you the best path. You can point a directional antenna in that way and actually go around the building. So with a directional antenna, you can try to find an answer, try to find a path that reflects signals to the repeater. And actually, I have that situation here. I'm nowhere near line of sight to our repeaters, and yet somehow I can access both our 2-meter and 440 repeaters, and I don't know what path I'm taking, but it's bouncing around town somehow and hitting the repeaters on the other side of town. See, there's another question here. Yeah, Stanley says, just like moving an antenna when you have TV over the air, a little to the left or the right might get a better picture. And that's absolutely true. Back in the old days when it was all over the air television, you could always tell when a plane was going by, because the signals would reflect off the plane, and sometimes you get that picket fencing on your TV. You'd see the TV signal flutter. Question: which of the following effects may allow radio signals to travel beyond obstructions between transmitting and receiving stations? Answer: knife edge diffraction. And I've got a so here's another multipath diagram, and this shows the diffraction. What's actually happening in this case here, it says diffraction, is that the signal is hitting this edge and then diffracting a little bit, allowing the signal from this mobile to reach the repeater. We'll say this is the repeater here. These diagrams are all made for cell phones, so I just sort of co-opted them for our use. One thing I haven't shown here is any kind of vegetation, but vegetation can also sometimes affect signals, especially the higher up in frequency you go. So question: what is the effect of vegetation on UHF and microwave signals? Answer: absorption. So, in this case, let's say we had a big tree here. Well, we probably wouldn't be able to use that diffraction path because this tree might, depending on the frequency, if we're at 900 megahertz or something, that tree might absorb just too much of the signal. Another consequence of this, of course, is you don't want to put a UHF antenna up in a tree because in the spring and summertime, when the tree leaves out, your transmission and reception won't be as effective. Let's see. Let me get rid of this stuff. Okay, so let's talk a little bit about polarization now. Polarization is how the radio wave itself is actually situated. Okay, we say a radio wave has vertical polarization if the electric field is vertically polarized, right? So in this case, this is just an HT, right? If you hold the HT so that the antenna is sticking up in the air, your signal is going to be vertically polarized. It's going to be horizontally polarized if you have it so that the antenna is parallel to the earth. And sometimes this is bad. You don't want to do this. Why is that? Because a repeater system generally has a vertically polarized antenna. And when the transmitting antenna and the receiving antennas match, have the same polarization, that's when you get the maximum amount of transfer of signal between the transmitter and the receiver. So in this case, this is good. Oops. Good. This is bad. It might look cool to hold that radio like that so the antenna is parallel to the ground, but it's bad because you won't be able to hit the repeater from as far away as you would if you're holding the HT vertically. So question: what property of a radio wave defines its polarization? Answer: the orientation of the electric field. What happens when antennas at opposite ends of a VHF or UHF line of sight radio link are not using the same polarization? Answer: received signal strength is reduced. So in this case, we're going to get a lot less signal than in this case. And on VHF, UHF, FM, we almost always use vertical polarization. I know of no repeaters that actually use horizontal polarization. So Vertical polarization is the way to go for VHF and UHF FM operation. Now, that's not always the case, even on VHF and UHF. Question, what antenna polarization is normally used for long distance CW and SSB contacts on the VHF and UHF bands? CW and SSB are different operating modes. CW is for Morse code. Single sideband is a voice mode, but it's much different than FM. And we'll talk a little bit more about that later. These folks all use horizontal. So the answer to this question is horizontal. And my take on this is that most of these weak signal modes, you're using a directional antenna, such as a Yagi, and we'll talk about Yagis later, the Yagi antenna. And it's much easier to mount and operate these antennas horizontally than it is vertically. So that's my theory on why those modes, they use horizontally polarized antennas. All right. Let's talk about propagation modes now. So I said before we'd talk a little bit about the ionosphere. So the ionosphere extends, as you can see, up to maybe even 400 kilometers above the Earth's surface. And it's made of different regions. There's the D region, the E region, and the F region. There's no A, B, and C regions, oddly enough. And the reason for that is that when scientists first began studying this, they discovered the D, E, and F regions, but they theorized that there would also be A, B, and C regions. Well, those never materialized. They never were able to find an A, B, or C region. So now we're stuck with D, E, and F. I always thought that was kind of funny. But even at VHF and UHF frequencies, we can still get, which of course is the exception that proves the rule, right? Is that we still can get some propagation off some of these regions. Perhaps the most interesting one, or most common one, maybe something called sporadic E. And what happens here is sometimes this E region gets so highly ionized that VHF and UHF signals will actually bounce off it. Now, the reason it's called sporadic is because unlike this diagram, which sort of shows it as a static kind of thing, it's really not. There's clouds of ions floating around in this E region. And when that cloud just happens to be in the right spot to allow communication from point A to point B, then you get sporadic E propagation. And it's called sporadic because it's sporadic. It comes and goes very quickly as these ionized clouds float around. So question, which of the following types of propagation is most commonly associated with occasional strong signals on the 10, 6, and 2 meter bands from beyond the radio horizon? Answer, sporadic E. Question, what is the characteristic of VHF signals received via auroral backscatter? Answer, they are distorted and signal strength varies widely. So the aurora is something else you can do, right? It's not shown on here at all, but with increased solar activity, we've been seeing a lot of auroras. You can actually shoot your signal into the aurora and it'll bounce out. And because that aurora is constantly changing, your signal is going to get modified as well. It's going to get distorted and the signal strength will vary widely as that aurora changes. So that's another thing you can do with in ham radio, auroral scatter. Another thing that hams find fun to do is meteor scatter, right? So what happens when meteorites enter the Earth's atmosphere? They leave little trails of ions behind them. And if you're at the right place in the right time, you can actually bounce your signal off those little ion trails. And you can accomplish meteor scatter. So question, what band is best suited for communicating via meteor scatter? Answer, 6 meters. And, one question I always get is, why would anybody want to do this? Well, the answer, of course, is because we can. It's just something fun to do. Okay, we'll come back to the ionosphere later on. Now let's talk about tropospheric ducting. Here's another kind of exception that proves the rule. This phenomena allows you to operate VHF and UHF over longer distances than normal. Question, what type of propagation is responsible for allowing over the horizon VHF and UHF communication to ranges of approximately 300 miles on a regular basis? Answer, tropospheric ducting. And what happens is that you get what's called a temperature inversion, where warmer air is actually above cooler air, and these ducts will form. And if you shoot your radio wave into one of these ducts, it'll bounce around in that duct and come out farther than you'd get up with normal range. And next question, what causes tropospheric ducting? Answer, temperature inversions in the atmosphere. That is warmer air over cooler air. One time, we have a repeater here in Ann Arbor that's connected to the internet, so people can access it via the internet. This one happens to use Echolink, and we'll talk more about Echolink later, but it's a way for people to access repeaters over the internet that they can't hit via normal radio. And so I was listening to the repeater, and I heard this guy. He was in, as it turns out, he was in Buffalo, New York. And he'd get on and he'd say his call sign. And he did this a couple of times. So I figured, well, okay, let me contact him and see what he's doing. Well, what he lived in Buffalo, New York. What he was doing was trying to find repeaters that were, 200 or 300 miles away from him, and access those repeaters, and then see if he could hear those signals via tropospheric ducting. And I thought, how cool is that? I mean, it's kind of weird. You're talking to yourself, but kind of cool that he was able to access these repeaters via the internet and then see if he could hear the return signal via these tropospheric ducts. So that was kind of a fun thing. And why was he doing it? Well, just because he could, right? So normally I say weather doesn't affect propagation. Well, of course, that's not the case in this scenario. That's setting up the. I'm trying to get rid of this. Anyway, so it's setting up the conditions for tropospheric ducting, but normally weather doesn't affect it. But there's another case where it will affect propagation at some frequencies. Question, what weather conditions might decrease range at microwave frequencies? Answer, precipitation. So if any of you have ever had a direct TV, in a rainstorm, a thunderstorm, sometimes reception is not quite so good. That's because the rain is actually absorbing the signals. But like I say, in general, weather has little or no effect on signals, especially at the lower frequencies. Question, what is the effect of fog and rain on signals in the 10-meter and 6-meter bands? Answer, there is little effect. All right. Let me get rid of it. So let's look at the ionosphere again, because we're going to talk about HF propagation, that is radio wave propagation between 3 and 30 megahertz. These are the frequencies that you normally will use for worldwide communication. For example, last night I was on the air and I was able to make several contacts in Europe. And I was using the 30-meter band, which is around 10 megahertz. And the bands were very, very hot last night. And it was very easy to make these contacts. And my signals were bouncing off the F region. So from here in the US to Europe, the signal was going up into the ionosphere, being refracted off the F region, and then into Europe. And that's just very cool. So question, which region of the atmosphere can refract or bend HF and VHF radio waves? Answer, the ionosphere. Question, what is a characteristic of HF communications compared with communications on VHF and higher frequencies? Answer, long distance ionospheric propagation is far more common on HF. So like I say, and why do we bring this up? Well, while you mostly be using VHF and UHF as technicians, you do have HF privileges. And you have voice privileges on 10 meters and Morse code privileges on 10 meters, 15 meters, 40 meters, and 80 meters. And fortunately, the propagation is starting to get really good. And on 10 meters, for example, you can talk to people all over the world. So, even as technicians, you might consider doing this. Why? Because it's a lot of fun. Question, so one of the reasons the bands are getting better is because we're seeing an increase in sunspots. And it's not the sunspots per se, but the sunspots are a measure of how active the sun is. And when the sun is more active, the ionosphere gets more ionized, and that makes radio propagation better. So oddly enough, the sun follows an approximately 11-year cycle. And you're getting in the ham radio at a good time because we're on the upswing in that cycle. We're still probably a couple, 3 years away from the peak of the cycle. So for the next 5 or 6 years, radio wave propagation is going to be pretty good. So it's a good time to get into ham radio. Bob asked, radio waves bounce off the ionosphere, but will they also bounce off the Earth, or will the Earth absorb them? Well, there is some amount of bouncing off the Earth, but you get a lot more absorption than you do off the ionosphere. I hope that answers your question. So, like I say, we're coming up on the upswing of the sunspot cycle. Question, which of the following bands may provide long distance communications via the ionosphere's F region during peak of the sunspot cycle? Answer, 6 and 10 meters. Well, it's actually all the bands, but 6 and 10 meters is the answer to this particular question. Propagation, so there's this long-term propagation change. Well, even during the day, propagation changes, right? So bands that the lower bands, like 80 meters and 40 meters, are generally not as good during the day as the higher bands. Why is that? Because the D region here, which you can see right here, this D region, it absorbs radio signals at 80 meters and sometimes as high as 40 meters. But the upper bands, like 10 meters and 20 meters and 15 meters, those generally do offer pretty good propagation. But this changes during the day. So question, what is generally the best time for long distance 10-meter band propagation via the F region? Answer, from dawn to shortly after sunset during periods of high sunspot activity. So at night, 10 meters probably will not be the best band to use for long distance communication. But during the day, that's when you want to be operating on 10 meters. Question, what is a likely cause of irregular fading of signals propagated by the ionosphere? Answer, random combining of signals arriving via different paths. So this is really just the same thing as the multipath propagation we looked at VHF and UHF, except that it's happening, the propagation between the transmitter and receiver is happening via the ionosphere. And like I said, this ionosphere is a constantly changing thing. So as the ionosphere changes, so does the propagation a little. And in some cases, those multiple paths may reinforce the signal and you'll hear it very strongly. And then sometimes those multiple paths cancel the signal and it fades out and then fades in and fades out. And That's all a result of a signal arriving at the receiver via multiple paths. So what happens in the ionosphere as far as radio waves is concerned? It's not really well known because you can't get up there and measure it, right? But we do know one thing that happens is that the polarization just changes completely, and the engineers like to call it. They say that radio waves get elliptically polarized as they get refracted by the ionosphere. And what this means really is that it doesn't matter on HF what the polarization of your antenna is, because there's no way you can predict, like you can with a VHF and UHF line of sight signal. There's no way to predict what the polarization will be when that HF signal reaches your antenna. So, question, which of the following results from the fact that signals propagated by the ionosphere are elliptically polarized? Answer, either vertically or horizontally polarized antennas may be used for transmission or reception. And sometimes what you find is that hams will have two or more antennas for a particular band. And one of those antennas, even though you're the same distance apart, one of those antennas will be better for that communication than another. It all depends how that signal is bouncing off the ionosphere. All right, another question here. When does an antenna tuner come into play? Well, we'll talk about that in a bit. As far as propagation is concerned, it doesn't really come into play at all. It's just a matter of matching an antenna to a transmitter to get the maximum power to the antenna. And we'll talk about that in a little bit. So hang on to that question. All right. Let's see. Talk about that. So let's talk about some actual antennas now. Perhaps the most common type of antenna in amateur radio is the dipole antenna. That's what this is, a dipole antenna. And it's commonly called a half wavelength dipole antenna because the approximate length of the antenna is a half of a wavelength. So for a 10 meter antenna, 10 meter dipole antenna, the length would be 5 meters. And to calculate the length in feet, this is a sort of a rule of thumb we use in ham radio, 468 over the frequency of megahertz. Question, which of the following describes a simple dipole oriented parallel to the Earth's surface? Answer, a horizontally polarized antenna. So you see it's parallel to the Earth's surface and it's horizontally polarized. Question, in which direction does a half-wave dipole antenna radiate the strongest signal? Answer, broadside to the antenna. So if we took a top-down view of this, you'd see the two legs of the dipole antenna. The antenna pattern would look something like this. So the strongest signals would be broadside to the antenna. Question, what is the approximate length in inches of a half wavelength 6 meter dipole antenna? So let's see how to calculate that. So a half wavelength at 6 meters, you get 6 meters. A half wavelength is 3 meters. 3 meters times 39.6 inches per meter is 118.8 inches. Now, so you'd say, well, it's 118 inches. Well, not really. And there's a bunch of reasons, but it's actually about 5% shorter than what you calculate with this equation. So if you multiply this times 0.95, you get 112 inches. Just remember, you always got to remember that 5% fudge factor. And there's a whole bunch of reasons for that, and that is sort of beyond the scope of this class right now. But I'd be happy to discuss that at some other point. Or actually, I wrote a blog post about it. You can find out about it on my read my blog post on that. But 112 inches for a 6-meter dipole antenna. So the next most common type of antenna is, let me go back. Well, this question works for this antenna too. Question, which of the following increases the resonant frequency of a dipole antenna? Answer, shortening it. So what happens here? I'll go back to it. So when you put up an antenna, like any dipole, certainly a dipole antenna, you really have to tune the antenna. By that I mean you have to adjust its length to get a proper match for coaxial cable. And there's a bunch of reasons for that, but sometimes you'll determine that the antenna is too long, sometimes it's too short. So and you always want the antenna to be, the resonant frequency of the antenna to be near the frequencies that you want to operate at, right? So if you determine that it's the resonant frequency is too low, then what does that mean? It means the antenna is a little too long and you want to shorten it. So that's the idea of this question. Which of the following increases the resonant frequency of a dipole antenna? Answer, shortening it. And why? Because the wavelength will be it will be resonant on is shorter. That means the resonant frequency will be a little higher. All right. So this is the quarter wave vertical antenna. Bob, if you could put your question in the Q&A box, that would work better for me, I think. As the name sort of implies, this is a quarter wavelength long, and usually it's operated against ground or some radials, and it's just, like I say, the second most common antenna in ham radio. Most of your HT antennas are vertical antennas. They're similar to this, but not quite. And there's a question here. What is the approximate length in inches of a quarter wavelength vertical antenna for 146 megahertz? Well, 146 megahertz is about 2 meters, right? A quarter wave would be 0.5 meters times 39.6 inches per meter. Oops, 6 inches per meter. That's equal to 19.8 inches times 0.95. And that gets you to 19 inches. One time in a class, I went through this calculation. There was one guy who just didn't want to understand it. I tried to explain it 2 or 3 different ways, and he just didn't get it. So after about 10 minutes of that, I said, look, just memorize 19 inches. I don't know if he passed the test or not. I should try and look that guy up. Okay, so even at a quarter wavelength, some antennas can get quite long, right? So let's take a 40 meter, the 40 meter example. If you had a quarter wave at 40 meters, that's 10 meters. So that's going to be about 33 feet long. So that's still kind of long for even a home installation, much less a mobile installation. So what we do to shorten the electrical length of an antenna is we put a coil in it. We call that coil a loading coil. And in this antenna, we might put that loading coil right here. So we break the antenna, put the coil in there, and then all the current would flow through the coil and into the antenna. That makes the antenna look electrically longer than it is. So question, which of the following describe, and because we call it a loading coil, the whole process is called loading. So question, which of the following describes a type of antenna loading? Answer, electrically lengthening by inserting inductors in radiating elements. All right. So let's talk about beam antennas. I should have had a slide for this, but I don't have a slide. A beam antenna, what a beam antenna does is it gives you an advantage in a particular direction, right? So a beam antenna will is built such that it forms the radio wave and puts more of the power in that radio wave in a certain direction. So let's just look at how that might work. So if this is a dipole, right, it has a pattern, something like this. Well, one type of antenna is called the Yagi, the beam antenna is called the Yagi antenna. It has other elements in addition to like a dipole. The dipole is still sort of part of this antenna, but it has more elements. And it takes that antenna pattern and makes it so that more energy is directed in this direction. So the antenna pattern for a Yagi antenna might look something like this. So you see, there's more energy being radiated in this direction than with a dipole. And this difference here in radiated power in this direction is called the gain of the antenna. And if this gain is like if I'm getting like twice as much energy radiated in this direction than I would with a dipole, what's the dB? Well, it's 3 dB gain. And you can see that's about what we got here, right? It's like almost twice. It's about 3 dB gain. So question, what is a beam antenna? Answer, an antenna that concentrates signals in one direction. Question, what is antenna gain? Answer, the increase in signal strength in a specified direction compared to a reference antenna. And in this case, the reference antenna would be the dipole antenna, right? Question, which of the following types of antenna offers the greatest gain? Answer, the Yagi antenna. So this is one way you might use dBs. You see what can happen here with the right antenna. Of course, the disadvantage of a Yagi antenna is that it's more complex, right? Instead of just a single wire stretching from one, like your house to a tree, which is like what I got here, you got to have 3 different elements here. In this case, we've got 1, 2, 3. And because it radiates in a particular direction, you have to be able to rotate it if you want to, talk to somebody in more than one direction. So that's beam antennas are great, but they do require more work. Let's put it that way. All right, they've got a question here. Let's see. Stanley asks, is this a directional antenna? Yes, a beam antenna is a directional antenna. All right, now let's talk about some other kind of antennas. Let's talk about the rubber ducks, actually, the type of antenna you'd get on an HT. So if you've seen pictures of HT, I should have a picture of an HT here, but I don't. Sorry about that. Most of them come with these cheap little antennas, right? And we call those rubber duck antennas. Why do we call them that? Because they're rubber covered. So some guy came up with that name, and it sort of just stuck. Those antennas are okay, but they're not really that efficient. And I'll give you an example. I bought a Baofeng one time, and I started playing around with it. And to reach the repeater from where I'm at, I had to use the high power setting. And after about 10 or 15 minutes, I happened to touch the antenna, and the antenna was hot. Well, really warm. I wouldn't say hot, but it was really warm. Well, what does that mean? That means that the antenna, instead of radiating my signal, was just turning it into heat. So those rubber duck antennas can be very inefficient. But yet you're still pouring power into them. So that power has got to go somewhere. And mostly what those antennas do is turn it into heat. So that's not a good thing. So question, what is a disadvantage of the short, flexible antenna supplied with most handheld radio transceivers compared to a full-size quarter wave antenna? Answer, it has low efficiency. That's why, a lot of times people will recommend like Nagoya, for example. It makes an antenna that's longer. And, in general, the longer the antenna, at least until you get to 19 inches, which is a quarter wave at 2 meters, the more efficient it'll be. And sure enough, I did purchase a Nagoya antenna, and it is a lot more effective. So there you go. Question, what is a disadvantage of using a handheld VHF transceiver with a flexible antenna inside a vehicle? Answer, signal strength is reduced due to the shielding effect of the vehicle. Yeah, well, think about that. If you're in a car, you got a metal cage around you, right? That metal cage is going to shield any signal that you're transmitting from getting out of the vehicle, and conversely, shield any signal being radiated by the repeater or some other ham station from getting inside the vehicle to the antenna. So the best option, if you're going to operate mobile, is to always have an external antenna. And what type of antenna? Question, what is an advantage of a 5/8 wavelength whip antenna for VHF or UHF mobile service? Answer, it has more gain than a quarter wavelength antenna. So that just means it'll be a little bit more effective when you're operating mobile. All right. Let's talk about feed lines and connectors. So these are two examples of the different types of coaxial cable that we use in ham radio. And coaxial cable is the most common type of feed line for a number of reasons, which I think there's a question on. Question, why is coaxial cable the most common feed line for amateur radio antenna systems? Answer, it is easy to use and requires few special installation considerations. You can run coax through ducts. You can lay it on the ground, and it won't affect it. I've done that in the past when I'm fooling around with antennas, and would just lay the coax on the ground. Of course, the bad thing about laying it on the ground is that if you have to be careful when mowing your lawn, otherwise you'll nick or even cut the coax. I've done that too, but that's, as far as transmission goes, it's okay to do that. Probably the most common, most important characteristic of a coaxial cable is its characteristic impedance. And the characteristic impedance in the impedance we use mostly in ham radio is 50 ohms. Question, what is impedance? Answer, the opposition to AC current flow. Question, what is the unit of impedance? The ohm. So like I say, we use 50 ohm coaxial cable. You can use 75 ohm coax, and I've done that, but it's not really as common as 50 ohms. And we'll talk a little bit about why that is, why you probably should use 50 ohm coax. Question, what is the most common impedance of coaxial cables used in amateur radio? Answer, 50 ohms. So, you know, we talk it up a lot about how good coax is, but it does have some disadvantages. Question, what happens as the frequency of a signal in coaxial cable is increased? Answer, the loss increases. So, you know, even though it's, you know, just a piece of wire, it sometimes can be a very long piece of wire, and you will have some losses inside the coax. So all the power you're pumping into the coax from the transmitter doesn't get to the antenna. And some coaxial cables are better than others. So here's two 50 ohm coaxial cables, but the RG58, while it's fine at HF, you know, say under 20 megahertz, yeah, maybe higher, I don't know. But if you're under 20 megahertz, you're okay. But above that, you're going to get a lot of losses. So, you know, you want to use an RG8 coax for the higher frequencies, because it'll have lower losses at those frequencies. Question, what is the electrical difference between RG58 and RG213, which is an RG8 kind of class coax, let's put it that way? Answer, RG213 cable has less loss at a given frequency. And like I say, at HF frequencies, it's not so bad, but at VHF and UHF, it does become a consideration. Question, which of the following types of feed line has the lowest loss at VHF and UHF? Answer, air insulated hardline. So it's actually neither of these. If you are putting in a repeater system, you probably will want to get air insulated hardline, because that has the lowest loss at VHF and UHF. Question, which of the following is a source of loss in coaxial feed line? Answer, all of these choices are correct. Water intrusion into coaxial connectors, high SWR, and multiple connectors in line. So again, depending on your installation, you might want to sort of keep track of these factors and avoid them if possible. Because again, the whole idea here is to get the maximum amount of power from the transmitter to the antenna and have the antenna radiate that power, right? Moisture contamination really is probably the big thing, water intrusion into the cable, either via the connectors, and we'll talk a little bit more about that in a second, but also via the jackets. So the jackets can crack, you know, the coaxial cable is outside. So if your coaxial cable is going to be mounted outside, you want to make sure to get coaxial cable that's rated for outdoor use. Because what will happen is the ultraviolet radiation will cause the cable jacket to become brittle. If it becomes brittle, it'll crack, and then it'll allow water in there. And water in a coaxial cable is not a good thing. Question, which of the following causes failure of coaxial cables? Answer, moisture contamination. Question, why should the outer jacket of coaxial cable be resistant to ultraviolet light? Answer, ultraviolet light can damage the jacket and allow water to enter the cable. Air insulated hardline is also susceptible to moisture problems. Question, what is a disadvantage of air core coaxial cable when compared to foam or solid dielectric types? Answer, it requires special techniques to prevent moisture in the cable. So that's air insulated hardline has the lowest loss, but it takes more work. It takes more work to install it and use it. And once water gets into a air insulated hardline, it's not a good thing. We had that problem here in Ann Arbor, one of our repeater systems, and we ended up having to replace the whole feed line. All right. Let's talk about connectors. So there's two main types of, well, there's actually more than this, but these are the two we talk about on this test. These are the two main types of connectors: PL259 coaxial connector and the N-type connector. The PL259 is probably the most common type. It mates with the SO239 socket, and that's what's on most amateur radio equipment these days are SO239s. So question, which of the following is true of PL259 type coax connectors? Answer, they are commonly used at HF and VHF frequencies. Above VHF, they start to get kind of lossy, but again, they're still on most equipment, even VHF and UHF mobile transceivers. Question, which of the following RF connector types is most suitable for frequencies above 400 megahertz? Answer, type N. And you can see the difference between the two. The PL259 relies on the shell to make the second connection, and that's not a really controlled impedance there. Whereas the end connector, as you can see, it doesn't use the shell as the shield conductor, and so it provides a better impedance match all the way through the connector. So let's talk about SWR now. So one of the things I was saying is that the idea here is to transfer the maximum amount of power from the radio to the antenna, right? And to do that, we want the system to be what's called matched. What does that mean? When a system is matched, it means the radio's output impedance, which is generally 50 ohms, is matched to the coaxial characteristic impedance. That's why you want to use a 50 ohm coax here. And the antenna input impedance, and you want that to be close to 50 ohms. When that happens, we say the system is matched. And this system will have what's called a low SWR. SWR is standing wave ratio. And it's a measure of how well the system is matched. So, oh wait, I got my pages out of order here. Shoot. So question, what is standing wave ratio? A measure of how well a load, in this case the antenna, is matched to a transmission line. Question, what reading on an SWR meter indicates a perfect impedance match between the antenna and a feed line? Answer, 1 to 1. So when everything's 50 ohms, a SWR in this case will be 1 to 1. Question, what does an SWR reading of 4 to 1 indicate? Answer, impedance mismatch. Question, what is a benefit of low SWR? Answer, reduced signal loss. So that, like I said, that means that all the power that the radio is generating will make it through the coax, or at least as much as possible, and get to the antenna and then be radiated by the antenna. Question, what happens to power lost in a feed line? It is converted into heat. And what can cause power loss? Well, just the properties of the cable, but also an impedance mismatch. Question: why do most solid-state transmitters reduce output power as SWR increases beyond a certain level? Answer: to protect the output amplifier transistors. So what happens is when there's a mismatch, is that the power will get up to the antenna and then actually be reflected back down the line. That power has to go somewhere, right? When it gets back to the radio, that means the radio itself has to dissipate that power. And that can cause the transmitter transistors to operate hot and in some cases even fail. Except now, most radios have a way to monitor the amount of power being reflected back to it, i.e. when there's a high SWR condition. And in that case, it'll reduce the amount of output power, which means that less power will be reflected and have to be dissipated by the output transistors. So a friend of mine says they're making radios ham-proof, like idiot-proof, right? So just a way to protect the radios. I got my pages out of order here, so I'm trying to find them. So how would you measure the SWR? Well, you'd use an SWR meter. And and where you'd put the SWR meter is like right here. So the one way to tell if your system is matched is to use an SWR meter. One thing you have to do is to make sure you get the right type of SWR meter, though. Some SWR meters won't operate at certain frequencies and at certain power levels. So question: which of the following should be considered when selecting an accessory SWR meter? Answer: the frequency and power level at which the measurements will be made. Question: which instrument can be used to determine SWR? Now, you think the answer to this question is an SWR meter, but that's not a choice here. The correct answer in this case is a directional watt meter, and you'd put it in the same spot as the SWR meter. And what the directional watt meter will do is measure forward power, reverse power, and then there's an equation that you can use to determine to calculate the SWR from those two readings. But the answer to this question is directional SWR meter or directional watt meter. And the watt meter is an RF power meter. Where should an RF power meter be installed? Answer: in the feed line between the transmitter and the antenna. A bunch of things can go wrong here. And one of the questions is, what can cause erratic changes in SWR? Answer: loose connection in the antenna or feed line. So, any of the, all these connection spots are possible sources of failure. And it's even worse if you have a splice in there somewhere, because again, that's another possible source of failure. So now we get to we talked about, so one way you might want to determine what's going wrong if something is wrong in your system is by using what's called an antenna analyzer. What an antenna analyzer allows you to do is to make these kind of measurements without even hooking up to a radio. So if you disconnected the coax and connected the coax instead to an antenna analyzer, you can use this instrument to actually measure the impedance of the coaxial line and determine the SWR and all that before you actually put any power to it. These are really great devices. I'm not very intuitive when it comes to antennas, so having an antenna analyzer really helps me. I can make measurements and I can determine, what's going on with my antenna. So question, which of the following is used to determine if an antenna is resonant at the desired operating frequency? Answer, an antenna analyzer. And if you determine that you've got a problem with your antenna system by using an antenna analyzer, like say that the impedance isn't 50 ohms at this point for some reason, what can you do? Well, one thing you can do is buy what's called an antenna tuner. And we had a question about that before. Antenna tuner. And what the antenna tuner will do is make it look to the transmitter like a 50 ohm coax is connected here. The impedance might be different here, but at this point it'll be 50 ohms.
Hey Dan, we have a question in the YouTube chat.
Okay.
Are HT antennas all similar impedance, or do aftermarket options have a chance to damage radios?
Oh, you know what? So that's a good question, but I don't know about you. Maybe you also want to jump in there on this, but I've never had a situation exist where an aftermarket antenna damaged a radio. And why is that? Because these radios do have circuits that will prevent damage from happening. Mm-hmm. Now, that antenna might not work that well, but it's not going to damage your radio.
Right. And most handheld radios are 5-8 watts maximum power. Usually you got to run a lot more power through it to damage the finals back in there. So that's not very high power. So yeah, right. Same with you. I've never had that happen to me either.
Here's another thing about HT antennas, right? Is that, if you're walking around with an HT, that's not a very controlled environment, right? So the impedance is actually going to be changing constantly anyway. So that's why they have these protection circuits, because you just can't tell. So that's a good question, but it's probably not something to really worry too much about. All right. So question, what is the major function of an antenna tuner? Parentheses, antenna coupler. Answer, it matches the antenna system impedance to the transceiver's output impedance. So that's why I said it makes the radio happy. There might be something still funky going on in your antenna system, making it not as efficient as possible, but at least you can operate. So in addition to having an antenna analyzer, another device you might want is a dummy load. And let me get rid of all this. What does a dummy load do? So a dummy load, again, you disconnect the antenna and you run this thing into your dummy load. Only thing a dummy load is a big 50 ohm resistor. And it's designed to consciously turn all the radio's output power in the heat, just to dissipate it. Why do you want a dummy load? Because if you connect a dummy load to your radio, you can eliminate, assuming the radio operates properly, you can eliminate that as a problem, and then focus on the antenna system to figure out what the problem is. So question, what is the primary purpose of a dummy load? Answer, to prevent transmitting signals over the air when making tests. Question, what does a dummy load consist of? Answer, a non-inductive resistor mounted on a heatsink. So I think certainly every ham I think should have a dummy load, and I suggest antenna analyzers as well, because I like them. And that's really all we've got for this section. Let's take a lunch break, and we'll do a half hour. Let's say come back at in my time, 1:25, 1:30, and then we'll get through the rest of it.
Okay, that sounds good. All right, so lunch break for everybody. for 30 minutes. It's 11:55 in Texas right now, so 12:25 Central Time, 1:25 Eastern Time. I guess that'd be 10:25 a.m. on California on the West Coast. So you guys let us know if you have any questions. I'll hang out here for a few minutes. I did. Yeah. I'm sorry. Go ahead, Dan.
Yeah, I'm gonna go get a sandwich and I'll be back too. So if
okay.
Anybody has questions, feel free to ask.
Sounds good. I did get a scheduled testing time from Steve, KO4AFL, who's going to be coordinating some testing at the end of the day today. If anyone's confident enough and wants to take a test today, if you don't want to do that today, I mean, it's not part of the curriculum, so it's really totally up to you when you want to take a test. So you can go sign up here. Let me find that link again. There it is. I'll put that link in the Zoom webinar and also in the YouTube chat. Right there and right here. So go check that out. It's scheduled for 7 o'clock tonight, 7 o'clock Central Time, 8 o'clock Eastern Time. Hopefully we'll be done by then. I don't know. You'll be done. You'll be done by then. Okay. So Dan says he'll be done, but y'all can't hear him right now. But he says we will be done by then. So, yeah, I knew it was. You said about 8 hours, Dan, but I wasn't sure if you were. You know, I mean, it seems to be flowing pretty well today, and not a lot of questions to stop and pause with,
right?
Which is good and bad. I mean,
once we get to the operating point parts, especially the rules and regulations, we go pretty fast.
Okay, good. So yeah, if y'all are comfortable enough with that, you can go sign up at for the testing session tonight at 7 p.m. Central Time. Once again, I said earlier that we would be giving away a radio tonight, which is, well, let me share this screen first. This is what the remote ham session looks like. If you click on the link I just shared in both the chats, this is what it looks like here. Duration is 2 hours. It won't take that long for most people. That's just the time they set aside. 7. I apologize. He says 7 o'clock Eastern Time. I misread that. So hopefully we'll be done by 7 o'clock Eastern Time. But I'll confirm with Dan when he comes back.
We will be done by then.
You'll be done by 7 East? Okay, so that's an hour earlier than I said a minute ago. Okay. All right, so we'll be done by 7. Yeah, so this is scheduled for 7 o'clock Eastern Time. If you guys don't want to go to this session, you want to schedule something for a few days from now, just go to hamstudy.org/sessions. Take out this last part here, and you can find all kinds of classes right here, both in-person classes, if you can find one near you, or remote virtual classes where anyone from anywhere can take it. So there's that right there. And I know I'm just showing this on, let me share this in Zoom right now as well. Start my video. Show self view and pin. Okay, sorry about those guys in the webinar. Now you can see what YouTube is seeing. Brian's asking, can we view the video live after the session is finished? Absolutely. Yeah, it'll be replayable on this channel forever, just like every live stream I've ever done. So this is one of the things that's one of the good reasons. That's one of the reasons I wanted to do a live stream, because it would be playable afterwards. So yes. What is an FRN number? I forget what that stands for. It's basically a number that the FCC supplies to you and identifies you with on any license you ever get. Amateur radio license, GMRS license, if you ever get a radar license or anything like that, some kind of commercial license. I'll get, I don't know if that's part of Dan's curriculum or not, but I'll get a link where you can go register for an FRN number. I don't think it takes very long to get. Glendon asks, are there any plans to do general and amateur extra classes? Okay, so I'm glad you asked that. That's one of the things I meant to talk about this morning. So the way that the question pool works is that the question pool changes every 4 years. So this year, this is 2022, the question pool for the technician updated. And there was only about, I think, 10 or 15% of the questions that changed or updated. Most of the questions remain the same. Maybe 20% at the most, something like that changed. So this year, the question pool for the technician changed. Next year in July, the general pool will change. The following year in July, 2024, the extra pool will change. And then they take a year off, and then they go back to the technician pool, which will be 2026, I guess. Okay, so The general and extra classes are already on my channel. I recorded the general class from the Hearst Club and the North Richland Hills Club here in North Texas 2 or 3 years ago with the current question pool that's still good until July of next year. The extra class I recorded from the North Richland Hills Club, and it's good until 2024. So those are already on the channel. I'll get some links to share with you guys, and I'll send out a follow-up email with all the links that we talk about today, all the sponsored links, the testing session sign-up links, the general and the extra classes and everything. So I'll send all that out. But those are already on my channel in a playlist, so I'll get those for you. Does ham need a different FRN than GMRS? No, it's the same. You need one FRN for everything from the FCC. Federal registration number. Thank you, Jesse. Yeah, same FRN for all licenses, does not matter. That is correct. All right, so we spoke about earlier about the Oshang KG UV9 Papa X-ray, which we will be giving away one of those towards the end of the session today. In addition to that, Baofeng Tech is another sponsor of this show, and they asked to sponsor this live stream series as well, and asked me to talk to you about this UV5x3. Now, this radio has been out for a while. It looks just like a UV5R. Some of you might have a UV5R, but Baofeng Tech is a company in one of the Dakotas. I always forget if it's North Dakota or South Dakota. But it's a USA company. And they do a lot of design and revamping of Baofeng radios, which are Chinese radios. And this one right here says, don't let the appearance fool you. The BTEC UV5x3 is the only radio in the series with new firmware features and menu updates while maintaining the same classic design to allow full backward accessory compatibility. So if you have any speaker mics, extended batteries, earpieces, whatnot, antennas, for your UV5R, they'll all fit this radio. The great thing about this radio is it incorporates the 220 megahertz band, which as a technician you can use. You can use anything over 50 megahertz, which is 6 meters. 6 meters, 2 meters, 1.25 meters, which is 220, 70 centimeters, which is 440, and a bunch of stuff above that. So the UV5x3 is a great little radio. I purchased one myself like 5 years ago, back before I started to get real heavy into YouTube, and I still use it today. It works great. I take it to my hunting lease because there's a really nice 220 repeater out there, but we talk to each other on 146.52 simplex, and there are also some 440 repeaters in the area. So this is going to be built better. It has better sound, better front end rejection, better quality control than some of your $25 to $30 Baofeng radios that you get on Amazon. Someone mentioned that they in the chat earlier that they used a UV5R, and they're like, well, don't laugh at me, but I use a UV5R. I'm like, that's a great entry-level starter radio. When I got into ham radio in 1994, the cheapest radio I could get was a Radio Shack HTX 202, which was $189. It did 2 meters only and only had 16 channels in memory. So the Baofeng UV5R for $27 to $30, which is dual band, 128 memory channels, is a heck of a entry starter radio to get into ham radio with. Much lower price than what I had available to me when I got licensed. But this UV5x3 is great because it incorporates a third band, so you get 3 places just to talk instead of 2. And once again, that is thanks to Baofeng Tech out of, I want to say it's North Dakota. It might be South Dakota. I don't remember. But they're a USA company. I'll share that link in the chat right there. And I will share that also in the webinar. Okay, there is a link for FRN for testing on the website. Just didn't know what it was. Yeah, okay. Hopefully we answered that. Norm, let me know if I didn't. So special thanks to Baofeng Tech for sponsoring this live stream for new technicians. And special thanks to BetterSafeRadio as well. So I don't remember if I mentioned this up front, but BetterSafeRadio has a constant coupon for everyone, for all of my viewers. The coupon code is HR2all7. So while we're going to give one of these radios away, they've got a lot more stuff than just that. They carry commercial band and GMRS radios as well. If anything you purchase from BetterSafeRadio.com, if you use the coupon code HR2all7, so HR like ham radio 2, all the word all, ALL, and then the number 7, it will give you a 7% discount off of everything on their website. And I mentioned earlier about email signups. This is what the page will look like when you sign up on my email list, name, email, and call sign. Call sign's not required if you don't have a call sign yet. Just leave that blank or put NA or something like that. You can sign up on my email list and get updates on stuff that's happening on the channel, upcoming events, upcoming class. Like I sent an email out to my email list about a week ago telling people about this class today. So notifications of stuff like that happen a lot. Is the UV53 as wide-banded as the UV9 Papa X-ray, though? I've had my eyes on the UV9P for a while as a versatile ray. No, it is not. So the UV9PX is going to be much more wide-banded and have a lot more receive frequencies than the UV5x3. The UV5x3 will transmit on 1.25 meters, while the UV9PX will receive only on 1.25 meters. So there is that. But no, it's not as wide-banded as the Oshang. The Oshang's more expensive, but it carries a lot more features with it. So that is that. Okay. I think we're good there. And let me find, go over here. So we got about 20 minutes, about 15 to 20, well, about 20 minutes. So anyone with a question? What time will be for... Rod, I see your question in the Q&A. I don't understand what you're asking. What will be time for Macon, Georgia class tonight? I don't understand what you're talking about. Anyone else? You guys be sure and take a break and go get yourself something to eat, something to drink. No, Gary, there's not a way to sign up for the radio. I'm going to do a random drawing from the people who are in the Zoom webinar today. Now, after today, BetterSafeRadio has been gracious enough to donate one radio per month for the next 11 months, and that one will be open for everyone to sign up for, and one random winner picked on a different live stream once a month for the next year. So, but today it's going to be exclusive to the Zoom webinar folks. What time will the class start tonight? Rod says it starts at 7 p.m. Eastern time, which is 6 p.m. Texas time. And that'd be 4 p.m. West Coast time. Yeah. Central Joint Professional Firefighters, thank you for being here today. Yeah, 7 p.m. Click on that link that I said, that hamstudy.org link that I put in the webinar chat. And it'll tell you everything you need to know on that webpage. No problem, Jared. Thank you very much. Let me find those general and extra class links for you guys. Let's see. Pump. Okay. Okay, there's that one. General class. Okay, here's a playlist for the general class. This is a playlist. There's 4 videos in this playlist. And then the extra class. And there's about 9 videos in this playlist. The extra class is longer because the question pool is larger. There's that there. Okay. I saw your video on the 6 best radios. Which one do you recommend for the Aries EMA emergency management, I assume? Probably that UV9 Papa X-ray, because it comes pre-programmed with a lot of those frequencies already. So that one's good. I mean, all of the 6 best radios, I like them all, and I own, I think, all but one or two of them. So you're not going to go wrong with any of them. But since the UV9 Papa X-ray comes with a bunch of channels already programmed, it's you'll be kind of a step ahead. Omar says, I'm just learning about ham radios. Is analog radio better for a beginner than a digital radio handheld? Thank you. Generally speaking, yes, although a lot of people get into amateur radio these days because they want to use digital modes like D-Star, Yaesu's System Fusion, DMR. They want to use these modes so that they can connect a hotspot or a repeater to the internet and talk to their friends in other states, other countries, overseas while traveling, something like that. So a lot of people get into amateur radio because of the digital modes today. And if that's you, then do that. Go get a digital radio. But typically speaking, most of your Aries and Races and storm watching stuff is always going to be done on analog. You're probably going to find more repeaters in your area on analog than you will on DMR or D-Star. So it really kind of depends on what you're trying to do. I would answer yes. Analog better for a beginner, yes, but not always. Most of the time, yes. There's that. Good. Excellent. Yeah, I gotta make a note of all these links so that we can share that. And like I said, I will send an email to those of you who signed up on this webinar email list. And there's like 68, 69, something like that signed up on that list. I'll send an email that. But I'll send an email to my main list as well. If you've signed up on my main list today, I've already gotten some emails saying that people have signed up on my main email list today. So thank you for following me over there. I'll send all these emails out, all these links that we talk about in this video today, along with the link to the replayable video itself. I'll send all that out to the main email list so that you guys can be sure and have everything there. Get the coupons for the Better Safe Radio. Get the hamstudy.org link for testing. If you don't want to test tonight, you want to test later on, you can get the link for that. That link is also good if once you want to take your general and upgrade tests. It's the same link to use to schedule a test for any of the 3 classes. Okay, Bob. So Bob says, I bought a GT5R. Is there a big difference between that and the UV5R? So the GT5R is supposed to be Baofeng's attempt to fix a lot of the spurious emission issues with the UV5R. It's supposed to be better performance, cleaner signal, better front-end projection. I have not used a GT5R myself, but I've watched a couple of videos from other YouTubers who I know and trust, and they say that it does do a little bit better than the UV5R. So yes, I would say that if you want to keep from interfering with radios near you, or splattering on, I don't know if anybody uses answering machines or not, but we used to get interference when we were running HF. We used to get interference, and the neighbors would call us and say, hey, you're coming across the speaker on my answering machine. All right, so we'd have to turn the power down. But yeah, so it's going to be less interference wise for stuff like that, and it's going to be a better option from what I've seen so far. Aaron says, once we get our tech license, how do you suggest we pick a radio? HT, base, mobile, and antenna. What do you want to do? Do you want to carry a radio around with you everywhere you go on your belt that you have access to all the time that's only 5 or 8 watts? Or do you want to put something in your car? Most people start with an HT. They're less expensive. You can sit on your couch at home while watching a movie and play with it and try and learn programming it and maybe talk on a repeater that's close to your home. But the mobile radio experience is one that is much more, will reach out a lot farther because it's a more powerful radio with an external antenna on your vehicle, and they're great during drive times if you have an active repeater in your area. So most people start with an HT, but that doesn't have to be the case. If you drive a lot, if you drive for a living, I know truck drivers who have ham radio licenses. I know people who, if you do Uber a lot, something like that, or if you're a delivery person of some sort and you're going to be in the car all the time, you spend most of the day in the car, then a mobile radio would be a great first choice for your first radio. I have videos on my channel, best HT for 2022 and best mobile radio for 2022. Those are my personal picks, what I think is the best, and I kind of do a comparison between all those. So just search my channel for that, and you can find those out there. You want to send me an email, I'll send you the links directly to them. I have to go find them, but they're on the channel. It's not quite that cold here, Dan. Dan says it's 35 degrees and snowing in Ann Arbor, Michigan. We won't see snow until probably maybe around Christmas, but usually not until like February is when it snows in Texas. If it snows here at all. It'll snow about once every 2 to 3 years. Something like that. Yeah, I bet it does. I bet it does. You're quite a bit farther north than I am. Okay, let's go figure out how to do this again. There we go. Cool. Okay. Well, we got about 10 minutes left in the lunch break, guys, so hopefully everybody's gone and got some refreshments and whatnot. Do let me know if you have any other questions, either in the webinar chat or in the Google chat. When will we do the giveaway? Gavin is asking, maybe around 4 or 5 this afternoon. Probably during the last break of the day. I'll probably do it during the last break of the day, whenever Dan decides that's going to be one last break until we end this evening, late this afternoon, this evening, whenever that is. We'll probably do that then. Mm-hmm.
User or readers or listeners or whatever you want to call them.
The YouTube viewers?
Yeah.
Yeah. Yep. Yeah, YouTube has a really good analytics machine built into the back, what they call the YouTube Studio. And it has a good information on that. I have like 96% are male, about 4% are female. And I think that's typically true throughout most of the other YouTube channels as well. Most of my viewers are in the United States, but I've got a good number of viewers either in Canada, South America, or some over in Europe. And most of them are probably in the 45 to 65 age range. So, which of course, you're hoping that with new people coming in, they're a little bit younger demographic. But I mean, it's for everyone, obviously. But
Yeah, that's who's getting in the ham radio.
Right. Right. Correct. Is there a mobile that is as versatile as the UV9 Papa? Do you mean as versatile? Do you mean as pre-programmed like that? Not that I've seen. No. Waxon Oshang, they make a UV 980 Papa. That's their quad band, I think it is, mobile radio. I don't think BetterSafeRadio sells that one, but it's made by the same company that builds theirs. But it's not pre-programmed. You have to program everything yourself. Okay, guys, we've got about 4 minutes left. It's a fast 30 minutes, really. I thought the morning's been going well, though. I think everything's flowing pretty good, Dan. Yeah.
Hopefully our viewers think so.
Yeah. I haven't, like I've seen, I haven't really seen that many questions, which I think is good. That means you're explaining everything well. But you guys definitely don't be bashful about asking questions if you have a question about something. I'm with you, Glendon. Yep. Okay. About 29 people in the Zoom webinar now.
See this video over again if you'd like, and or you can email me with questions. So
right, yeah. Dan has his email address at the bottom of every slide, like he said, or most every slide. Okay. Can Radio HT talk further than GMRS HT due into other frequencies available on ham radio? It's possible that you could get a little bit further with VHF than with UHF, which GMRS is UHF, and ham radio has UHF and VHF and a lot of other stuff as well. So it's possible that's true. Generally speaking, outdoors, VHF is going to go farther, and UHF is better for like indoors. GMRS being a business use band for a lot of people, works better inside of buildings. It'll penetrate steel and concrete a little bit better. But farther range line of sight is usually VHF, but it really depends on ionospheric conditions and propagation, like Dan was talking about at the beginning of the class. So there's not a good answer to that question. You have more options with ham radio than you do with GMRS, because GMRS is limited to one band, 460 megahertz in the UHF range. There's 22 GMRS channels, and that's it. With ham radio, you get multiple bands. So if one band's not working, you can change to another one. You can't do that in GMRS. So now, there's nothing wrong with GMRS. I have my GMRS license, and I used it a bunch the last road trip I took. But ham radio is definitely more versatile and have a lot more options with ham radio than you do with GMRS. Is that okay? All right, we're just about there. Appreciate everybody being here today. Once again, the link to the PDF file that Dan is following is at the top of the YouTube chat. It's a free PDF download called the No Nonsense Study Guide for Technicians to get your first ham radio technician class, or technician license, I should say. Dan, I show 1225. You ready?
I'm ready to roll.
Okay. It's all yours.
Thank you. So this next chapter covers signals. And like, what do we do in ham radio? We generate signals and we receive signals. And we can, Jason was just talking about how much more versatile amateur radio is than, say, GMRS. Well, GMRS, uses FM, right? And in amateur radio, we can do FM, AM, all kinds of digital modes, and we can even do television, all those things we can do in ham radio. And so that's what we're going to talk about a little bit about here now. So having said that, of course, one of the first things you'll probably do as technicians is get a FM radio. Well, what does that really mean? FM stands for frequency modulation. And modulation is a way that we sort of imprint, if you will, information on a radio signal, right? I mean, you could generate radio signals all day, but unless you have some way of conveying information over that signal, it's kind of useless. And that's what modulation is all about. So the two main types, if you will, are FM, which stands for frequency modulation, and AM, which stands for amplitude modulation. And if you look at this chart, you see sort of the difference between the two. In FM, or PM as well, PM is a type of FM, you're actually changing the frequency of the signal with the modulating signal, i.e. the voice, your voice. Whereas in amplitude modulation, you're not varying the frequency, but rather the amplitude of the signal. And there's different permutations of that, one of them being single sideband, which we'll talk about in a bit. But anyway, question, which type of modulation is commonly used for VHF and UHF voice repeaters? Answer, FM or PM. Question, what type of modulation is commonly used for VHF packet radio transmissions? Answer, FM or PM. And packet radio is digital information, but it's encoded as audio tones, so that you can still use FM for that. All right. Now let's talk a little bit about AM. So one of the things you get with, oops, I don't want that. Sorry about that. One of the things that happens with AM is that when you amplitude modulate a signal, you generate two sidebands. And what those are actually two signals on either side of the center frequency. So if I was amplitude modulating a signal with a 1000 hertz tone, I would get actually these three signals out of it. Something on the center frequency or carrier frequency, a signal 1000 hertz below the carrier frequency, and 1000 hertz above the carrier frequency. And there's no information in the carrier frequency. It's just the plain old radio signal. And the two sidebands are sort of duplicates of one another, just on opposite sides of the carrier frequency. So some smart guy in about World War II timeframe said, hey, you know what? Let's get rid of the carrier frequency and the lower side, one of the sidebands, in this case, the lower sideband, and let's put all our power, I guess that's not very well drawn, all the power into one of the sidebands. And this turned out to work very well. And it's a lot more efficient because we're putting all of our power into the signal that carries the most information. We call this signal a single sideband signal. And like I said, it's a form of amplitude modulation. So question, which of the following is a form of amplitude modulation? Answer, single sideband. Question, which type of voice mode is often used for long distance, weak signal contacts on the VHF and UHF bands? Answer, SSB. So that's SSB is just the acronym for single sideband. Question, which sideband is normally used for 10 meter HF, VHF, and UHF single sideband communications? Answer, upper sideband. So this would be the lower sideband because it's below the carrier frequency. This is the upper sideband. And just by convention, we normally use the upper sideband for voice communications when using sideband. Below on the 40 meter band and below, we do use lower sideband. There's a bunch of sort of historical reasons for that, but there's no technical reason. There's no technical reason to use one or over the other. It's just a convention. And like I say, most of the time we're using upper sideband. Question, what is a characteristic of single sideband compared to FM? Answer, single sideband signals have a narrower bandwidth. So in most transmitters, we filter the audio signal to be 3 kilohertz wide. And what that means is that the bandwidth of a single sideband signal is about 3,000 kilohertz, or 3,000 hertz, I mean. So single sideband in an FM signal can be anywhere from 10 to 15 kilohertz wide, or 10 to 15 kilohertz wide. Oops. So theoretically, we could fit maybe 5 single sideband signals into the bandwidth of one FM signal. So you can see it's much more efficient. Of course, it's not as, the audio isn't quite as good, but it is more efficient. So question, what is the approximate bandwidth of a typical single sideband voice signal? 3 kilohertz. What is the approximate bandwidth of a VHF repeater FM voice signal? Answer, between 10 and 15 kilohertz. And that's why, you can't, the only HF band you can operate FM on is the 10 meter band. And why is that? Because we have 1.7 megahertz of bandwidth up there. But take the 40 meter band, we only have 300 kilohertz. So there's no way we want to, put FM signals on the 40 meter band. It would just take up too much space. So to be efficient, when we're using voice, we use single sideband on 40 meters. Question, which of the following is a disadvantage of FM compared with single sideband? Answer, only one signal can be received at a time. So this is called the capture effect. And generally, the strongest signal at the receiver is the one that captures the receiver and the only one that the person listening to the receiver can hear. And that's why they still use AM, for example, for aviation. The international aviation uses AM because they can hear all of the planes on particular frequencies. So these are some of the things we can do. I mentioned we also can do television. There's a couple of questions about television. And when we're talking about television in these questions, we're talking about the old-fashioned amplitude modulated, very wide band signals. So question, what is the approximate bandwidth of AM fast scan TV transmissions? Answer, about 6 megahertz. So you see that's quite a bit more than 3 kilohertz or even 15 kilohertz. Question, what type of transmission is indicated by the term NTSC? Answer, an analog fast scan color TV signal. NTSC stands for National Television Standards Committee. Okay, so we talked about Morse code a little bit before. So, as technicians, you guys can operate, once you get your license, Morse code or CW on the 80 meter, 40 meter, 15 meter, and 10 meter bands on HF, and anywhere in the VHF region for that matter. But so there's a few questions about CW operation. Question, what is CW? Answer, another name for a Morse code transmission. CW stands for a continuous wave. Which of the following types of signal has the narrowest bandwidth? Answer, CW. So a CW signal can range from, 150 hertz and, maybe to 200 hertz. So you can see we could fit, theoretically fit 15 CW signals into the space of a sideband signal and, 75 CW signals in the bandwidth of an FM signal. Question, what is the approximate bandwidth required to transmit a CW signal? Answer, 150 hertz. Now, how do you send CW? Well, we all seen the old kind of hand keys. We call those straight keys in ham radio. But a lot of folks are now using what are called keyers. Keyers are electronic devices that send very consistent dots and dashes. So question, what is an electronic keyer? Answer, a device that assists in manual sending of Morse code. All right. So let's talk about digital now. There's some confusion, I'd say. I wouldn't, it's not that bad, but we use the term digital modes for some things that are not really related. Like some people would say DMR and D-Star are digital modes. And, they are digital, they are sending digital signals, but they're not digital in the way, that say FT8 is, or even packet radio. So there's a little bit of confusion about that, but just bear with us here and we'll explain this. So question, which of the following is a digital communications mode? Answer, all these choices are correct. Packet radio, IEEE 802.11, and FT8. So all these choices are correct. One of the digital communications mode is called packet radio. And the reason we call it packet radio is because we're actually sending packets of data. And this diagram here shows a packet of data. It consists of different parts. There's a flag that basically says, hey, I'm sending a packet, a header which contains some information about the packet, the payload which contains the actual data, and then some kind of checksum or check to make sure that the data was received properly. So question, which of the following is included in packet radio transmissions? Answer, a checksum that permits error detection. That's the check here, the CHK. A header that contains the call sign of the station to which the information is being sent. An automatic repeat request in case of error. So that's not shown here specifically, but a request would take the form of a packet, actually. So the answer to this is all these choices are correct. Now talking about, excuse me, talking about automatic repeat request, sometimes we call that an ARQ transmission system. Question, what is an ARQ transmission system? Answer, an error correction method in which the receiving station detects errors and sends a request for retransmission. So if we were operating a packet station, passing data back and forth, if my receiving station did not receive a packet correctly, as indicated by the checksum, I would send the transmitting station a packet saying, hey, resend that last one. Okay, another type of digital mode, if you will, that uses packet radio as a base is called the Automatic Packet Reporting System, or APRS. And you can do all kinds of things with APRS. So, question, what kind of data can be transmitted by APRS? Answer, all these choices are correct. GPS position data, text messages, and weather data. Now, mostly we use it for sending GPS position data. And if you go to I think it's aprs.fi, you'll see all of the APRS stations that are transmitting their locations. And you can follow them on a map. So question, which of the following is an application of APRS? Answer, providing real-time tactical digital communications in conjunction with a map showing the locations of stations. So how would you use this? Well, here in Ann Arbor, our club provides communications for a local bike tour. And we have ham radio operators in the SAG wagons, which are out there to provide aid to, riders in distress. They all have APRS. So at the net control station, we're able to see where these stations are. And if one of the riders should call in saying that they have a problem, flat tire or whatever it might be, we can look on the map, see which SAG wagon is closest to the person needing help, and then dispatch that person to the rider. And that all works pretty slick. So that's how you'd use APRS for that application. PSK 31 used to be a big popular mode. It's not quite so popular anymore, but there's a question here. What does the abbreviation PSK mean? Answer, phase shift keying. So it's another kind of modulation technique. And what they're doing is not so much changing the frequency or the amplitude, but actually changing the phase. So I can show you here. So they transmit a tone, but at some point they change the phase. Oops. I need to get a real diagram for this. Or do it slower. So here's the points where we've changed the phase. And where those points happen in time tells the receiving station what the ones and zeros are being sent. So that's what they mean by phase shift keying. DMR. DMR is another sort of buzzword in ham radio these days. What does that mean? It stands for digital mobile radio. Question, which of the following describes DMR? Answer, a technique for time multiplexing two digital voice signals on a single 12.5 kilohertz repeater channel. And that's kind of the cool thing about DMR. You can actually have two conversations going on, and neither will hear the other, but still there's enough bandwidth for these two things to happen. And one of those channels may be connected via the internet to some other repeater in some other country, for that matter. And it's all because we can time multiplex these two signals. So the one of the users gets a time slice, the next user gets the next time slice, and back and forth and back and forth. And because all the data is digital, the radios can recreate the voice signals from the digital information. One of the previous questions referenced FT8. So FT8 is another sort of phenomenon in ham radio. In fact, I've heard it said that more than 50% of the contacts being made on HF are now FT8 contacts, which is like incredible to me. But one of the reasons for that is because it can operate in very low noise and very poor signal conditions. And so a lot of people are finding it nice to be able to make contacts, even if they don't have very good antennas or if band conditions are poor. So question, what is FT8? Answer, a digital mode capable of low signal to noise operation. And it really is amazing. I mean, the key to this, of course, is that the computer is doing a lot of fancy digital signal processing on the signals to actually pull the signals right out of the noise. And signals you can't hear, the computer can figure out what's being sent. And that's what makes it kind of amazing. To run FT8, to be able to run FT8, you need what's called WSJTX software. And this is freely available on the internet. So there's no problem with that. But and in addition to FT8, it has a lot of other different modes that are tailored specifically to certain applications. Question, which of the following operating activities is supported by digital mode software in the WSJT-X software suite? Answer, all of these choices are correct. Earth, Moon, Earth, weak signal propagation beacons, and meteor scatter. So we talked about meteor scatter before. If you want to do meteor scatter, get this WSJT-X software and you'll be able to do meteor scatter. It really is kind of amazing, this FT8. All right, now let's talk a little bit about mesh networking. So this is another sort of digital thing we can do. We can set up our own networks over the air and network stations together. We're here in Ann Arbor. We are setting up our own mesh network, and we've got a node at all the local repeater sites, and a lot of our members are buying equipment so they can connect into this network, and we'll be able to use the network even if the internet goes down. So we'll see how that works. But whether it really works in practice or not, it still is a lot of fun to do. But mesh networking, one of the biggest I should say the most popular software being used for mesh networking is something called ARDN, AREDN, which stands for Amateur Radio Emergency Data Network. And the question here is, which of the following best describes an amateur radio mesh network? Answer, an amateur radio-based data network using commercial Wi-Fi equipment with modified firmware. And see, that's one of the key points there, is that all these nodes that you see here are using just regular wireless networking hardware, but the firmware in those units has to be modified. And the reason for that is there's no encryption allowed in amateur radio. So that firmware has to be modified to basically take out the encryption. So there's a big debate about whether or not that should be so, but that's sort of an ongoing thing. But at this point in time, there's no encryption allowed on amateur radio. So this diagram is a little out of date. I'm going to have to modify it. And the reason for that is, unfortunately, amateur radio operators can no longer use the 3 gigahertz band. So I'm going to have to change these frequencies here. But this is kind of a fun thing to do. And if you live in an area where a club is doing this, you can do it. Question, what about scrambling? No, that is the way the rule is written is you cannot legally, they don't say encrypt, they say something about obscure the meaning of a message. So if the vocoder uses a known algorithm and that's publicly available, then that's possible, but otherwise not. I mean, because what are you doing with digital voice? You're doing basically the same thing, right? You're taking the audio, encoding it somehow, and then transmitting it. Well, some might say that that's obscuring the meaning of a message, but the way the rule is, as long as the means to decode that message is available, then that's perfectly legal. So I hope that answers your question. All right. Now let's talk about safety. So in a way, this, excuse me, in a way, this is the most important part of the class. I mean, if you kill yourself, it doesn't matter what kind of license you have or what you can do with a ham radio license, right? So, and unfortunately, I'm kind of laughing, but unfortunately, every year you read stories about some amateur who is seriously injured or even killed in the course of pursuing ham radio. And most of these have to do with antenna work and tower, falling off towers and such like that. But still, there's still some things you want to be aware of so that you can do them safely. And the first thing we'll talk about is electrical safety. So, question: what health hazard is presented by electrical current flowing through the body? Answer: all these choices are correct. It may cause injury by heating tissue. It may disrupt the electrical function of cells. It may cause involuntary muscle contractions. So all these choices are correct. And, it doesn't take that much. Like there used to be questions on the test about what the voltage level is, safe. And it was like 30 volts or something like that. It doesn't take a lot of voltage to cause current to flow through the body. And once that happens, it doesn't take much current to really cause problems. It's on the order of hundreds of milliamps, not like amps. So you got to be careful. You got to be careful. Question: so the first thing you need to do is make sure wherever you're going to install your station that the electrical system, the electric supply, is properly wired and is safe to use. So question: in the United States, what circuit does black wire insulation indicate in a 3-wire 120-volt cable? Answer: hot. So the black wire is the hot wire. What is a good way to guard against electrical shock at your station? Answer: all these choices are correct. Use 3-wire cords and plugs for all AC-powered equipment. Connect all AC-powered station equipment to a common safety ground. Install mechanical interlocks in high-voltage circuits. So all these choices are correct. When I moved to Ann Arbor, I moved into a house that was built in the 1950s, and it had just 2-wire electrical wiring. And so before I could get on the air from that location, I had to rewire the room where I was going to put my station to have 3-wire, 3-prong outlets. And it wasn't too hard. That was a little bit of work, but I was safe. It's much more safe. Question: what is the purpose of a fuse in an electric circuit? Answer: to remove power in case of overload. So one of the things I want to say here is in this safety section, if you get safety questions, the answers are almost going to be like obvious. Always choose the most conservative answer. The conservative answer is always the right choice. Question: where should a fuse or circuit breaker be installed in a 120-volt AC power circuit? Answer: in series with the hot conductor only. And you see in this diagram, that's exactly where it is. That breaker is in the hot wire. Question: remember, why should a 5 I always laugh at this one. Why should a 5-ampere fuse never be replaced with a 20-ampere fuse? Answer: excessive current could cause a fire. Question: what hazard exists in a power supply immediately after turning it off? Answer: charge stored in filter capacitors. So, we said before that capacitors can store charge, and they store it in the electric field. Well, some power supplies that are made to supply 30 or 50 amps have big capacitors, and which can store a lot of charge. So even once you turn them off, there may be voltage present across the outputs. So before you do any kind of work with that power supply, or if you're rewiring your station or whatever, always make sure that there's no voltage there. And even if you turn it off and then unplug it, you can't be sure of that. I always take a multimeter and measure the voltage, and I make sure it's 0 volts before I get in there with a screwdriver or wrench or something. batteries, batteries can be really dangerous, right? So like I said before, we use a lot of batteries in ham radio. Question, which of the following is a safety hazard of a 12-volt storage battery? Answer, shorting the terminals can cause burns, fire, or an explosion. Yeah, we talk about a screwdriver or wrench. You don't want to get that screwdriver or wrench across the terminals of a battery. Question, what hazard is caused by charging or discharging a battery too quickly? Answer, overheating or outgassing. And, we know about lithium batteries, right? They can cause fires. All right. Oh, should have shown this one, my battery safety slide. All right, now let's talk about antenna and tower safety. Like I said, the majority, I think, of people who are injured doing ham radio are as a result of doing tower work. So always, you need to have the right equipment and be sure to have a helper and all those kind of things when doing any kind of tower work. Question, which of the following is an important safety precaution to observe when putting up an antenna tower? Answer, look for and stay clear of any overhead electrical wires. So, I mean, again, this is kind of common sense, but it's really true. If you're going to install a tower, make sure it can't fall such that it, falls across a electrical power line. Question, what is the minimum safe distance from a power line to allow when installing an antenna? Answer, enough so that if the antenna falls, no part of it can come closer than 10 feet to the power wires. Question, I get a kick out of this question too. Why should you avoid attaching an antenna to a utility pole? Answer, the antenna could contact high voltage power lines. So again, this is the most safe answer. Now, having said that, I have a friend who grew up in Brooklyn. And really, the only place he could attach that antenna wire was to some utility pole, which he did. And he got away with it for a while. I forget how long he said. But eventually, the power company came by and disconnected his antenna. But that's, he's still alive, fortunately, but that was not a good practice. Oh, hang on. Sorry about that. Where was I? Okay. Question, what hazard is created by touching an antenna during a transmission? Answer, RF burn to skin. Now, I have to admit that I'm guilty of this. And I didn't think about it. When I was a kid, I had a vertical antenna, which I put up in my backyard, right by the house. Oh, this will finally quit. I put up right by the house, and I didn't think that if somebody could touch it and maybe get an RF burn while I was transmitting. So, fortunately, that didn't happen, but I was guilty of this. Now, some more tower questions. What is required when climbing an antenna tower? Answer, all these choices are correct. Have sufficient training on safe tower climbing techniques. Use appropriate tie-off to the tower at all times. Always wear an approved climbing harness. And you see that here, in this picture. The guy's wearing a climbing harness. He's tied off to the tower. So he's going to be safe. He's also wearing a hard hat, which is another thing to be sure to do. Question, under what circumstances is it safe to climb a tower without a helper or observer? Answer, never. Again, that's the most conservative choice, right? And finally, which of the following is an important safety rule to remember when using a crank-up tower? Answer, this type of tower must not be climbed unless it is retracted or mechanical safety locking devices have been installed. These crank-up towers are not really designed necessarily to support a human weight. So that's why they suggest making sure it's retracted or there's some other kind of mechanical device to prevent it from accidentally retracting when you don't want it to be retracting. Question, what is the purpose of a safety wire through a turnbuckle used to tension guy lines? This is more of an installation question than a maintenance question, but prevent loosening of the turnbuckle from vibration. Because with those guy wires, you want to make sure they're always sturdy enough to prevent the thing from tipping over. Grounding is a very important point for your station and for towers. Here's an example of a tower grounding. Question, which of the following establishes grounding requirements for an amateur radio tower or antenna? Answer, local electrical codes. So, if you have any questions about whether your installation is safe, consult an electrician. Which it's kind of odd when you think about it, but these fellows are supposed to know that. And you may have to search around a bit for someone who really has the knowledge about this, because this is kind of a different thing. It's not normal house wiring, but they should know about local electrical codes. Question, which is a proper grounding method for a tower? Answer, separate 8-foot ground rods for each tower leg bonded to the tower and to each other. So you see that here. So here's a 3-legged tower, and these are where the tower meets the base. And they all run directly to 8-foot ground rods, which are here. And if you look closely enough, you'll see that they're all bonded to one another. Oops. The whole idea is you want to try and keep the whatever voltage drop as low as possible. And if you take a direct antenna strike or lightning strike, there's a lot of current flowing. A lot of current, even with very low resistance, means there's some voltage drop there, and you want to make that as low as possible. Question, which of the following is good practice when installing ground wires on a tower for lightning protection? Answer, ensure the connections are short and direct. So here, they're short and direct. Question, which of the following is true when installing grounding conductors used for lightning protection? Answer, sharp bends must be avoided. There's so much energy in a lightning strike that they can actually jump the wire. And that's not a good thing, right? You want that all that energy to go right to ground. Question, what should be done to all external ground rods or earth connection? Answer, bond them together with heavy wire or conductive strap. And, like I say, that's what they're doing here. They're bonding them together. Question, where should a lightning arrestor be installed in a coaxial feed line? So another way to, if you don't have a tower, you still just have an antenna, you still may want to prevent a lightning strike from getting into your shack. Well, answer, on a grounded panel near where feed lines enter the building. So we actually have this, we put in a club station at a local museum, and this is what we did. So that we have a tower. Oh, geez. We have a tower, and there's a Yagi antenna up on top. Feed line runs down to a NEMA box at the base of the tower. And that NEMA box has the lightning arresters in there. So the feed line runs there, and then the coax runs into the building. So this NEMA box has a big metal plate in it, and that provides the grounding. The grounding then, the plate is then grounded right to the building structure, and that provides the safetiness. And so if you in your home, you could still do this. A friend of mine used to have a big metal plate near the window where his feed lines came in, and his lightning arresters were mounted on that plate, which was then connected to an external ground. right. Sorry, I missed the question. Do you need to ground a J pole? You know, some people might tell you so, but I really don't think so. You can get, when you say ground, I guess it depends what you mean. Like if you're going to mount that J pole external to your home, then you might want to get a lightning arrestor that's capable of operating at VHF and UHF frequencies, because that's also a concern. And then ground that, provide some kind of grounding for that lightning arrestor. So, it all depends how high up it is and stuff like that. But yeah, it's something to think about. And every case is different. All right, so let's talk about RF hazards now. Oop. Now, fortunately, radio waves are non-ionizing. That means they're not going to cause any genetic damage. So that's good. But there's still plenty of hazards in non-ionizing radiation. Question, what type of radiation are radio signals? Answer, non-ionizing radiation. Question, how does RF radiation differ from ionizing radiation? Parentheses, radioactivity. Answer, RF radiation does not have sufficient energy to cause chemical changes in cells and damage DNA. So take that for what it's worth. So having said all that, there's still precautions you have to take as an amateur radio operator with regard to RF hazards. And there's different ways to determine how hazardous your installation is. And basically, there's three ways to do this. One is to get FCC OET Bulletin 65. Let me write this down. FCC OET Bulletin 65. I would suggest that you all get this. It's free on the FCC website. It has a number of recommendations for determining your situation, and it's very practical in its approach. Two other ways of doing it is by calculation based on computer modeling and by actually measuring the field strength. Unfortunately, both of these two latter methods take a lot of expertise and can be expensive. Computer modeling software for this type of situation can be quite expensive. And even renting the equipment to measure the strength of the RF fields can be expensive. So FCC OET Bulletin 65 is really the way to go. Question, who is responsible for ensuring that no person is exposed to RF energy above the FCC exposure limits? Answer, the station licensee. So there actually are limits set in the amateur radio rules. And let me show you that. That's this chart here. This is right out of the FCC OET Bulletin 65. Question, which of the following, this is sort of the discussion I just made. Which of the following is an acceptable method to determine whether your station complies with FCC RF exposure regulations? Answer, all these choices are correct. By calculation based on FCC OET Bulletin 65, by calculation based on computer modeling, by measurement of field strength using calibrated equipment. So, like I say, FCC OET Bulletin 65 is really the way to go here. Question, what is the definition of duty cycle during the averaging time for RF exposure? So what all these exposure limits are about is how much radiation you're exposed to over what period of time, right? So for example, if you were exposed to a very high energy RF field for like less than a second, well, that's probably not too big a deal. If you're exposed to that same field for a couple of hours, well, that's a different story. So the this is where duty cycle comes in. So if the duty, what the duty cycle is a sort of a measure of how long the transmitter is on versus how much it's off. Right. So question, what is the definition of duty cycle during the averaging time for RF exposure? Answer, the percentage of time that a transmitter is transmitting. So if it's on for a minute, then off for a minute, then on for a minute, then that's 50%, right? Because it's on for 50% of any given period of time. Question, why is duty cycle one of the factors used to determine safe RF radiation exposure levels? Answer, it affects the average exposure to radiation. So the lower the duty cycle, the less radiation you'll be exposed to. And this next question is always like one of the hardest to explain, but stick with me here. So how does the allowable power density for RF safety change if the duty cycle changes from 100% to 50%? The answer is it increases by a factor of 2. Right. And so what does that mean? That means if you're being exposed to a certain level of RF energy, but at 100% duty cycle, meaning the transmitter's on all the time, then you can only withstand that energy or the exposure for a certain period of time. But if the duty cycle decreases to 50%, then you can withstand that field for twice as long. So I hope that makes some sense. This is always a kind of a hard one to explain. One of the factors about frequency or RF exposure is frequency, the frequency at which the RF radiation is occurring. And they vary with frequency. And oddly enough, the 6-meter band is probably the worst for RF exposure. You can, and the reason for that is the human body tends to absorb RF radiation at those frequencies more than at other frequencies. And you can see that in this chart, right? You know, and the VHF, all bands, the maximum transmitter power above which you have to do this RF exposure evaluation is only 50 watts. And that's because, again, the human body will absorb those frequencies more than say 80 meters, you know. So question, why do exposure limits vary with frequency? Answer, the human body absorbs more RF energy at some frequencies than others. Question, at which of the following frequencies does maximum permissible exposure have the lowest value? Answer, 50 megahertz. Question, what factors affect the RF exposure of people near an amateur station antenna? Answer, all these choices are correct. Frequency and power level of the RF field, distance from the antenna to a person, radiation pattern of the antenna. And notice here it says RF exposure of people, not your family or you, the operator. It says of people. And that means your neighbors. You know, if you live in a typical city kind of situation, you know, every time you transmit, your neighbors are getting exposed to RF radiation. And it's your responsibility to ensure that they're not getting an unsafe level of exposure. Question, which of the following actions can reduce RF exposure to RF radiation? Answer, relocate antennas. So if your evaluation determines that, hey, your antenna is probably too close to your neighbor's house, you know, you got to relocate, put that in a different place. You know, it's really what it amounts to. Question, how can you make sure your station stays in compliance with RF safety regulations? Answer, by reevaluating the station whenever an item in the transmitter or antenna system is changed. You know, anything there can make a difference. You know, if you're all of a sudden, you know, buy a linear amplifier, put up a beam antenna, all those things can affect RF exposure. All right, so that's the end of the safety chapter. Just like I say, be safe. You know, that's the key point here is operate safely and make sure those around your station are safe. And you know, the rules on this is sort of recently changed. And if you want to get really technical about it, even when you're setting up portable operations, you should, try and ensure you're being safe. Yeah, most portable operations, we're operating relatively low power, so that's not a factor. But say you want to do a summits on the air, and you're going to operate on 2 meters or 6 meters, and what does it say here? The power thresholds for routine evaluation is only 50 watts on those bands. So if you set up a 100-watt station, you should do some kind of evaluation to make sure you're operating safely. All right, that's that. Oop. Let's talk about station setup. So, when you get a license, you'll want to set up a station. A lot of you will start out with HTs, but some of you might want to do some HF work or set up home base stations. And this chapter covers some of those considerations. The first thing you're going to have to do is set up a power supply, set up your transceiver and power supply. And this shows it's kind of a typical installation. This is an ICOM IC7300 transceiver, and this is a common Astron power supply. Basically, to power the radio, you connect 2 wires, right? And you think, oh, that's all we need to do, connect 2 wires. But no, there's some considerations involved here. When you're transmitting, if you're transmitting at 100 watts, you could be drawing up to 20 amps of current, right? And so if you remember E equals IR, if you're drawing 20 amps out of the power supply, it only takes 1/10 of an ohm to drop 2 volts from here to here. So if you had set this power supply to 12 volts, say, so you got 12 volts coming out of the power supply, you're only going to get 10 volts here. Now, that may or may not be enough to make that radio operate properly. So even just connecting 2 wires between your power supply and your radio is something you got to keep in mind. So question, why are short, heavy gauge wires used for a transceiver's DC power connections? Answer, to minimize voltage drop when transmitting. So you want to, make this voltage drop as little as possible. Otherwise, you're going to get flaky results. Question, which of the following is an appropriate power supply rating for a typical 50-watt output mobile FM transceiver? And there's 4 choices here. 2 of them say 24 volts. Right off the bat, that's wrong. Most amateur radio equipment does not operate at 24 volts. So that leaves 13.8 volts at 4 amps, 13.8 volts at 12 amps. Well, we're talking about 50-watt transmitter here, right? So this sounds pretty good. 13.8 volts times 4 amps, that's 55.2 watts, right? That should be enough. That's the wrong answer. The reason it's the wrong answer is if the output power is 50 watts, the current it's being drawn, the power it's being drawn out of the power supply is going to be at least twice that, or 100 watts, because the amplifiers are not 100% efficient. Plus, the radio needs power for other things as well. So the correct answer here is 13.8 volts at 12 amps. That gives you like 156 watts, and that should be enough. All right. So let's talk about using a computer in your station. If you ask me, using a computer is probably almost a necessity anymore. And if not a necessity, it certainly makes operating a lot more fun. So keep that in mind when you're setting up a station. Now, mostly what we do is to connect a computer, connect the computer to the radio, we connect the microphone input to the audio output, and the audio output to the microphone input. Because when you're operating digital modes, mostly you're sending audio tones back and forth. So question, what signals are used in a computer radio interface for digital mode operation? Answer, receive audio, transmit audio, and transmitter keying. So there needs to be a third line here to tell the transmitter when to turn on. Question, how are the transceiver audio input and output connected in a station configured to operate using FT8? Answer, to the audio input and output of a computer running WSJTX software. SJTX software. Question, which of the following connections is made between a computer and a transceiver used to use computer software in operating digital modes? Answer, computer line in to transceiver speaker connector. So again, that's just the audio, one of the audio wires here. Now, having said that, with all these questions, especially with this IC 7300, we don't even do that anymore. There isn't a question about this, but I'm going to show you anyway. So we just use a USB cable now. In the USB, what this 7300 does is digitizes the audio, sends it over digitally, and conversely, this sends the audio digitally, and the receiver converts it back to audio. So this works much slicker than having all those wires running around. Question, which of the following could you use to cure distorted audio caused by RF current on the shield of a microphone cable? So let's go to the next slide here. What you'd use is a ferrite choke. This is an example of a ferrite choke. And you see, this is a USB cable, but this could also be an audio cable. If you run the audio cable through the choke, it will prevent any RF from getting into that wire. It's very, very cool. The story I tell, I think every ham operator should have a handful of ferrite chokes in his shack at any one time, because you never know when RFI problems can occur. I'll give you an example. So when I got back on the air, I don't know, it's almost, well, over 20 years ago now, I put up an antenna in my backyard, a 40-meter dipole. I tune it up using my antenna analyzer, and I go downstairs and I start calling CQ. Well, the first thing you know, my wife runs downstairs. She says, "What the heck are you doing?" I said, "Well, I put up an antenna. I'm calling CQ." She says, "You're opening and closing the garage door." And what was happening is enough RF was getting into the wire connecting the garage door opener to the switch on the wall that it made it look like someone was poking the switch. What was the solution? The solution was a ferrite choke up near the input to the garage door opener, and my problem went away. So putting a ferrite choke on a line is like adding an inductor to it, which will cause a very high impedance at RF frequencies, basically blocking or choking the RF off and not letting it get into to the cable. So ferrite chokes, get a handful of those. You can get them on Amazon too, and they're cheap on Amazon. Question, which of the following conductors, and so grounding is also important, right? Grounding is another way to make sure that these things don't happen in your station. Question, which of the following conductors is preferred for bonding at RF? Answer, flat copper strap. So that's what this is, flat copper strap. Why do we use this kind of thing? Well, at RF, you have a thing called skin effect. So if you have a conductor, let's say this is the cross section of a conductor, at RF frequencies, all the current's going to happen around the outside of the conductor. So all this is like not even there. And so what happens is it presents a higher resistance at RF frequencies because you're not using the whole cross section of the conductor. So if you have many, many conductors and they're all braided together like this, basically you have a lot of sort of resistors in parallel, and the impedance or the resistance that RF experiences over this distance is rather low, a lot lower than if you had a single conductor. So flat copper strap, that's what you want for bonding to ground at RF frequencies. All right, mobile installations. So a lot of you are going to be putting your radios in your cars, and you want to be careful there about how you wire the radio to the power system. Question: where should the negative power return of a mobile transceiver be connected in a vehicle? Answer: at the 12-volt battery chassis ground. So you want to get that connection as close to ground as possible. Why is that? Well, a lot of current is going to flow through that ground. And if it meanders around the car, that might create a high, relatively high anyway, resistance connection, especially if it goes through several different connectors, and that'll cause a voltage drop. So even though your battery is still in good condition, by the time that that the voltage on the ground might not be as close to zero as you like, and the voltage at the radio may be lower than you need for that radio to operate properly. So by connecting it as close to the 12-volt battery chassis ground as possible, that'll help your radio work properly. Again, battery questions. How can you determine the length of time that equipment can be powered from a battery? Answer: divide the battery ampere hour rating by the average current draw of the equipment. So if you're this happens when you're operating portable, right? If you go to do summits on the air, for example, which is operating, we'll talk a little bit about this later, which is taking your handheld or some other VHF, UHF radio, or even HF radio to some summit and see how far you can talk line of sight. If you're way up high, you can talk pretty far line of sight sometimes. You're going to be operating off a battery. How can you tell how long you can operate? Well, let's take an example. If you have a 2 amp hour battery, that means you can draw 2 amps for 1 hour, basically. Well, if your radio is only drawing on average, say, a half an amp, well, you can operate for 4 hours and you'll still have 2 amp hours, that'll reach your 2 amp hours of energy. So divide the battery amp hour rating by the average current draw of the equipment. That'll tell you how long you can operate. Or in this case, 2 amp hours divided by 0.5 amps equals 4 hours. All right. Don't see any questions, so I'm going to plow on here. One of the most important, we're going to talk about operating controls next year. One of the important things about operating controls, one of the most important operating controls, is the microphone gain. And this is true for both single sideband and FM transmissions. So question, what is the effect of excessive microphone gain on SSB transmissions? Answer, distorted transmitted audio. So using too high a gain setting will feed too much audio into your transmitter and cause distorted audio. Question, and the next thing is to make sure you're on frequency. Question, what is the result of tuning an FM receiver above or below a signal's frequency? Answer, distortion of the signal's audio. So it's like, okay, make sure you're on the right frequency. Question, which of the following can be used to enter a transceiver's operating frequency? Answer, the keypad or VFO knob. And we're going to take a look at our friend the Baofeng here and just show you that, one of the ways to set this operating frequency is by the keypad. And some radios, the Baofeng unfortunately doesn't have it. I should have maybe chose a different radio here. There's sometimes a knob up on the top, a second knob, where you can adjust the frequency with that knob. Question, what is a way to enable quick access to a favorite frequency or channel on your transceiver? Answer, store it in a memory channel. So you can't see it too well here, but this is the VFO/MR button. And when you're in memory mode, MR, then you can select channels that you've pre-programmed into the radio. Question, what does the scanning function of an FM transceiver do? Answer, tunes through a range of frequencies to check for activity. So you can program a set of, like for example, if there's 3 or 4 repeaters in your area that you can hit, you can program those frequencies into memory and then tell the radio to scan through those frequencies till it hears something, hears some activity on one of the channels. And that works pretty good. Question, what is the purpose of a squelch function? So the squelch function in a Baofeng is one of the memory or the menu selections. But you can set the level, the squelch level. What is the purpose of a squelch function? Answer, mute the receiver audio when a signal is not present. So if nobody's on the repeater, for example, and all you'd be hearing is noise. Well, if you don't want to hear that noise, you set the squelch level above a certain setting, and you don't hear anything until someone actually gets on the repeater. That's the squelch function. Question, how is squelch adjusted so that a weak FM signal can be heard? Answer, set the squelch threshold so that the receiver output audio is on all the time. So that's one of the bad things about squelch, is that if there's some weak signals on the frequency, you may not hear them because your level is set too high. Well, if you set the level lower, then you might be able to hear that weaker signal. That's all that really meant here. Question, what is meant by repeater offset? Answer, the difference between a repeater's transmit and receive frequencies. So, as you may or may not know, a repeater receives on one frequency and transmits on another. Okay, so here in Ann Arbor, we have what we call the 146.96 machine. So the repeater transmits on this frequency and receives on 146.36. The difference here is 600 kilohertz. And that's the repeater offset for that repeater. And you have to set that up properly, right? You have to set up your radio to do that properly. You'll be listening, in this case, you'll be listening on 146.96, and when you hit the push to talk button, you want it to transmit on 146.36, which is the frequency that the repeater is receiving on. Question. So here, the next couple of questions have to do with digital modes again, but how to properly set up digital modes. Question, what function is performed with a transceiver in a digital mode hotspot? And I should have had a figure for this, but I'll draw something. So you use a hotspot with some of these new digital modes, right? And so you have an HT, let's say, and you have this is the hotspot. And that hotspot might be connected to your computer. So the hotspot will transmit and receive on a ham frequency and then connect to the internet via your computer to, connect with other DMR stations or D-Star or, whatever digital mode you desire. So question, what function is performed with a transceiver in a digital mode hotspot? Answer, communication using digital voice or data systems via the internet. So it's just a way to get your radio signal into the internet. DMR radios, the DMR system, has what are called talk groups. And when you connect to a talk group, you're connecting to a bunch of other amateur radio stations connected to that talk group. And there's servers somewhere that keep track of all this information, who's connected to where. And when you talk in on your repeater or on a hotspot, and that digitized signal is sent to those servers, those servers know where to then send your digital signals. So a talk group is like I say, sort of a group of users that have all connected to one another. So question, what is a talk group on a digital repeater? Answer, a way for groups of users to share a channel at different times without hearing other users on the channel. So remember, we talked about DMR being time multiplexed. So if, even if other stations are on that frequency, if they're not connected to that talk group, they won't hear you. Question, what does a DMR code plug contain? So all DMR radios need a code plug. And really, the code plug is a kind of a misnomer. It's a carryover from when DMR radios actually used physical plugs that plugged into a radio. But now it's just a file with all kinds of programming information on it. So question, what does a DMR code plug contain? Answer, access information for repeaters and talk groups. So you download this code plug into your radio, and then when you dial in a certain channel or punch in a certain channel, it has all that configuration information inside the radio, and it knows what to do with it. Question, how is a specific group of stations selected on a digital voice transceiver? Answer, by entering the group's identification code. So each talk group, in this case, has its own code, whatever that might be. And if you've programmed your radio to use that code when you want to connect to that talk group, then everything just works, and you're connected to all the right people. It's really pretty spiffy. Question, what is the purpose of the color code used on DMR repeaters? Answer, establishes groups of users. I don't like this question. Just memorize the answer to this one. Question, which of the following must be programmed into a D-Star digital transceiver before transmitting? And this is true for DMR and Fusion and all the digital voice systems. Answer, your call sign. So that's how, because even though the transmissions are all digital, it's because you've entered your call sign, the radio will send your call sign along with all the digital voice information. That's how someone on the other end knows it's you. One of the cool things about DMR is when you receive a signal from somebody, if they're listed in your, if they're, every user has a specific DMR number, and if those names are programmed into your radio, it'll tell you who that transmission was from, even without them identifying their station, because really they have identified just digitally. So now we're going to talk a little bit more about HF transceivers. One of the things that HF transceivers have are very fancy filtering. And the filtering is really nice because it prevents other stations that are operating nearby you from interfering with your operations. So, question: what is the advantage of having multiple received bandwidth choices on a multi-mode transceiver? Answer: permits noise or interference reduction by selecting a bandwidth matching the mode. Okay. And the next question, we'll just talk about this question, then I'll show you how these relate. Question: which of the following receiver filter bandwidths provide the best signal to noise ratio for SSB reception? And the answer here is 2,400 hertz. So we talked before about, I need to get another screen here. We talked before about single sideband signals being like 3 kilohertz wide. So if you select a filter that's 2,400 hertz wide, then you can still receive this 3 kilohertz signal quite nicely. So this is a filter, and let's say it's 2,400 hertz wide. So each FH minus F0 will be 1,200. So let's say there was a signal out here that just is, transmitting. Because it's outside the bandwidth of your filter, you're not going to hear that, right? On the other hand, if your filter was 4 kilohertz wide, all of a sudden you'd hear that station because it's going to be within your bandpass. So having the ability to set a 2,400 hertz bandwidth allows you to operate interference free. And it's especially true like for CW operation. CW operation is very narrow, and sometimes stations could be right on top of you. But if you have really narrow filter, then you're not, you just won't hear that station. So that's some of the advantages of having these new modern transceivers with all this fancy filtering. So a couple other controls that they have questions about here. Which of the following controls could be used if the voice pitch of a single sideband signal returning your CQ call seems too high or too low? Answer: the RIT or clarifier. So RIT stands for receiver incremental tuning. And what this does is it allows you to set your receiver frequency a little different from your transmit frequency. And so if signal seems, the voice pitch seems too high or too low, it means they're not transmitting on the same frequency you are. So you can set your receiver to be appropriate so that you can understand them properly. And that's where the clarifier comes in. It's clarifying the voice signal. And one of the manufacturers uses clarifier instead of RIT. And that's why it's in this question. Question: what is the function of a transceiver's push-to-talk input or PTT input? Answer: switches transceiver from receive to transmit when grounded. And what's that? That's just that's the push to talk button right here on the radio. No big deal. All right. Let me see how much is here. And I think we can blow through the next chapter before taking the next break, unless there's some, there's a lot of stuff to cover, so we got to just sort of keep plowing through it. All right, so let's talk about station equipment now. First question is, what is a transceiver? Well, these are two examples of transceivers, right? We've already seen these. The one on the left is the Baofeng HT handheld transceiver, and the one on the right is the IC7300 HF transceiver. What are transceivers? Answer: a device that combines a receiver and a transmitter. And this is kind of a holdover from the old days. I've been a ham a long time, and when I got started, you had separate boxes. You had a receiver and you had a transmitter. It's kind of like if any of you guys are hi-fi guys, and back in the 1950s, 1960s, and even in the 70s, you had a separate receiver, you had a separate amplifier, you had a separate turntable. Well, ham radio was the same way. But now we've combined everything into a transceiver. Question: what device converts the RF input and output of a transceiver to another band? Answer: a transverter. So this is an example of a transverter. And what you do with the transverter is you connect it from the radio to the transverter, and then the transverter to the antenna. Oops, that's not so good. And what it'll do is, say you set your HF transceiver to 10 meters, and you transmit on 10 meters. The transverter takes the 10-meter signal, converts it up to the 2-meter band in this case, and then conversely receives 2-meter signals and converts it into a 10-meter signal that the transceiver can receive. So that's how some people operate, like single sideband and CW on VHF bands, is with a transverter. Question: what device increases the transmitted output power from a transceiver? Answer: an RF amplifier. So this is an example of an amplifier. What is the function? And this is a this particular one is I think a VHF amplifier. So it would connect to the radio and vice versa, to the VHF radio. Question: what is the function of the SSB CW FM switch on a VHF power amplifier? Answer: set the amplifier for proper operation in the selected mode. So you may need to set this switch depending on what mode you're operating. If you're operating FM, set it for FM, CW FM. If you're going to operate sideband, say through this transverter, then you put it in the single sideband mode. So even though we talk about transceivers now, we still talk about their specifications as if the receivers and transmitters were separate. And these next two questions talk about two receiver parameters: sensitivity and selectivity. Question: which term describes the ability of a receiver to detect the presence of a signal? Answer: sensitivity. Well, this term is really kind of a vestige. It is another sort of obsolete question. We really don't talk about sensitivity anymore. What we talk about is the minimum discernible signal, MDS. And the MDS of these new radios are so good, this is almost not a consideration anymore. I mean, honestly, the radios today are just so good So in a way, this is a little bit of a misnomer, because if you looked on the 7300 spec sheet, you'd probably see MDS instead of sensitivity. Question, which term describes the ability of a receiver to discriminate between multiple signals? Answer, selectivity. And again, this is sort of an obsolete term, because nowadays with the radios being able to set their filter bandwidths, as I just described previously, what is the selectivity? You know, I suppose you could say, well, it's the lowest bandwidth that you can select, but even again, that's sort of an obsolete term, because you're not going to always select that minimum. In fact, you're probably never going to select the minimum. And again, here's another sort of useless question. Where is an RF preamplifier installed? Answer, between the antenna and a receiver. So say we used RF preamplifiers in the old days when you had very poor, very insensitive receivers. Well, nowadays these are all so good, you don't need these things anymore. But if you did have one, you'd put it here between the antenna and the receiver. But I tell you the truth, I don't even know where you can buy these things anymore. I don't think anybody sells them, because like I say, the receivers today are so good. All right. And again, here's some more sort of obsolete questions. Sorry about that, but they're on the test. So this is a block diagram of what's called a super Heterodyne radio. Super Heterodyne radio. Nowadays we're using all software-defined radios, so we're not even really using this type of radio anymore. But the way this would work is a signal would come in, there'd be a filter here, an amplifier, and then it would go to a mixer. And the mixer, this oscillator would be set. The mixer combines two signals and produces the sum and the difference between them. And one of those differences would be called what's called the intermediate frequency, and that was normally about 455 kilohertz. And then the rest of the circuitry here would operate at 455 kilohertz, not at the frequency of the incoming signal. Okay. But like I say, nowadays we use software-defined radios. Even that IC 7300, which is relatively inexpensive, uses software-defined radio techniques. But there's some questions here about this kind of thing. For example, which of the following is used to convert a signal from one frequency to another? Answer, the mixer. Question, what is the name of a circuit that generates a signal at a specific frequency? The oscillator. And we talked about this before. Which of the following describes combining speech with an RF carrier signal? Answer, modulation. I really should move this question to the other chapter. So if any of you are really interested in like how a super Heterodyne works, you can get with me later and we can go through this in more detail. But I tell you what, unless you're planning to play around with vintage radio equipment, you really won't need to use that information. All right, so let's talk now about things that can go wrong. So Murphy's Law applies to amateur radio as well as to almost everything else in life, right? And if things can go wrong, they will. And one of the things that can go wrong is radio frequency interference. either you causing interference to somebody or somebody causing interference to you. And these are some of the things that can cause you interference, and some things you can cause interference to. It could be strong radio stations nearby, your neighbor's shortwave radio that all of a sudden you're starting to get into, baby monitors that you might be causing you some interference. All these things can cause interference. And so it helps to know what to do when when something's wrong. So question, which of the following can cause radio frequency interference? Answer, all of these choices are correct. Fundamental overload, harmonics, and spurious emissions. So let me talk a little bit about each one of those. Fundamental overload is when something is so strong that it doesn't matter what frequency you've set your radio to, you're going to hear that station. That would be the case if you were close to a broadcast station's antenna. Harmonics are where you're hearing or generating multiples of a transmit frequency. So, for example, if you were hearing like a strong AM station in the on its second harmonic, which is like twice the fundamental frequency in the 160 meter band, that would be an example of harmonic interference. And spurious emissions happen just randomly. There's no relation to the actual transmit frequency at all. Question, which of the following actions should you take if a neighbor tells you that your station's transmissions are interfering with their radio or TV reception? Answer, make sure that your station is functioning properly and that it does not cause interference to your own radio or television when it is tuned to the same channel. So fortunately, this isn't as much of a problem as it used to be, right? People are on cable and or even satellites, and the instance of amateur radio transmissions causing TV interference is a lot less than it used to be. But even so, you might want to do what is suggested by the answer here, and I do this myself from time to time. I'll turn on a radio while I'm on the air and see if my AM or FM radio can pick up my transmissions. And if I can't, which is good, then if my neighbor complains, then I can just show him. I said, hey, look, I'm not getting any interference. The problem is with your radio. And you can sort of wash your hands of it at that point. As long as depends on your relationship with your neighbor, but it's not your fault. And consumer electronics are supposed to be able to have a certain amount of be able to reject signals that they're not designed to receive. So you're certainly well within your rights to say that kind of thing. Question, what should be the first step to resolve non-fiber optic cable TV interference caused by your amateur radio's transmission? Answer, be sure all TV feedline coaxial connectors are installed properly. And this is actually a thing. If you are causing some kind of interference to your neighbor's cable TV, that the first thing you really should do is to go over there and just crank down the connectors on their cable TV box. I had cable internet installed here, I don't know, a couple of years ago now. And that's one of the questions I asked the guy. I said, yeah, I'm a ham radio operator. And right away he said, oh, you're one of those guys, huh? And I said, yeah. I said, well, there's a question on the ham radio test. And I told him this question. He says, oh yeah. He says, that's the case more times than not. If there's a problem with interference, is that either the cables themselves are bad, the connectors are coming loose or something, or the cables are not cranked down properly and not making good connection with the box. So that's the first thing you want to do, is be sure all TV feedline coaxial connectors are installed properly. Question, what would a broadcast AM or FM radio, what would cause a broadcast AM or FM radio to receive an amateur radio transmission unintentionally? Answer, the receiver is unable to reject strong signals outside the AM or FM band. So that's a case of fundamental overload. And like I said, the problem is with the receiver, not necessarily with your transmissions. So, all these consumer devices are supposed to be able to do that. But of course, manufacturers take shortcuts, and that can cause problems. Question, how can fundamental overload of a non-amateur radio or TV receiver by an amateur signal be reduced or eliminated? Answer, block the amateur signal with a filter at the antenna input of the affected receiver. So it's possible to install a filter between the antenna and the receiver that will filter out some of the offending signal. I'm a little dubious about that, but I suppose it can happen. Question, which of the following can reduce overload of a VHF transceiver by a nearby commercial FM station? So this is sort of the reverse process. What if your VHF transceiver is being overloaded by a nearby FM station? Answer, installing a band reject filter. So this actually can work. And in fact, you can buy these band reject filters for I think they sell them for SDRs that want to receive signals, in the VHF portion of the band. The problem, of course, is they have to be designed for transmitting as well as receiving. So they have to be able to handle however much transmit power you have. So that's, you got to be careful about that. You might buy one of those filters and then end up frying it because you're trying to push too much power through it. Question, what should you do if something in a neighbor's home is causing harmful interference to your amateur station? Yeah, and what can happen? Well, baby monitors, cordless phones, microwave, all that stuff. They can interfere with you. Answer, all these choices are correct. Work with your neighbor to identify the offending device. Politely inform your neighbor that FCC rules prohibit the use of devices that cause interference. Make sure your station meets the standards of good amateur practice. So all these choices are correct. So that's all the TVI and RFI things, but there's still some things that might go wrong even just in normal amateur operations. Question, what might be a problem if you receive a report that your audio signal through an FM repeater is distorted or unintelligible? Answer, all these choices are correct. Your transmitter is slightly off frequency. Your batteries are running low. You're in a bad location. What is a symptom of RF feedback in a transmitter or transceiver? Answer, reports of garbled, distorted, or unintelligible voice transmissions. And, what's a solution to this? Well, you make sure you're using a shielded cable to connect the microphone to a transmitter, or get an RF choke and put that in the microphone line. That should prevent any kind of RF feedback. Question, what can you do if you are told your FM handheld or mobile transceiver is over deviating? Answer, talk farther away from the microphone. So what is over deviating? That means the FM signal that's changing its frequency too much. It's over deviating from the central frequency. And that deviation is caused by the amplitude of the audio signal. So if you've got the microphone gain set too high, then that FM signal is going to over deviate. All right. Let's talk about test equipment. There's only a couple more pages here. Then we'll take a break. So stick with me. Another thing I think every ham radio station should have is certainly at the bare minimum is a multimeter. And multimeters are called that because they can measure multiple electrical parameters. You can usually measure DC voltage, AC voltage, resistance, current, and some will do capacitance. I think this one can do capacitance. I'm not sure. anyway, they can measure a multitude of things, and that certainly will help you in if you have a problem or when you're setting up a station. So, question: which of the following measurements are made using a multimeter? Answer: voltage and resistance. Of course, like I say, they'll measure current too, and sometimes capacitance, sometimes other things, but voltage and resistance are the two main ones. Question: which instrument would you use to measure electric potential? Answer: a voltmeter, or the voltmeter function of your digital multimeter. How is a voltmeter connected to a component to measure applied voltage? Answer: in parallel, right? So let's show you how that works. So say you had a resistor here, right? And there's some current flowing through it. How do you measure the voltage across that resistor? Well, you measure it in parallel. So you connect the common to one side and the plus to the other side. And then you'll measure the voltage. Oop. All right. Which of the following can damage a multimeter? Answer: attempting to measure voltage when using the resistance setting. Question: which of the following precautions should be taken when measuring high voltages with a voltmeter? Answer: ensure that the voltmeter and leads are rated for use at the voltages to be measured. And when I teach this class in person, I pull out a little crummy little voltmeter you can get from Harbor Freight. I don't know if any of you've ever seen those. Sometimes they even give them out free, or at least they used to. And if you look on that meter, you'll see it's rated for 1,000 volts. My advice to you is never try to use that meter to measure 1,000 volts. I think if you put 1,000 volts to it, it'll just burn up right in your hand. So anyway, I would measure 1,000 volts with this Fluke multimeter. These are good quality meters, but not with Harbor Freight. Question: how is an ohm meter connected to a component to measure its value or resistance? Answer: in parallel. Well, it's the same kind of thing, right? You want to measure across the resistor, and then you'll measure the resistance. Question: which of the following precautions should be taken when measuring in-circuit resistance with an ohm meter? Answer: ensure that the circuit is not powered. And why is that? Because what happens, how a multimeter measures resistance, it actually sends a test current through the resistor and then measures the voltage and then does the calculation, R equals E over I. And if there's other sources of current, like from like if there's another source of current from the rest of the circuit here, that's going to throw off the measurement, because the current flowing through the resistor will be the test current plus whatever this current is, and that'll throw off the measurement. So answer is: ensure that the circuit is not powered. Question: what reading indicates that an ohm meter is connected across a large discharged capacitor? Answer: increasing resistance with time. Why is that? Because that capacitor will have some kind of charge on it, and that charge will be discharged through the ohm meter. And as the capacitor is discharged, the voltage across it will go down, and that'll cause the voltage to the resistance reading to keep changing as the capacitor discharges. All right. Question: which instrument is used to measure electric current? Answer: an ammeter, or the ammeter function of your digital multimeter. Question: when configured to measure current, how is a multimeter connected to a component? Answer: in series. So if you remember, we had this circuit before. Right? And current goes this way. Current flows through the resistor and blah, blah, blah. So to measure that current, what you need to do is actually break that circuit and connect the meter in series with the circuit so that the current flows through the meter and then back into the circuit. When I was a kid, I had really had trouble like understanding that for some reason. And well, now I understand it, fortunately. All right. That's how you use a multimeter. So soldering is a thing we do in ham radio, right? I mean, you really want to learn how to solder and make good solder connections. And I mean, having a good soldering iron and having proper techniques will help you be a better ham radio operator, believe me. And you'll have more fun doing it too. That's sort of really the key. So question, which of the following types of solder should not be used for radio and electronics applications? Answer, acid core solder. Don't use acid core. Use some kind of lead tin solder with a rosin core solder. Question, what is the characteristic appearance of a cold tin lead solder joint? Answer, a rough or lumpy surface. So here's some examples of cold solder joints. And this is actually from a project I worked on. The guy who I was working with, he actually made these connections. I didn't do this. I'm going to claim innocence on this. But you see here, these are cold solder joints. And you see that the solder here just doesn't cover the whole pad. And it doesn't even look like it's connected to the lead here. So these are bad solder. This one here is not too bad. As this one. This one's not too bad. These are nice and even, and you can see the solder is flowed onto the lead. So, but these are bad. And why do we call them cold solder joints? Because chances are the person who was doing the soldering didn't hold that soldering iron on we call it the joint, the solder joint, long enough to heat up both the pad and the lead. So it was cold. So when they put the solder on it, it didn't flow nicely around the whole joint, and it just sort of bubbled up and got lumpy. So those are cold solder joints. All right, let's take a break and come back in about 10 minutes.
Sounds good.
We're almost there.
Almost there. Okay. All right. Well, good. Okay. All right. Switch over here like that. Good. Okay. Yeah. So break time, 10 minutes is about 2:20. Yeah, about 2:23, 2:25, somewhere in there, Central Time.
Yeah.
Good. Dan, will we have another break between now and the end?
We can do that. We can go through like the next chapter and then which is all the like operating stuff, and then take another short break and you can do your thing. And
okay. All right. That's when we'll do it.
Then what I always say is then we get into the really boring stuff.
Okay.
Which is the rules and regulations.
Yeah, the rules and stuff. Yeah. Yeah, that's true. Cool. All right. Well, once again, we're appreciate Dan being here and giving us this information today with the new question pool that's come up. He talked a little bit about DMR, and as I said during the lunch hour, the Baofeng Tech BTech is one of our sponsors for this live stream. They have a DMR 6x2 Pro, which the DMR 6x2 radio they've had for a while now has been out, and it's designed by a company called Anytone, but BTech out of one of the Dakotas, like I said, they do a lot of their own firmware for this radio and several others. They came out with this Pro model just like a month ago, and I've actually got one sitting right here. That's it right there. I've been really happy with it. They got a lot of really cool firmware stuff, firmware updates to it that they're doing, and more of it planned, more updates planned for the future. So I'm going to check out, if you're into DMR, now you're going to pay a little bit more for a DMR radio than you will for a regular analog radio. And somebody asked that question earlier about whether they should get analog only or go with a digital radio as their first radio. That's really kind of up to you, depending on what you want to do with it. Again, I know a lot of people that got into ham radio because they wanted to use digital modes like D-Star and DMR to talk across to another state, across the country, to an overseas, something like that. So this DMR 6x2, his 6x2 Pro from BTech has been really good. They asked me to tell you about that one today. So I want to leave that with you because they are one of our sponsors. So go check that out. Put a link in both the chats, and you guys can go read up on that.
So Bob asks, are most repeaters simplex or duplex? So most repeaters are duplex. They transmit and receive on different frequencies. And that's the difference. Duplex, they're using two frequencies. Simplex uses the same frequency. And we'll talk a little bit more about simplex operation in this next chapter. So
right.
And talking about the 6X2, I have a BTech 6X2. So I'm going to have to look up and see what kind of firmware improvements they've made.
They added it has true APRS now for analog.
Oh, cool.
So it'll beacon and receive on 144.39 for standard analog. It's got more channels and more contacts capacity and a few other things like that. So they told me, they gave me a list of things that they're wanting to add in the future, and they said, we want to add this, but don't advertise this yet because we don't know if we can make all this work. I'm like, okay, that's fine. So, but they're actively working on it, which is good.
Yeah, I think it's a good. I actually, disclaimer, I actually did some work for them. I wrote some of their app notes.
Oh, good. Okay. All right. So, Gary, this is a good question right here. I see the BTech 6x2 Pro does AES 256 encryption per the session. I hear you cannot do encryption. How does it work with that? Well, long story short, okay, we could get into this a little bit more later, but DMR is a commercial standard that amateurs took and adapted to our needs. So DMR is usually used by police, fire departments, commercial companies and whatnot. So it's not a traditional amateur radio standard. But guess what? Neither were FM repeaters when they first released. Back in the 60s, police and fire departments were using FM repeaters, and they started to sell some of these older FM repeaters, and amateurs started picking them up for our use on our frequencies. So yes, while DMR is a commercial standard that does allow encryption, we're not allowed to use encryption on the amateur radio frequencies. But if you have a commercial license of some sort, then you can use it over there. So it really depends on, it follows the frequency, not the mode. David, yeah, I've done a comparison between and Anytone. Anytone basically designed the radio for BTech, and then BTech is writing their own firmware for it. So they're very similar at this point in time, but BTech has some updates that they're planning for the radio in the future. The BTech one is a few dollars cheaper, if that makes a difference to you. So, but the Anytone's a fantastic radio too. I carry my Anytone a lot as well. And once again, at the next break, we're going to be giving away one of these UV9 Papa X-ray radios from BetterSafeRadio.com. You can go check out their website, BetterSafeRadio.com, and look at I'll put a link to this radio in there. But if you find anything you like over there, they have a coupon code you can use to get 7% off of anything on their website. HR2all7 is the coupon code. And then lastly, we got a few minutes before we come back. We are going to be offering testing at 7 o'clock Eastern time tonight, so 6 p.m. Central time. And the link for that is over here. It's actually right here. And Steve, KO4AFL, if you guys have watched my channel for any amount of time, he's been on my channel several times, several of my happy hours and whatnot. Sometimes he's co-host on my Wednesday live streams. So he's a volunteer exam coordinator, and he's got a team that works with him over there, and they're offering testing tonight. If you guys are ready and willing to go take a stab at getting your first license.
And you really might consider it just because, so much of this is like memorization and stuff. The longer you wait, the more you'll forget.
Right. Dennis says, if using a commercial license, then you are sharing the commercial licensee's call sign without having to have the ham radio correct. Yeah, well, you wouldn't use your amateur call sign on commercial frequencies or vice versa, if that's what you mean.
Right.
Rod says he'll attend the test tonight. Good. What's the cost for the exam? Looks like it's $10 per this link I just shared. So I just put the link in both the YouTube chat and the webinar chat. Go check that out, Tiki. And I signed up for the test after the class and have received a session pin, but I do not see how to pay for the exam in advance or how actually to take the test. It states I'll receive an email. How long does that usually take? You know what? I don't know, but I'll find out. Because I got Steve over here on Discord. He stepped out for a bit, but I was talking to him earlier this morning. So I will find that out information and let you know.
One thing you folks might think about doing, because I think we're going to get done a little bit before the test session starts. I'm going to guess at least an hour before the test session starts. You can take some practice tests. You can go to qrz.com or aa9pw.com. There's tons of places that take practice tests. You can take some practice tests while you're waiting.
Right. Yep. Yeah, I always use aa9pw.com. I always like that one.
Yeah, he has a nice site.
Mm-hmm.
They're all good. They're all pretty good.
Yeah.
Even the ARRL has one.
Yeah. That is true. I show about 1, maybe 2 minutes left until we start again. So anybody have any more questions, let me know.
Yeah, they're playing football here today, so they're playing in the snow.
Yeah.
Starting to come down for pretty good now.
Oh, wow. That's fun. I like to see snow every now and then, but like I said, we only see it about once every other year, and it usually doesn't stick very long.
Well, that's good timing.
Yeah. Yeah.
All right. Well, I'll get started anyway.
Okay.
There's no more questions.
Nope. Not that I see. Go ahead, Dan.
All right. So now we'll talk about operating procedures. And the first thing we'll talk about is repeater operation, because again, that's probably what the first thing you guys will all do is repeater operation. Question: what type of amateur station simultaneously retransmits the signal of another amateur station on a different channel or channels? Answer: repeater station. And as I mentioned before, like here in Ann Arbor, our repeater receives on 146.36 and transmits on 146.96. So that's just an example. Question: what types of amateur stations can automatically retransmit the signals of other amateur stations? Answer: repeater, auxiliary, or space stations. And an example of the space station is the station on the International Space Station, right? It has a digipeater on the space station. Question: which of the following describes a linked repeater network? Answer: a network of repeaters in which signals received by one repeater are transmitted by all the repeaters in the network. So there's a lot of examples of this. There's the PAPA system in Southern California, and we have a linked repeaters network here in Michigan on the west side of the state. And they're good because, like the one here in Michigan, you can transmit it into a repeater here on like just above the border near Chicago, and you'll be heard all the way up north in Traverse City. Question: what is so we talked a little bit about repeater offset frequencies before, and that's something you have to program your radio to do properly to have the right offset. Question: what is a common repeater frequency offset in the 2-meter band? Answer: plus or minus 600 kilohertz. Question: what is a common repeater frequency offset in the 70 centimeter band? That's the 440 megahertz band. Answer: plus or minus 5 megahertz. So make sure you set your radio properly. Whoop. So one of the problems people have when they're setting up their radios is they don't get the CTCSS tone, sometimes called PL. That's the Motorola trade name for it. They don't get the CTCSS tone set properly. And if you don't have the proper tone set, then the repeater is not going to hear your signal. Question: what term describes the use of a sub-audible tone transmitted along with normal voice audio to open the squelch of a receiver? Answer: CTCSS. And that stands for continuously tone-coded squelch system. Question: which of the following could be the reason you are unable to access a repeater whose output you can hear? Answer: all of these choices are correct. You set the improper transceiver offset. You're using the wrong CTCSS tone. You are using the wrong DCS code. DCS stands for digital code squelch, and it's sort of similar to CTCSS, except that it's a digital signal. I've never seen any repeater use DCS. Have you, Jason? Well, I guess he stepped away. But I've never seen any repeater use a DCS. So, but you can find out all that information before you program your radio. Question: how is a VHF-UHF transceiver's reverse function used? Answer: to listen on a repeater's input frequency. And why would you do that? Well, sometimes an operator may not be able to access the repeater, but he or she may be close enough to you that you can hear them on the input. And so if you use this reverse function, you can listen to the input and then maybe actually copy that station. Question: what would cause your FM transmission audio to be distorted on voice peaks? Answer: you are talking too loudly. So again, that's over deviation, right? Operating procedures. What is an appropriate way to call another station on a repeater if you know the other station's call sign? Answer: say the station's call sign, then identify with your call sign. Question: which of the following indicates that a station is listening on a repeater and looking for a contact? Answer: the station's call sign followed by the word monitoring. So here's an example. I often talk to my friend Ralph, AA8RK, on the repeater here. Sometimes I'll get on and say, AA8RK, this is KB6NU. And if he's listening and wants to talk to me, he'll come back and say, KB6NU, this is AA8RK, and along we go. If I just want to talk to anybody, I'll just say KB6NU monitoring. And if anybody's listening and wants to talk to me, then they can call me back. Here in Ann Arbor, Michigan, we actually say listening. So sometimes you might hear listening instead of monitoring, or sometimes you just hear a call sign. Sometimes they may not say monitoring or listening. And in which case, if that's what you hear, then you can certainly call that station. Someone asked about simplex and duplex. Here's this question. What term describes an amateur station that is transmitting and receiving on the same frequency? Answer: simplex. Question: why are simplex channels designated in the VHF-UHF band plans? Answer: so that stations within range of each other can communicate without tying up a repeater. So, there's in the 2-meter band, these simplex frequencies are centered around 146.52. In fact, that's the next question. What is the national calling frequency for FM simplex operation in the 2-meter band? Answer 146.520 megahertz. But 30 kilohertz up and down from 146.52 are the simplex frequencies. So like 146, 146 dot, let's see, 490, 146.460, 146.55, 146.58. Those are all simplex frequencies. So if you listen in those ranges, you might hear people operating simplex. On the 70 centimeter band, this isn't on the test, but in the 70 centimeter band, 446.000 megahertz is the national calling frequency. And if you get on those calling frequencies and just, say your call or even call CQ, then you might hear somebody and have a nice conversation with them. Like I said, you guys can operate HF, and there's a couple of questions here about HF operation. Question, what is the meaning of the procedural signal CQ? Answer, calling any station. So when I call CQ on HF, I'll say CQ, CQ, CQ. This is KB6NU, and I'll give my call sign phonetically, Kilo Bravo 6 November uniform. And then if somebody hears that, they know I'm looking for a contact and can call me back. But before you do that, you want to make sure that the frequency is not in use. So question, what should you do before calling CQ? Answer, all these choices are correct. Listen first to be sure that no one else is using the frequency. Ask if the frequency is in use. Make sure you are authorized to use that frequency. So the first two are kind of self-explanatory, except that second one. Even if you listen, you can't be sure on HF that the frequency isn't in use. There might be two stations on that frequency, and they can hear each other, but one of them can't hear you. So if you ask if the frequency is in use, that third station, which wasn't transmitting at the time, might be able to hear you, and then they'll say, yes, sorry, the frequency is in use. And then you can go choose another frequency. Question, how should you respond to a station calling CQ? Transmit the other station's call sign, followed by your call sign. And I would say, give your call sign phonetically, especially on HF, signals can fade and there may be noise, and it may be hard to actually make out a call sign. Question, which of the following is required when making on-air test transmissions? Answer, identify the transmitting station. And what this question is all about is sort of a basic principle of amateur radio operation, is that you always have to identify your station. Whenever you make a transmission, you have to identify, even if it's just a test transmission. Like I said before, you guys can operate Morse code. So there's a few questions here about Morse code operation. One of them has to do with Q signals. A couple of them have to do with Q signals. Q signals are 3-letter combinations beginning with the letter Q that stand for phrases or sentences or questions. And they're great because you send fewer characters over Morse code using these. So question, which Q signal indicates that you are receiving interference from other stations? Answer, QRM. So instead of saying, hey, somebody's interfering with you, you just send QRM and the other operator will know that's what you mean. Question, which Q signal indicates you are changing frequency? Answer, QSY. So somebody might send QRM, QSY up 5. And what that means is someone's interfering with you. Let's change frequencies up 5 kilohertz. And these really work great on CW. Band plans. Question, what is a band plan beyond the privileges established by the FCC? Answer, a voluntary guideline for using different modes or activities within an amateur band. So what does that mean? So if you look in the rules, you'll see that you can operate, if you had a higher class of license anyway, you could operate a single sideband phone on 20 meters from like 14.2 megahertz to 14.35 megahertz. I think it's maybe a little bit bigger. I'd have to look to be sure. But anyway, the voluntary band plan, however, says that around 14.275 is where a slow scan TV operators are encouraged to operate. And so that's a kind of a nice thing. People that are operating slow scan TV, which, not a lot of people do, know that they'll congregate around that frequency and find each other instead of having to search the whole band. So it's a voluntary, and it's voluntary. So theoretically, I could operate single sideband phone right on top of there, but I don't because, everybody's trying to use the same frequencies, and cooperation is a thing still in ham radio. Conversely, or similarly, if two stations do find themselves operating on the same frequency, it's a polite thing for one of them to move to another frequency, right? Question, which of the following applies when two stations transmitting on the same frequency interfere with each other? Answer, the station should negotiate continued use of the frequency. So the whole idea, the principle there is, don't cause any interference, be polite, don't cause interference. Public service and emergency communications. So, one of the purposes of amateur radio is to provide public service and emergency communications. It's right in part 97.1. And I would encourage you all to read part 97.1 just to see what the government thinks amateur radio is all about. There are two sort of main organizations, if you will, that are providing public service. One is called ARES, Amateur Radio Emergency Service, and RACES, the Radio Amateur Civil Emergency Service. The Radio Amateur Civil Emergency Service is more quasi-governmental, whereas ARES is more volunteer run. That's the big difference between the two. But question, what is the Amateur Radio Emergency Service, ARES? Answer, a group of licensed amateurs who have voluntarily registered their qualifications and equipment for communications duty in the public service. Question, what is the Radio Amateur Civil Emergency Service, RACES? Answer, all these choices are correct. A radio service using amateur frequencies for emergency management or civil defense communications. A radio service using amateur stations for emergency management or civil defense communications. An emergency service using amateur operators certified by a civil defense organization as being enrolled in that organization. So as you can see, the RACES is a little bit more formal and a little bit more, like I say, quasi-governmental. Question, what is RACES? Answer, an FCC Part 97 amateur radio service for civil defense communications during national emergencies. And a lot of times for RACES to be quote unquote activated, for them to actually start taking part, a national emergency does need to be called. When you're doing public service or emergency communications, we often form what are called nets. And nets are when a group of amateurs get on a particular frequency to share information about what's happening, whether that be the bike tour I was talking to you about, or, another big use for nets is in an activity called Skywarn, where amateurs are dispatched around a geographic location to look for threatening weather, such as tornadoes and severe thunderstorms. The nets are controlled by a net control station, or NCS. Question, which of the following are typical duties of a net control station? Answer, call the net to order and direct communications between stations checking in. So if you had a dozen or more stations on a particular frequency and they all tried talking over one another, you'd have chaos, right? So that's where the net control station comes in. They're responsible for directing the communication, the information flow on a net. Question, which of the following is standard practice when you participate in a net? Answer, unless you are reporting an emergency, transmit only when directed by the net control station. So that's, let's take Skywarn, for example. So all these stations were dispatched around our county here in Michigan, and the net control station would go down one at a time. Call station number one, give a report, station number two, and they just progress around the list that way. Now, if someone actually saw a tornado or something really severe, then they would be able to break into the net. They'd say break or emergency or whatever, and then be able to report on the emerging situation. But in general, you want to have an orderly flow of information from the stations in a net. One of the things that you do in a net sometimes is what we call pass traffic. That means send formal messages from one station to another. So, question, what does the term traffic refer to in net operations? Answer, messages exchanged by net stations. Question, which of the following is a characteristic of good traffic handling? Answer, passing messages exactly as received. So some of you may have played the game telephone at some point in time. The person originating the game, whispers something to the person next to them, and then they pass that message down. Well, by the time it gets to the end, it's something totally different from what the originator said. That's not good amateur practice. You want to pass that message exactly as received, and there's some mechanisms for doing that. Here's one of them. Question, what technique is used to ensure that voice messages containing unusual words are received correctly? Answer, spell the words using a standard phonetic alphabet. And these messages also have a formal format, if you will. And it's very similar to the packet kind of thing. There's a, whoops, sorry about that. There's a format to it. It's got a header that says where the message is going, who originated, the body of the message, and then a word count, which is sort of like the check in a packet, just to make sure that the person receiving the message has got the correct number of words. So question, what information is contained in the preamble of a formal traffic message? Answer, information needed to track the message. Question, what is meant by check in a radiogram header? And we call these formal messages radiograms. What is meant by check in a radiogram header? Answer, the number of words or word equivalents in the text portion of the message. So if you do that properly, then you kind of help ensure that the message gets passed properly, even though we're relying on people to pass the messages. So I maybe should have left this for the rule section, but this is part of emergency communications. So there's always a question of what rules apply in an emergency, right? So here's a question. When do FCC rules not apply to the operation of an amateur station? Answer, FCC rules always apply. Question, are amateur station control operators ever permitted to operate outside the frequency privileges of their license class? Answer, yes, but only in situations involving the immediate safety of human life or protection of property. So this is kind of a catch-22, right? You always have to follow the rules, but the rules say you don't have to follow the rules when there's a real emergency. I kind of like that reasoning. So yeah, that's the rules that apply to emergency operation. All right, let's talk about satellite operation. Oops, what's going on here? So here's a guy operating satellites. So at this time, there's a dozen or more satellites orbiting the Earth, and they're for amateur radio use. And what this guy's doing, he's got a Yagi antenna there, right? And he's pointing it up at the sky where he hopes the satellite will be, and he's bouncing his signal off that satellite. And these satellites are really just repeaters in space, except that they receive on one band and transmit on the other. So they'll typically receive in the 2-meter band and transmit on 440 or vice versa. So there's some questions about this on the test. Question, which amateurs may contact the International Space Station, ISS, on VHF bands? Answer, any amateur holding a technician class or higher license. So, all of you may have heard of the ARIS, Amateur Radio on the International Space Station contacts, where they talk to kids in schools mostly. But sometimes, these astronauts will just get on and talk to people. That's the one guy just came back. I forget what his name is off the top of my head. He actually got on quite a bit, and he made a lot of contacts with people. But so maybe not be quite as common in the coming months. But it's kind of a cool thing to do. Question, what is meant by the statement that a satellite is operating in UV mode? This is what I was talking about uplink and downlink. The satellite uplink is in the 70 centimeter band. That's the U in UV. And the downlink is in the 2-meter band. So if this guy was trying to operate a UV satellite, he'd be transmitting on 70 centimeters and receiving on 2 meters. And his radio is set up to do that, right? It's made to transmit on 440 and receive on 2 meters. Question, what mode of transmission is commonly used by amateur radio satellites? Answer, all these choices are correct. SSB, FM, CW data. So all these are common, but FM is really still the most common. And like you can see in the picture here, this guy's just using a handheld, regular HT. Question, what is the impact of using excessive effective radiated power on a satellite uplink? Answer, blocking access by other users. So this goes back to like sharing the frequencies and all, don't use too much power. Give everybody a chance to operate the satellites.
Hey, Dan.
Yep.
We got a question in the YouTube chat about the difference between the horizontal and the vertical elements on that handheld Yagi there.
Oh, well, so that's a good question. So,
yeah.
So I think what they're doing, what the idea there is to prevent sort of any interaction, and in actual operation, you have to, because this is line of sight, right? Even though it's a satellite, right. It's line of sight. So you point the antenna in the direction you think the satellite is. Obviously you can't usually see it, but then you have to rotate it to get the proper polarization. It's really kind of amusing. I've got that antenna right here in my office, that same antenna. And that's the reason to prevent the two antennas. And there are two antennas there, right? There's 3 elements on 440 and 7 elements on 2 meters. And this to prevent the interaction between them as much as possible. Okay. Question, which of the following is a way to determine whether your satellite uplink power is neither too low nor too high? Answer, your signal strength on the downlink should be about the same as the beacon. So all these satellites have beacons. They'll transmit on some odd frequency to give status like battery voltage and ambient temperature and stuff like that. So if your signal strength on the downlink is about the same as the beacon strength, then you've got it set right. So all these satellites are in low Earth orbit. And what does that mean? That means that they basically they come and go. The ones in stable Earth orbit, they're always in the same space, same place in the sky all the time. But these LEO satellites, they just go over for 10 or 15 minutes, and then you don't see them again for a couple of hours and stuff like that. So the question is, what is an LEO satellite? That stands for low Earth orbit. Answer: a satellite in low Earth orbit. That's why you sort of have to look them up. There's websites where you can go to tell you what satellites are in the air, what modes they operate, when they're coming over your location, that kind of thing. And you need those to figure out how to point that antenna and where to point it. Tell you, what bearing to point, and then what elevation to point. It sounds real complicated, and it is kind of, but once I've done this, and once you get the hang of it, it's not so bad. It's kind of amusing, like I said. Question: what is a satellite beacon? Answer: a transmission from a satellite that contains status information. So that's why I said battery voltage, ambient temperature. Question: what telemetry information is typically transmitted by satellite beacons? Answer: health and status of the satellite. Question: who may receive telemetry from a space station? Answer: anyone. That's sort of a trick question, right? Anybody, at least here in the US, there's no license for receiving anything. Like I say, so you have to track these things as they cross the sky. So there's programs to help you do this, but there's also websites. Question: which of the following are provided by satellite tracking programs? Answer: maps showing the real-time position of the satellite track over Earth, the time, azimuth, and elevation of the start, maximum altitude, and end of a pass, the apparent frequency shift of the satellite transmission, including the effects of Doppler shift. So the answer is all these choices are correct. And the Doppler shift is kind of amusing. You actually have to account for that. So as the satellite is coming toward you, the frequency will be a little bit higher. As it's going away from you, it'll be a little bit lower. Question: which of the following are inputs to a satellite tracking program? Answer: the Keplerian elements. And those are all readily available on the AMSAT website. Question: what is Doppler shift in reference to satellite communications? Answer: an observed change in signal frequency caused by relative motion between the satellite and the Earth station. That's what I said. It'll seem a little higher as it's coming toward you, a little lower as it's going away from you. Question: what causes spin fading of satellite signals? Answer: rotation of the satellite and its antennas. So, these things are rotating as they're up in the air, and sometimes the body of the satellite will rotate between you and the antenna, and sometimes it'll rotate so that you can see the antenna, and that causes some kind of fading. That's called spin fading. All right, let's talk about some other activities. One of them being contesting. So, we're in the quote unquote contest season now, whatever that means. It means there's a lot of contests going on in the amateur radio world. Almost every weekend, you'll find some kind of contest or another. So question: what operating activity involves contacting as many stations as possible during a specified period? Answer: contesting. Question: which of the following is good procedure when contacting another station in a contest? Answer: send only the minimum information needed for proper identification in the contest exchange. So let me give you an example. Here in almost every state has what's called a QSO party. And I'm in Michigan, so I take part in the Michigan QSO party. And the idea is to like I say, for Michigan stations to contact as many stations outside of Michigan as possible, and for stations outside of Michigan to contact as many stations inside Michigan as possible. And so, I mean, it sounds kind of dopey, and in a way it is, but it can be kind of fun too. And the exchange is just a small bit of information. For stations outside Michigan, they send a serial number and their state. Stations inside of Michigan send a code signifying the county that we're in and the serial number. So, typically a contact takes, 10 seconds, 15 seconds max, because, I'll be calling CQ. Somebody will send me their call sign. I'll send their call sign, the serial number, and the code for Washtenaw County, which is my county. And after they receive that, they know to send me their serial number and state. And then that's it. That's the contact. We're on to the next one. So the proper operation is to just send that minimum amount of information so that the participants can get on to the next contact. Because the idea is to make as many contacts as possible. So it's kind of an amusing thing. In some contests, especially VHF, UHF contests, they want a finer geographic resolution, okay? And to get that, they often use what's called Maidenhead grid locators. So what's somebody has done, and they did this in Maidenhead, England, that's why we call it the Maidenhead grid locators. They've sliced up the earth into all these different grid squares. We call them grid squares. The question calls them a grid locator, but we normally say grid squares. And like here in Michigan, you see Michigan is in the EN block there. We're actually in EN 82. And if there's a contest I'm in that requires a grid locator, I'll send EN 82, and then I'll get a grid locator from somebody else. But that's the grid locator system. Question: what is a grid locator? Answer: a letter number designator assigned to a geographic area. Another very popular thing is called fox hunting or radio direction finding. And it's not only fun, but people make a contest of it. They'll have to hide a transmitter somewhere and see if, they'll have groups that see if they can find it. The person who finds it first wins, that kind of thing. But it also has some very useful things, like if there's an interference source that you're trying to find, and you've done this radio direction finding contest, you have the skills and the equipment to find the interference, right? So that's it's useful and fun at the same time. Question: which of the following methods is used to locate sources of noise interference or jamming? Answer: radio direction finding. Question: which of these items would be useful for a hidden transmitter hunt? Answer: a directional antenna. I mean, that's how you find the source. If your antenna is pointing at the source, the signal will be strong. If it's pointing elsewhere, then it's not strong. So you want to tend to go in the direction where the signal's the strongest. All right. So let's talk a little about IRLP and Echolink and those kind of things. These operating activities use what's called voice over internet protocol. And so if you have I mentioned before that we have a repeater here that's on the Echolink system. So they're connected to the internet. And when I talk into the repeater, the computer that is connected to the repeater will digitize my signal and send a digital signal over the internet to other repeaters if I'm connected to them. And that's how it works. So there's basically two of them that use this VoIP. The Internet Relay Linking Project, which is shown in the diagram here, and Echolink, which is a similar but a little bit different system. So let's start with the question: what is voice over internet protocol? Answer: a method of delivering voice communications over the internet using digital techniques. Question: what is the Internet Radio Linking Project? Answer: a technique to connect amateur radio systems, such as repeaters, via the internet using voice over internet protocol. Question, what is required before using the Echolink system? Answer, register your call sign and provide proof of license. So the reason that you have to do that with Echolink and not IRLP is that IRLP requires a radio link. And when you're on the radio, you have to identify. So that's the story there. But with Echolink, you can access Echolink via your computer. And so before they give you an ID number, an Echolink ID, they required that you send them an image of your license and somehow prove that you're a licensed radio amateur. Question, which of the following protocols enables an amateur station to transmit through a repeater without using a radio to initiate the transmission? Answer, Echolink. Question, how is over-the-air access to IRLP nodes accomplished? Answer, by using DTMF signals. So all the nodes, and you see here there's several nodes on this little diagram, you are assigned a node number. And this remote IRLP user here, if he punches that code in for another node, he'll be connected through the internet to that node. And he does that with the DTMF pad on his HT. Question, what type of signaling uses pairs of audio tones? Answer, DTMF. And, DTMF, when you press a button, it actually generates a pair of tones. And then that pair of tones is decoded to what the number is that you press. And here's a sort of out of the blue question. What is an amateur radio station that connects other amateur stations to the internet? Answer, a gateway. So like the local node radio up at the top of the diagram might be considered a gateway. All right. Time to give away a radio, I think.
Are we there?
We are there.
Okay. Good. Okay. How much more do you have after that?
You know what? We'll be done by 5. I mean, it depends how long you take to give away the radio, but certainly be done by 5.
Yeah, that won't take long. But okay, good. All right, so I've got a screenshot here that I'm going to share with you guys right there and here of the 27 people that are currently in the webinar. It starts with, and they go in alphabetical order. So you're going to have to deal with talk to your parents for giving you a name in a certain order if you have a problem with today's drawing. So Bob, Dan, Dennis, Dwayne, Gary, Gavin, Jack R, Jared, John, Jonathan, Kelly, Lord Allen O. Patterson. That's a good one. I like that one. Michael, Michaela, Norm, Omar, Paul, Peter again, Richard, Rod, Stanley, Suzanne, Tiki, Todd, Walter, and WC371. So as you can see right here, I've pulled up the random number generator, which I use for a lot of my drawings on the when I do drawings on a live stream. And again, this is for a free Oshang KG UV9 Papa X-ray dual band amateur radio from BetterSafeRadio.com, being donated by them. And so we appreciate them sponsoring this live stream. I just got a message from Steve KL4FL. He has sent PayPal links to the ones who's registered for the test. So the test will take place in about 3 hours. And again, that's right here, hamstudy.org. I'll share the URL to that if anybody else is interested in taking a test right there. There and there. Okay, let's go back over here. And not that. Where'd it go? There it is. Okay, so 1 to 27 is what I've got here. I started at a high number, so it wouldn't start anywhere from 1 to 27. I'm going to click this one time, and that's who's going to win. 26, look at that. Walter Loney, Lougheny. Walter is the winner. So Walter, you have won a KGUV9PX dual band ham radio from Better Safe Radio. Walter, email me, send me an email, kc5hwb@gmail.com, I'll get your information. I'll get you connected to Better Safe Radio, and they will drop ship that to you. So congratulations to Walter on that. But we will be giving away one more of these radios for the next 11 months. So you guys be sure to sign up on my email list, and I'll keep you apprised of when that's happening. So I think that's it, Dan. Do you want to take another 5 or 10 minute break or what? Oh, he probably stepped away. He's probably taking his break. You guys go ahead and take 5 minutes or so, and we'll reconvene here and do the last section. So to clarify, today's drawing was just for the people who had joined the Zoom webinar, who are on it currently, because I know that there were 23 or 24 on earlier today, and there's 27 now. So I don't know if some people dropped off and more joined, or if just more have kept joining. I'm not sure. Anyway, in the future, from now on, everybody will be eligible. And the way that I run my giveaways is I've been doing giveaways once a month, every month this year for 2022, except for October. I'll be doing another one towards the end of this month. And the way I do that is I will send out an email sign-up list where you give your name and email address and call sign if you have one. And then I do a live stream towards the end of the month, and I do random number generation of people who signed up. And that's how I do drawings. So it won't just be Zoom people in the future. It was just the Zoom registrants today, but from now on it'll be everybody, and I'll keep you guys updated on how to track that. Steve, KO4AFL, I think you scheduled it for 3 hours from now, if I'm not mistaken. You scheduled it for 7 o'clock Eastern time, and it's currently 4 o'clock Eastern time. So Dan said we got about another hour to go before the class ends, the live stream ends. So if you want to update that, let me know. But if I read you've got it scheduled for 7 p.m. Eastern time, which is 3 hours from now. And just we're waiting on Dan to come back. Everybody can take a break if you want to. But I would still like to thank the sponsors of this specific live stream, Baofeng Tech, with their UV 5x3 tri-band radio, which is a really great radio. I've owned one for 4 or 5 years. Great performing radio, backwards compatible with a lot of UV5R accessories. Also, their DMR 6x2 Pro, which just came out about a month ago. Some updated features for a DMR dual band radio that will have more features added to it in the future. And of course, BetterSafeRadio.com, where they sell GMRS radios. I think they sell some CBs and stuff. Let's see. I know they sell FRS, GMRS by service here. MERS, LMR Business, no CBs, okay, and ham radios. You can get a 7% discount, anything on that site, with the coupon code of HR2all7. So special thanks to BTech and BetterSafe Radio for sponsoring this live stream. And I'm putting the links to all of these in both the chats again right now. There's that. And there's that. Okay, Steve, if you're going to update that, okay, let's just refresh that. You said you updated it just now? Let's see. All right, so we're going to do it at 5 p.m. Eastern time, immediately after this ends. So Dan said we'd be done by 5. You might want to make it like 5:30. I don't know. So we'll do the set. Steve's willing to work with us on time. We'll do the testing session as soon as this class ends, about an hour from now. backups. Oh, yeah.
I had to go check on the football game.
Oh, is that where you went?
Yeah.
Okay. That is fine. Nice.
Well, should we do it?
Yep. If you're ready, I'm ready.
All right, let's do this.
Okay.
So,
Let's,
so now we're going to get to the really boring part. The
now the
rules
really
and
boring stuff.
regulations.
Yeah. All right.
And I have no charts for this. So because and why? These questions are all memorization. So I'll discuss some of the rationale behind some of these rules, but I mean there's no calculations. There's nothing like that. So let me start out by saying that the amateur radio rules are set forth in Part 97 of the FCC regulations, and they're all it's online. There's a copy on the ARRL website. There's other places you can find it. Just put Part 97 into Google, and you'll find references to it. The first part, in Part 97.1, and I probably should have made a slide to show that. It sets forth the base. It's called the basis and purpose of amateur radio, and it lists 5 things. The first one is providing a public service and emergency communications, and then there's something about providing a pool of trained radio operators.
Hey, if you want to share your PDF file instead of the blank screen, that might work better.
Well, again, I don't have.
Okay, well that's fine.
I don't really have that. Sorry.
That's fine.
So, but yeah, you're probably right. Let me see if I can do that. Hang on. I don't have Part 97.1 in there, but you're right. Maybe that's a good thing to try here.
Yeah, just something else to share a Zoom session.
Right.
Or share a screen share rather.
But while I'm looking this up here, as I was saying, Part 97.1 is all about the basis of amateur radio. It's, providing a pool of trained operators and technicians, advancing the state of the radio art. They still call it radio art because it was written in 1934. And then the last one, which is one I really like, which they took the question out for some reason, is enhancing international goodwill. And if you think about that, that's kind of a cool thing, right? It's, radio knows no boundaries. And well, just like me, last night I talked to 3 stations in Europe. So, it's that kind of thing. All right, so I got it here. Hang on. Okay, can you see that now?
Yeah, that's good.
Good. So these are the questions about the rules and regulations. So question, which agency regulates and enforces the rules for the amateur radio service in the United States? Answer, the FCC. Which of the following is part of the basis and purpose of the amateur radio service? Answer, advancing skills in the technical and communication phases of the art. Oops, what happened there? Uh, Wait, what? How come that's doing that? Oh, so part of it is saying, well, part of the purpose of amateur radio is to, advance the state of the art, help people become better operators, and all that kind of stuff. So it's really worth reading because it's kind of idealistic and it's something to keep in mind when you're doing amateur radio. One of the big parts about Part 97 is they have lots of definitions. Obviously, if you're going to be setting rules, you want to define what those things are, right? And so Part 97 is big on definitions. So, question: what is the FCC Part 97 definition of a beacon? Answer: an amateur station transmitting communications for the purposes of observing propagation or related experimental activities. So it's not just satellite beacons. There's HF beacons around, and that's allowable under the rules to set up that kind of station. What is the question? What is the FCC Part 97 definition of a space station? Answer: an amateur station located more than 50 kilometers above the Earth's surface. And of course, the International Space Station certainly qualifies. Oh, heck. Why does it keep doing that on me? Sorry about this. So one of the things, as we talked about before, is cooperation, not interfering with other stations, blah blah blah. That's actually in the rules. So question: when is willful interference to other amateur radio stations permitted? Answer: at no time. We talked a lot about repeaters. There's parts of the rules that describe how repeater frequencies can be allotted. Question: which of the following entities recommends transmit receive channels and other parameters for auxiliary and repeater stations? Answer: volunteer frequency coordinator recognized by local amateurs. So this is actually sort of a quasi-governmental body that's formed by amateurs in a region. Here in Michigan, it's for the whole state of Michigan. And they have sort of the rule of law, if you will, on setting amateur radio repeater frequencies. Question: who selects a frequency coordinator? Answer: amateur operators in a local or regional area whose stations are eligible to be repeater or auxiliary stations. So anybody, basically that's a long-winded way of saying anybody who has a technician class license or higher. As a technician class licensee, you can set up your own repeater station if you wanted to. The only ones that can't are novices. And while there's no longer novice licenses being issued, there still are some in the database. So those folks are not eligible to set up their own repeaters or to be part of a frequency coordinator. Frequency allocations. Okay, this is sort of a big thing, right? The big thing here is you don't want to operate outside your allotted bands. Even if you're a extra class operator, you can't operate outside the amateur radio bands. So everybody's got to be cognizant of this. Question: which frequency is in the 6 meter band? Answer: 52.525 megahertz. So this is where that frequency and wavelength equation can come into play. At least help you narrow it down. Certainly allows you to eliminate C and D right off the top of the bat. And then as long as you remember that 6 meters is 50 to 54 megahertz, the answer is B. Question: which amateur band includes 146.52 megahertz? Well, again, use the other form of that equation and you realize it's 2 meters. Question, on which HF bands does a technician class operator have phone privileges? Answer, 10-meter band only. Question, which of the following frequency ranges are available for phone operation by technician licensees? Answer, 28.3 to 28.5 megahertz. Question, where may SSB phone be used in amateur bands above 50 megahertz? Answer, in at least some segment of all these bands. Question, which of the following VHF, UHF band segments are limited to CW only? Answer, 50.0 megahertz to 50.1 megahertz and 144.0 megahertz to 144.1 megahertz. So just, for this question, remember it's the bottom of the band. This is not another one of these silly questions in my point of view. How many amateurs use the 219 to 220 megahertz segment of the 1.25 meter band? Answer, fixed digital message forwarding systems only. I don't know about you, but I've never heard of anybody having a fixed digital messaging forwarding system on the amateur bands. Question, why should you not set your transmit frequency to be exactly at the edge of an amateur band or subband? Answer, all these choices are correct. To allow for calibration error in the transmitter frequency display, so that modulation sidebands do not extend beyond the band edge, to allow for transmitter frequency drift. And all these three, if any one of them happen, part of your transmission might be outside the amateur band. So that's the key point there. So let's see a question. Oops. Now you got a question in the Q&A section, Jason.
Okay, I'll get it. Thanks.
All right. So some of the bands that we have, we're actually secondary operators. And what does that mean? That means we have to defer to the primary service that's using that band of frequencies. And it's not such a big deal. I've never really come across any place where it was a problem, but something to be cognizant of. In the 440 megahertz band, there are some kind of restrictions in some portions of the bands. Anyway, the question is, how are U.S. amateurs restricted in segments of bands where the amateur radio service is secondary? Answer, U.S. amateurs may find non-amateur stations in those segments and must avoid interfering with them because they are the primary users, we're the secondary user. Question, except for some specific restrictions, what is the maximum peak envelope power output for technician class operators using frequencies above 30 megahertz? Answer, 1,500 watts. That's a lot of power. I appear on the ICQ podcast, and it's run by a couple of British guys, and sometimes we talk about licensing, and their initial class is called the foundation class license, and those folks are restricted to like 20 watts, no matter where they operate in the spectrum. So we always have a laugh when I say, yeah, technicians here can operate 1,500 watts. They just can't conceive of that. Question, what is the maximum peak envelope power output for technician class operators in their HF band segments? Answer, 200 watts. So you can only operate 200 watts on 10 meters and 15 and 40 and 80. We talked a little bit about this before. For which license classes are new licenses currently available from the FCC? Answer, technician, general, amateur, extra. So there are still some novice licensees in the database, and there are still some advanced class licensees in the database. My call sign, I was assigned my call sign when I upgraded from general to advanced many moons ago. And even though I'm an extra class licensee now, I decided to keep my call sign. Before I took the extra class license, or took the extra class test, I used to joke that I was never going to upgrade to extra because I wanted to be the last living advanced class licensee. And then I started selling licensed study guides. I figured, well, I better upgrade because who would want to buy a study guide from a guy who only has an advanced class license? So that's why I upgraded eventually. Question, what is the normal term for an FCC issued amateur radio license? Answer, 10 years. So it's good for 10, it'll be good for 10 years. Question, how soon after passing the examination for your first amateur radio license may you transmit on the amateur radio bands? Answer, as soon as your operator station license grant appears in the FCC license database. So that's the determinant factor now. They don't send you any paper. You just have to keep watching the website, their FCC website, to see when they finally issued your license. And it should be pretty fast. Everything is really fast nowadays. Question, how many operator primary station license grants may be held by any one person? Answer, 1. So you only get one license. You know, in Canada, this is talking about differences in countries. In Canada, you can have like, I don't know, quite a few actually. I don't know what the reason for that is, but you can have multiple call signs in Canada for some reason or another. Question, what proves that the FCC has issued an operator primary license grant? Answer, the license appears in the FCC ULS database. So that database really is the thing. So after you pass the test and you get into the FCC database, they'll give you just whatever is next sequentially in the pool of call signs. But you can choose your own call sign through the vanity license program. And as long as nobody else is using that call sign, you can request it. There's some as a technician, there's certain things you can't request. Like you can't request a 2x1 call sign or a 1x2 call sign. And by that, I mean, the 2 stands for letter, the numbers stand for letters, and the X stands for the number. So like it says in the study guide, a 2x1 call sign would be KA1X, and a 1x2 call sign would be W1XX. So you can't request those, but you can request just about any other kind of call sign. So a lot of techs will look for call signs with their initials or whatever, and you can do the 1x3s, which is popular. So who may select a desired call sign under the vanity call sign rules? Answer, any licensed amateur. Question, which of the following is a valid technician class call sign format? Answer, KF1XXX. I don't know how they chose that. And I don't know how KF1XXX will feel about it when it's assigned, but anyway. So you get the license for 10 years, and if it expires, if you allow it to expire, although there's really no reason to not renew it. It used to be free, now it only costs $35, but the renewing is very easy. You just go to the FCC website and tell them you want to renew it, and they'll renew it for you. But if you don't happen to renew it, you still have a grace period during which you can reclaim your call sign. That's a 2-year grace period. So question, what is the grace period for renewal if an amateur license expires? Answer, 2 years. If your license has expired and is still within the allowable grace period, may you continue to transmit on the amateur radio bands? Answer, no. You must wait until the license has been renewed. So even though you're in the grace period, you're not in the grace period for having a license. You're just in the grace period for being able to renew it. And also the grace period for renewing it without having to take the test. If you wait too long, so that you're out of the grace period, you exhaust the 2-year grace period, then you have to retest to get your license back. Clubs can apply for station for call signs. Our club here in Ann Arbor actually has 1, 2, 3, at least 3 club call signs. Question: which of the following is a requirement for the issuance of a club station license grant? Answer: the club must have at least 4 members. So the reason there's this rule is they had hams who were saying, "Oh yeah, I'm a club, give me a call sign," and then they would amass, several call signs and then use them whenever they wanted to. So that was kind of outside the rules. So they changed that, so you couldn't do that anymore. Which of the following can result in revocation of the station license or suspension of the operator license? Answer: failure to provide and maintain a correct email address with the FCC. So why is that? That's because they have to be able to get in touch with you if there's some reason, like if somebody reports you for causing interference, that they have to be able to get in touch with you. If they can't get in touch with you, either because your email address is no longer valid or you just don't respond to it, which they'll consider to be invalid, then they can revoke your license. And I knew somebody whose license was revoked because they moved and they never registered the new address with the FCC. Yeah, somebody says, before closing, can you expand the 2x1 and 1x2 call sign definition? Okay, in fact, let me answer, get to the end of this page and I can do that. Question: from which of the following locations may an FCC licensed amateur station transmit? Answer: from any vessel or craft located in international waters and documented or registered in the United States. So any U.S. vessel is considered to be under FCC jurisdiction as far as telecommunications goes. And so FCC rules apply, and so you can use your call sign from those stations. So let's take a step back and talk about the call signs. So sometimes we use the shorthand 1x2, 2x2, 1x3, 2x3, and these are all different combinations of call signs. U.S. amateur radio call signs either start with A, N, K, or W. A 1x2 call sign will have one of those letters before the number, and then so many letters after the number. So a 1x3 call sign might be N1ABC. So that's 1x3, N number 3. My call sign, KB6NU, is a 2x2 call sign, right? 2 letters, number 2 letters. They opened up, when they put in this vanity call sign, they opened up the 2x1 call signs too. And the whole idea here is they have short call signs, right? Is that, if you're in a contest, having a short call sign can be an advantage because it doesn't take you as long to send your call sign. So an example of a 2x1 call sign would be KA1X. That was in the study guide. So I hope that explains it. And also, as a technician class operator, you can request any combination except 2x1s, 1x2s, and 2x2s. You can't do the 2x2s either. So you can't request KB6NU and KB6NW. Authorized transmissions. Question: what, if any, are the restrictions concerning transmission of language that may be considered obscene or indecent? Answer: any such language is prohibited. Then the question is, what is indecent or obscene? I think they use the Supreme Court definition that you know it when you hear it. Question, under what conditions is an amateur station authorized to transmit music using a phone emission? Answer, when incidental to an authorized retransmission of manned spacecraft communications. That's the only time. You know, if your mother was a ham radio operator and it was her birthday, you couldn't sing happy birthday to her over the repeater. Because while your fellow hams may not consider that to be music, the FCC will consider that to be music. Now, here's another interesting part of this question. It says using a phone emission, right? So you could actually send an MP3 file of happy birthday to your mother over ham radio, and which she could then play at her house. But you didn't send it using a phone emission over ham radio, so that's allowed. The whole situation here is because they didn't want amateur radio to be competing with commercial radio back in the day. So we're still sort of stuck with this kind of rule even today. Question, when is it permissible to transmit messages encoded to obscure their meaning? Answer, only when transmitting control commands to space stations or radio control craft. So this is the encryption rule, okay? And so there's no encryption allowed except when transmitting control commands. And of course, you would want it then just so that you know, your craft or your space station doesn't accidentally crash. Question, with which countries are FCC licensed amateur radio stations prohibited from exchanging communications? Answer, any country whose administration has notified the International Telecommunications Union that it objects to such communications. Now, there currently aren't any countries in that bailiwick. There have been in the past, but we don't. There's none now. Of course, some of these countries they don't have any ham radio operators anyway. You're not going to have any luck, for example, trying to contact someone in North Korea, because there just are no ham radio operators in North Korea. Question, if a family member that held a license, however, has died, can a new license holder request to obtain their deceased family's call sign? And the answer to that is yes. And so, and they can do that before the 2-year grace period is up. So normally, if an amateur dies, even if they pass, that call sign is not made available until 2 years after they passed. But a family member could request that call sign before that 2 years is up. In fact, we did something similar to that at the Hands-On Museum. One of the fellows who was instrumental in setting up the Hands-On Museum was a professor at U of M, and he passed away, and we wanted to get his call sign as a memorial to him. And we were able to do that because a family member interceded on our behalf and allowed us to get that before the 2-year grace period was up. So yes, that can be done. So one of the big deals in ham radio is not getting paid for operating a station. But like everything, there's the exception that proves the rule. Question, in which of the following circumstances may the control operator of an amateur station receive compensation for operating that station? Answer, when the communication is incidental to classroom instruction at an educational institution. And I actually did receive compensation for operating an amateur radio station. I was sort of like the mentor for a middle school amateur radio club, and they paid me to do this, and I operated a station occasionally. So I was actually paid to operate an amateur radio station. But in general, if your uncle is a ham, he can't say, "Hey, come on over and operate my station. I'll pay you to do it." You can't do that. Question, when may amateur radio operators use their station to other amateurs of the availability of equipment for sale or trade? Answer, when selling amateur radio equipment and not on a regular basis. Okay, so what does that mean? That means I can get on the repeater and say, hey, I've got a Baofeng here I want to get rid of. Somebody, the first $20 takes it. That would be fine. But I can't get on the repeater and say, hey, I just got in a new shipment of Baofengs and they're going for $25 each. Because in the one case, I'm just selling stuff I have. In the second case, I'm selling it as a business. So you can't do that. You also can't get on there and say, hey, I got a microwave I want to get rid of. Anybody got $20 for it? Because it's not amateur radio equipment. You can only sell amateur radio equipment. Broadcasting. In amateur radio, we don't broadcast, we transmit. What's the difference? Broadcasting are transmissions intended for the general public. In transmitting, we're transmitting station to station. So question, how does the FCC define broadcasting for the amateur radio service? Answer, transmissions intended for reception by the general public. And like I say, broadcasting is not permitted. So, I'll get that every once in a while. People will say, well, on what frequencies do you broadcast on? I say, no, we don't. We never broadcast. We transmit. Question, under which of the following circumstances are one-way transmissions by an amateur station prohibited? Answer, broadcasting. So that's another reason. Most transmissions are two-way transmissions. Not all of them, but most of them. And broadcasting is a one-way transmission. Question, when may amateur stations transmit information in support of broadcasting, program production, or news gathering, assuming no other means is available? Answer, when such communications are directly related to the immediate safety of human life or protection of property. That's the emergency communications catch-22. Question, what types of international communications are FCC licensed amateur radio operators permitted to make? Answer, communications incidental to the purposes of the amateur radio service and remarks of a personal character. I don't know how to interpret this question, but I don't know that that's, I guess it's in the rules. There's the rule section there, but that's pretty vague. Control operator and control point. So this is one of those things that's sort of another principle of amateur radio. Every station must have a control operator, and basically where that control operator is the control point. And the control operator is always responsible for the proper operation of the station. That's sort of the real important point. So question, when may an amateur station transmit without a control operator? Answer, never. Who does the FCC presume to be the control operator of an amateur station unless documentation of the contrary is in the station records? Answer, the station licensee. So if your name is associated with that call sign, you're responsible. Who must designate the station control operator? Answer, the station licensee. So I can designate somebody to use my station or be the control operator for my station, should I so desire. When the control operator is not at the station licensee, when the control operator is not the station licensee, who is responsible for proper operation of the station? Answer, the control operator and the station licensee. So even if you designate somebody else as the control operator and go on and play golf or something, you're still on the hook because you're the station licensee. You can't shirk your responsibility there. Who is accountable if a repeater inadvertently retransmits communications that violate the FCC rules? Answer, the control operator of the originating station. So somehow repeater operators were able to finagle this point in the rules to get off the hook should somebody start doing bad things on a repeater. When under normal circumstances may a technician class licensee be the control operator of a station operating in an amateur extra class band segment? Answer, at no time. So even if I designated you as the control operator, you're operating my station and I'm an extra class licensee, that really doesn't mean anything. That you can still only operate it with the privileges assigned to you as a technician. Of course, if I was here, supervising you, then all bets are off. Then I'm really the control operator and you can do anything you want. Within reason, of course. Question, who may be the control operator of a station communicating through an amateur satellite or space station? Answer, any amateur allowed to transmit on the satellite uplink frequency. And again, that's sort of a fine point there because novices aren't allowed. Other than that, all amateurs are allowed to operate through the satellites. Control point and control type. This goes along with who's the control operator now. Question, what is an amateur station's control point? Answer, the location at which the control operator function is performed. Question, which of the following is an example of remote control as defined in Part 97? Answer, operating the station over the internet. So let's say I was operating my station remotely on my cell phone, which you can do. There's apps that allow you to do this. Well, I would be the control operator. I'm doing a remote control because I'm not at the station, but the control point is where I'm standing with my cell phone. So that's the ticket there. Question, which of the following are required for remote control operation? The control operator must be at the control point. That's sort of a truism. Wherever the control operator is, that's where the control point is. A control operator is required at all times. That's by law, right? That's by the rules. The control operator must indirectly manipulate the controls. Well, if you're doing this on your cell phone, you're indirectly manipulating the controls. And actually, I would maybe even posit that. So I have a flex radio, and it's all software-defined radio. I would say maybe I'm even doing remote control even when I'm just in my shack. I never thought of that. I'll have to think about that some more. Question, which of the following is an example of automatic control? Answer, repeater operation. And it's automatic control because the computer is actually controlling the operation of the station. Station identification. This is another big thing in the rules. Basically you're required to identify every 10 minutes. Question, when are you required to transmit your assigned call sign? Answer, at least every 10 minutes during and at the end of a communication. And actually, this is kind of an interesting point. So when you start talking to somebody, you don't have to identify yourself. So I could get on the repeater, say, hey, Ralph, are you there? You could say, hey, Dan, yeah, I am. And we could talk for 10 minutes before identifying ourselves. Even though the practice is to identify, usually identify at the start, you really don't have to do that. Question, when may an amateur station transmit without identifying on the air? Answer, when transmitting signals to control model craft. So usually what people do is they put their call sign on the control box, and that stands for suffices for identification. Question, what language may you use for identification when operating in a phone subband? Answer, English. You can speak any language you want or that you know, but you have to always identify in English. Question, what method of call sign identification is required for a station transmitting phone signals? Answer, send the call sign using a CW or phone emission. So you can say your call sign, or you can have a little device that automatically identifies you in CW if that's what you'd like to do. What do the FCC rules state regarding the use of a phonetic alphabet for station identification in the amateur radio service? Answer: it is encouraged. And it actually says that in the rules, that they encourage you to identify using a phonetic alphabet. Question: how must you identify with your FCC assigned call sign when using tactical call signs such as race headquarters or like net control station or something? Answer: at the end of each communication and every 10 minutes during a communication. So again, that's the rule. Question: which of the following self-assigned indicators are acceptable when using a phone transmission? Answer: all these choices are correct. KL7/W3, KL7 slant W3, KL7CC stroke W3. So, and what that means is that, so KL7 is a call sign usually signifying that somebody is in Alaska. But let's say they were visiting a friend in Pennsylvania, and that Pennsylvania is in the 3rd call district. So they could signify that they were in the 3rd call district by using one of these self-assigned indicators. Third-party communications. Third-party communications is when you're using your station to communicate with someone on behalf of someone else. That someone else is the third party. So question: what is the definition of third-party communications? Answer: a message from a control operator to another amateur station control operator on behalf of another person. And this used to be a big deal in previous years because, we didn't have cheap phone service then, right? And so sometimes amateur radio operators would use their stations to patch into the phone systems in different places and go around the long distance phone system. Nowadays, you pick up a cell phone and talk anywhere, but for nothing. It's like, that's not such a big deal anymore. Question: which of the following restrictions apply when a non-licensed person is allowed to speak to a foreign station using a station under the control of a licensed amateur operator? This is another example of third-party communications. Answer: the foreign station must be in a country with which the U.S. has a third-party agreement. And before you do this, or if you ever want to do this, you really should check, because countries you think we should have third-party agreements with, we don't. For example, we don't have a third-party agreement with Germany. So if a friend of yours has an aunt in Germany, you can't use your amateur radio station to make a contact and have your friend talk to her aunt, because that's third-party communications, and we don't have a third-party agreement with Germany. Why is that? Well, the Germans collect taxes on long-distance phone calls, at least they used to, and so they didn't want the hams to be going around that system so that they couldn't collect the taxes. And finally, the last question. Whoops. Sorry about that. When must the station and its records be available for FCC inspection? Answer: at any time upon request by an FCC representative. So they're not going to, knock on your door at 2:30 in the morning and demand to see your station, but they'll request it, and then you have to let them in at some point in time so that they can inspect your station. And what they're up to is just to ensure that you're operating legally, you're not operating too much power, you're operating on the proper bands. That's that kind of thing. Personally, I've been a ham for 50 years. I've never known anybody that's had a request like this, but again, it's possible. So I told you we'd be done by 5. Any questions? Kelly Sharp. Kelly Sharp, go ahead. Oh.
Where do you see that?
He or she raised their hand, and
let me
says talking permitted.
Yeah.
Can you? Kelly?
Yeah, Kelly, you should be unmuted and able to speak now.
Well, maybe not.
You can type it in the Q&A if you'd rather do that too.
Yeah, you type it in the Q&A if you want.
Good. John
says, much thanks for taking the time today. My pleasure.
Yep. It was a good information for sure. So I created a Zoom session that I'm going to give to Steve, KO4AFL. If you signed up, you should have gotten emails from him with PayPal links for the $10 service charge to take the test, and he should be sending out. Okay, he just posted in the chat. He will send out the Zoom link once the VEs are on board and ready. So I'll have to wind this down before I can start that one because we're using the same Zoom account to do that. So, Rod, thank you for being here. Any other questions or anything?
Well, like I say, if you have questions that come up later, I know it's a lot of material. If you have any questions that come up later, please feel free to email me.
Kelly posted in the the YouTube chat saying, just wanted to say thanks. Long day, but worth it.
So it was a long day.
Yeah,
this is the first time I did the whole thing in one Zoom session. So
yeah. Well, you did well. I mean, honestly, we ended earlier than I thought we were going to.
Me too. Although, this is a little bit different than in person, but not too much different. So it usually takes me 6.5 hours, and we've been at it not quite 7. So
right, yeah, yep, good, okay. Well, we will wind it down. I'm getting a lot of thank yous here, so thank you guys for joining today. Thank you for attending. If you do have any questions, and those of you on Team Replay, if you're watching this later on, sometime after it was live, you can always comment on the YouTube video. You can send an email to myself or to Dan. Dan's had I've known Dan for more than 10 years. He's had the same email, so I don't think he's going to change anytime soon.
I'm not planning it.
Yeah. So, feel free to reach out if you have any questions, comments on anything, and check the links. I will update the YouTube description here later on this evening with all the links that we spoke about today, including our sponsors. If you end up buying something from one of the sponsors, be sure and thank them for sponsoring this session, just to let them know that's where you heard about it from. And I'll also share the links for the general and extra classes which exist on this channel already. And when the general pool updates next year, we'll do something with the updated general pool. Dan, have you ever done a one-day general class?
I have not. Although there's a friend of mine here in Michigan who's done them, and we could think about doing that.
We can. Well, we got a whole year, so that's fine. Yeah. I imagine the extra would be too long to do in one day, but the general and technician pools are usually about the same number of questions and whatnot. So
and what these guys did was they made it really more of a review than anything. They said, read this stuff, and then we'll do this one day thing, and it'll be just really review.
Well,
so that's kind of a possibility.
Yeah, that's a good idea. Sure. Okay. Well, 73 to all. Thank you very much. Those of you who are going to try the test tonight, good luck to you, and wait for the email from Steve, and we'll get you guys in there as soon as possible. So, Dan, thank you again for your time today, and this was a really good session. I really enjoyed listening to it.
Good. Thanks, everybody, for attending.
Yep. Thanks a lot, guys.